So you've learned the basics of Spring Boot, and maybe you've built a few simple apps. How about something a little more advanced? In this video, we're going to build a restaurant review platform, where diners can leave reviews for restaurants they have visited. Together, we'll build the Spring Boot backend that integrates with Elasticsearch. I'll guide you through that process step by step, and even provide the same front-end source code that I am using. The Devtiro community is now on Discord, so you can grab the PDFs of the written materials and the source code all from there. There is a link in the description below and you join the community for free. Okay then, let's get started. In the upcoming lessons, we'll be focused on building an application rather than discussing the theory in detail. So a foundational knowledge of certain subjects will help you to get the very most out of this project. As a means of explaining the levels of understanding I suggest for this build, we'll use this simple scale. The scale has 3 levels. Level 1 is describe. You're able to recall the basic facts and concepts about a particular technology or tool. Level 2 is explain. You can explain the ideas or concepts about a technology or tool in your own words. And level 3 is use. You can use that technology or tool in different situations without any support. So now that we have this ranking system, let's go through the prerequisites for this project. To follow along with this builder, I suggest the following prerequisites. Java Level 3 Use. You should be very comfortable with Java. We won't be going into any details as to use the Java programming language. That will be assumed. Maven is also Level 3 Use. We won't be going into any details on how to use Maven in this project. So Spring Boot is also Level 3 Use. You should be comfortable with Spring Boot. Although I'll explain the specifics of what we're doing at the time, that foundational knowledge of Spring Boot is assumed and you'll need it for this builder. If you're unsure on whether or not your Spring Boot knowledge is level 3, then I'd recommend checking out the Task Tracking App Builder or the Blog Platform Builder before attempting this project. Spring Security is also level 3 Use. We'll be using Spring Security in this project, but I won't be going into great detail as to how Spring Security works. This is assumed. If you'd like to learn a little bit more about Spring Security before attempting this project, then I'll leave the details in the notes below. Keycloak is also level 3 Use. We'll be using Keycloak with Spring Security in order to implement authentication for this project. I won't be going into a lot of detail as to how Keycloak works. That knowledge will already be assumed. Docker is also level 3 Use. We'll be using Docker in order to run Keycloak and Elasticsearch in this project. So it's assumed that you're already comfortable using Docker. And now Elasticsearch, which I've put as level 1 Describe. Although we'll not be diving deep into Elasticsearch in the same way that we would do in a dedicated course, we will focus on using Elasticsearch in this project. Therefore, a level 1 understanding of Elasticsearch should be enough to start this project, aiming for a level 2 or level 3 understanding by this project's end. And for Node, I've put level 1 Describe. Of course, this project is focused on building a Spring Boot application. However, I do offer the same front end that I use, which is Next.js. We'll be using Node and the Node Package Manager to install the dependencies for the front end and also to run the front end. You don't necessarily need to know how to build a Next.js app, but it would be beneficial to know what Node is and what it means to use npm, and you should get this information from the Node website. Of course, I'll give you the commands that you need to run in order to run the front end, so a level 1 Describe for Node there. As an intermediate project, the prerequisites list is a little bit longer. However, if you're comfortable with what you've seen here, then let's move on and build ourselves a restaurant review platform. Let's now cover setting up your development environment for this project. To build the restaurant review platform, you will need Java 21 or later. You can check your Java version by opening up a terminal or a command prompt and typing java-version, just a single hyphen, and you should get an output that looks like this. If you don't see Java version 21 or later printed out here, then I'd recommend downloading a later JDK. You can get this from Oracle or the Eclipse Foundation or any number of JDK providers. And now for Maven. We'll be using Apache Maven to manage our project, although you don't need to install this on your system, as an instance of Maven will come bundled with your Spring Boot project. So no need to install Maven, but if you do have an installed instance, do feel free to use it. And now for Node. To run the front-end code I'll provide, you'll need Node version 20 or later. You can check your Node version by opening up a terminal or a command prompt and typing node-version, and you should get a printout that looks a little bit like this. Note that it's 2 hyphens before version for Node, but only a single hyphen before version for Java. If you don't have Node version 20 or later, then I'd recommend going over to the Node website and downloading a later version. And now for Docker. In order to run Elasticsearch and Keycloak, which we'll need later, you'll need Docker installed on your machine. To check that you have Docker installed, open up a terminal or a command prompt and type docker ---- version, and you should get a printout that looks a bit like this. Otherwise, head over to the Docker website, which will guide you through installing Docker. And now for our IDE. I'm going to be using the community version of IntelliJ IDEA as the IDE for this project. You are of course welcome to use any IDE that you like, such as VS Code, but I recommend IntelliJ as it's great for Java development. And if you like, you can download the community version of IntelliJ IDEA from the JetBrains website, completely free. In this module, we'll examine what we're going to build. We'll look at the project's requirements, understand the domain model, explore the user interface, and review the system's architecture. The goal of this module is to give you a clear picture of the project before we start building it. So the module is structured as follows. We'll start with the project requirements and goals. We'll then look at the domain objects and their relationships. We'll look at the user interface design and flows. We'll look at the system architecture and components. And then we'll look at the REST API's design and the endpoints that we're going to implement. So now for the learning objectives. So by the end of this module, you'll be able to describe the requirements of the project we are going to build. Describe the domain objects we'll use to build the app and their members. Describe the screens of the user interface, how it works, and how it delivers on the app's requirements. Describe the components of the project and how they fit together. And describe the design of the REST API our project will use. So with this covered, let's get started. So now that we have a working development environment, let's take a look at the project that we're going to build, starting with the project brief. So here we are on the Devtiro community site, and I've opened up the Restaurant Review Platform project brief. So let's go through this. So let's start with the summary here. We're building a web-based platform that enables users to discover local restaurants, read authentic reviews from other diners, and share their own dining experiences. So straight away, I'm picking out words like restaurants and reviews and diners, which appears to be a type of user. And these diners can share their own dining experiences through detailed reviews and ratings. And that helps others make informed decisions about where to eat. So already quite a lot of information in here. So let's read a little bit more about our definitions. So a restaurant listing, and that's a dedicated page or entry containing information about the restaurant. And then we have a list, essentially, of attributes for our restaurant. So name, location, cuisine type, operating hours, and contact details. And then we have some more information about the review here. A user submitted assessment of their dining experience, and it includes written feedback and a numerical rating. So that helps to flesh out what the review actually is. And then we have more information about the rating here, a numerical score, typically on a scale of 1 to 5 stars, which is typically what we've come to expect from review platforms nowadays. So let's now look at the user stories. Now, if you're not familiar with this pattern, a user story essentially describes a requirement of the system, but from the point of view of the user. And that adds additional context, which, as developers, helps us to make decisions. So we won't go through these word by word, but let's just go through them to get the gist of things. So this is about viewing the restaurant details. So diners want to see detailed information about restaurants in my area. So the phrase "in my area" immediately tells me that we'll be working with some form of geospatial data here, so that I can make informed decisions about where to eat. So now we have some acceptance criteria, which are statements which can either be true or false. And when all of these statements are true, then we say that the user story is complete. So 1 lists the information that we'd expect to be displayed. A restaurant should have an average rating. So that tells us that a restaurant can have many reviews. Each review has a rating, so we need to take an average at some point. The restaurant contact information is clearly visible. Photos of the restaurant are displayed when available. So that tells us that we'll need to implement some form of image upload and display. Users can see their restaurant's location on a map. Again, that confirms that we'll be working with geospatial data. So we scroll down here, read restaurant reviews. So as a potential diner, I want to read reviews from other customers so that I can learn about others' experiences before visiting. So whereas this first user story here is all about displaying the restaurants, now we're talking about the reviews. So reviews are displayed in chronological order. So that tells us that we need to capture the date that the review was created. Each review shows the author's name and date posted. So that tells us that we need a link between the author user and the review. The reviews display both the written feedback and the numerical rating, so that just confirms what we already know about what's contained within a review. Users can sort reviews by rating or date, so that's some sorting functionality, and Elasticsearch will make that rather easy to implement. And the total number of reviews is clearly visible. So we'll need a count of the total reviews. That's all fairly straightforward. So now submitting a restaurant review. As a restaurant customer, I want to share my dining experience through a review so that I can help others make informed decisions. So whereas the first user story was about listing restaurants, and the second one was about listing reviews for those restaurants, this third one here is about creating a review for a restaurant. So let's look at the acceptance criteria. Users must be logged in to submit a review. So that tells us that we'll need to implement authentication. A review form includes a text area for written feedback. So that confirms what we know about a review, that it has this text component to it. Users can select a rating from 1 to 5 stars. Users can submit photos. So again, that confirms the image upload. Users cannot submit multiple reviews for the same restaurant. So that's business logic that we need to implement. And users can edit their review within 48 hours of posting. So that's some more business logic, which again confirms that we'll need to capture when that review was created. And then we have some bonus features at the end, which we'll not implement in this particular build. So the user stories that we have here at a high level are being able to view the restaurant details, being able to read the reviews, and being able to submit the reviews. Everything that you would expect from a restaurant review platform. So now that we understand the project brief at a high level, let's now analyze it for our domain objects. So now that we've explored the project brief at a high level, let's now analyze it for our domain objects. So here we are back on the community site with our project brief. Let's look to identify the domain objects that will then make up the domain of the application that we are to build. So first and foremost, we're referring to users. And what's more, if we scroll down to the submission story here, the user must be logged in order to submit a review. So that tells us straight away that we are working with a user. So if I just grab a notepad here, we're working with a user object. Now, of course, this is a restaurant review platform. So we'll almost certainly need to model the restaurant in some way. And we can see here, particularly on this view restaurant details story, that a restaurant has a display name, address, cuisine type, and operating hours. So at a high level then, let's just note down that we have a restaurant domain object to work with here. Now a user will view restaurant details. However, they will also be able to submit a restaurant review. So we'll almost certainly need to model this review object in some way. So let's note that down as well. Now, if we were to explore the details of the review, and this story does so rather nicely, it mentions here that users can submit a photo with their review. Now, although we could represent a photo as a URL to wherever that photo is stored, we should probably store some additional metadata around that photo. Maybe a caption for that particular photo, or even just the date that it was uploaded. So I think photos, again, makes another object that we should model in our domain. So let's add that to our list. Now, as for the text area, I think that will just be a property of the review object, as would be the rating. So I think we'll call it there for review, and perhaps explore the restaurant a little bit further. So we know that a restaurant will be linked to a user who created that restaurant. It will also have a name, cuisine type, an address, operating hours, etc. Now, whereas a display name could just be represented as a string, an address is a little bit more complicated. So we should probably represent an address object with properties like street number or street name or city, for example. So let's add that to our list of objects. Now, whilst we're on the topic of address, we have here that users can see the restaurant's location on a map. So we need to represent the geolocation data of the restaurant as well. So the latitude and the longitude. So let's say geolocation as an object that we need to represent as well. And that will be linked to the address. So we could make that a nested object. But again, we'll explore that a little bit later. Now, we also have this concept of operating hours. And I'm not sure that we can represent that in a simple way. So we're going to have to create an object to represent that, as it's a bit more complex. Of course, there could be different operating hours for different days. The restaurant may be closed on some days and open on others. So let's put operating hours as an object that we'll need to model. So let's just scroll up to the definitions here. So we have a restaurant listing. We've represented the restaurant as an object, the review as an object, rating is a property of review. And if we just briefly look through, I think we've got all of the high level objects. And again, we'll not do the bonus features in this particular case. So the approach has been nothing fancy. We've looked through this brief for nouns that we believe could represent complex objects in our domain. And in doing so, we've also identified that these objects can have certain properties. For example, our review has a text component and it also has a rating component. So the next step is for us to consider the relationships between these different domain objects. And let me show you what I've come up with. So here we have a class diagram of my current understanding of the system. So let's go through this. At the very top, we have our restaurant with its ID, the name of the restaurant, the type of cuisine that restaurant serves, contact information, an average rating, and then the geolocation, so where that restaurant is located in the world. And then we have several other objects which are nested inside of restaurant. So let's start from the far left with operating hours. So the operating hours, as you can imagine, represents the operating hours of the restaurant, when the restaurant opens and closes each day. I've thought about the best way to represent this, and in the end, I went with this approach. So we have an operating hours object, and that represents each day of the week, Monday to Sunday. And then we've represented the opening time and close time as a separate object, the TimeRange object, which we can see down the bottom there. Now I've chosen to represent the times as just plain strings, and that will make things a lot simpler for us. And because we're not needing to do any logic based on the opening time and closing time, we can use a string. We don't need to use, say, a local date time object. So TimeRange is used to represent the open and close time each day, and then operating hours represents the full week, Monday to Sunday. A restaurant also has an address with a street number, a street name, unit, city, state, postal code, and country. A pretty standard address object, nothing too special there. A restaurant also has a relationship with a user. A user creates a restaurant. And we can see here that demonstrated by the created by relationship. The user itself has an ID, a username, a given name, and a family name. This is the information that we'll get from Keycloak when the user authenticates for the first time. So a user creates a restaurant. Now, a restaurant also has reviews, with each review having an ID, some content, so what the user has actually written, a rating, which is an integer, so a number between 1 and 5, representing how many stars the user has given that restaurant. And then we have a local date time for the date the review was posted, and a local date time representing when the review was last edited. We also have a relationship between user and review here, with a user writing a review. And finally, we have the photo class on the far right. And we can see relationships between restaurant and photo and review and photo. And that's to say both a restaurant and review can have photos. The photo itself has a URL to where the photo is located. And then we have a local date time, which is the upload date to the date that photo was uploaded. This domain model has been influenced by the fact that we're using Elasticsearch. And I even used the word nested earlier. What that means is that we'll have a single index in Elasticsearch, the restaurants index. And in there, we'll store restaurant documents. How that will look is the restaurant object will contain operating hours, address, review, and photo. They'll all be nested. And where there's a two-level relationship, for example, restaurant operating hours, TimeRange will be nested in operating hours, and operating hours will be nested in restaurant. This approach certainly has its trade-offs, however, is a fairly standard approach when using technologies such as Elasticsearch. In this lesson, we'll explore the platform's user interface. So here we are on the user interface, and we'll be using this when we build our restaurant review platform. So let's take a look through this. So in the top right here, we have a login button, and that will allow us to log in, but we'll not do that right now. If we scroll down, we have a search bar, and then we have some filters by stars, and we have several cards for different restaurants. Please note that every single restaurant here is completely fictional and has been randomly generated. So any resemblance to a real restaurant is complete coincidence. So here we have all of our restaurants, and we can see on each card we have an image, the name of the restaurant, the location, we have the star rating for any reviews that restaurant has received, and then we have the cuisine that restaurant serves. If we scroll back up to the top here, we have our search bar. So let's say we wanted some Greek cuisine. So if we were to type Greek in here, it returns the Greek house. If we remove that, then we get all of our restaurants back. We also have the star filter as well. So only show me restaurants with 2 stars or greater, 3 stars or greater, 4 stars or greater. And if we scroll down to the bottom, we have pagination as well. So we're supporting pagination. So there are more restaurants on the second page. So if we take a look for a restaurant that has some reviews, let's go with the Golden Dragon here. So here we have the restaurant's details page. So we have the restaurant's image, we have a map to the restaurant. It should be noted that this is a randomized map somewhere in London. Of course, as this restaurant is fictional, it doesn't have a real location, so we're just going to randomize that. We have the name of the restaurant, where it can be located, the cuisine that it serves, and then a randomly generated telephone number. Again, this isn't a real telephone number. It has been randomly generated, so please don't call these people. So we have here the average rating, the number of reviews that the restaurant has received. We scroll down, we can see some restaurants nearby. So although this map uses a random location, each of these restaurants does have a location stored in Elasticsearch, and these are the restaurants that are near this particular restaurant. It should be noted that the Golden Dragon does also appear in this list, which goes some way to prove that these restaurants are located near the Golden Dragon. So now we have reviews. So if we scroll to the top here, we have 2 reviews for this restaurant. There's a review, there's another review. We can see each review has an image, a star rating, the date that the review was posted, and then we have the username of the user that posted that review. We then have this button here where we can order the reviews, newest first, oldest first, and we can also go by highest rating and lowest rating. Now on this page as well, we can also write a review. This is going to require us to sign in, so let's do that now. So we're signed in now. We have this little U in the top right-hand corner because I'm signed in as the test user, U for user. So if we continue through to write a review, we're able to give a star rating, give the review some content, upload a photo, and then submit the review. But if we go back to the details page, we now have several extra buttons. We can edit the restaurant using the update a restaurant form here. We can delete the restaurant. We'll not do that, but clicking delete will delete the restaurant. And if we scroll down, we can edit and delete the reviews as well. So if we scroll up, we've seen how we can edit an existing restaurant. So how do we create one? Well, if we click on our user icon up here, we can go to the add a restaurant form and we see the form to add a restaurant. So in summary, that is the restaurant review platform user interface that we're going to use to build our Spring Boot application. So in summary, the homepage displays restaurant cards with images, ratings, and cuisine types. The restaurant details page shows a location map, reviews, and a review submission form. We have search functionality that supports search and filtering by rating. Users can submit reviews with ratings, text, and photos. And restaurant owners can add new establishments via a dedicated form. Let's now look to explore the architecture that we are to implement. So here we see a representation of the architecture that we are to implement for this project. So starting at the top, we have our user, which is going to interact with our front end, a Next.js application. We'll not be focused on implementing the Next.js front end in this course. However, I will provide the code to you if you choose to run this as well. We can run the Next.js front end using Node, and it will interact with the Spring Boot backend via a REST API. So building the Spring Boot backend is going to be the focus of this course, and it's going to interact with 2 other components. It's going to interact with Elasticsearch, and that's going to be the technology that we use for our persistence layer. We're going to store representations of our restaurant, reviews, user, all in Elasticsearch. And although there are trade-offs to doing so, Elasticsearch does offer some very advanced search features that we can make use of inside of our application. So as a user would need to log in order to do things like submit a review, we'll need to handle authentication. There are an array of different options that we can choose from when implementing authentication. However, for this project, we'll use a Keycloak server, which our Spring Boot backend will interact with via Spring Security. And we'll be making use of OAuth 2 and OpenID Connect standards when doing so. And Keycloak will handle the creation of users and management of users all for us. Now, I did mention it briefly earlier, but we're going to run Elasticsearch and our Keycloak server in Docker. We'll create a Docker Compose environment in order to do that. And that will allow us to develop our Spring Boot backend, which we can then interact with via our frontend. In this project, the frontend and backend are going to interact using a REST API. So let's explore what that REST API might look like. So here is the first iteration of the Restaurant Review Platform REST API. And I'm using the Swagger editor in order to visualize this. So let's go through this REST API. At a high level, we have endpoints for managing restaurants. We also have endpoints for managing reviews, and then some endpoints for managing photos. There may be some additional endpoints that we need to implement later, but for the moment, these look like the endpoints that we'll need initially. So let's briefly go through each endpoint here and look to understand it. And let's start with the first endpoint here, search for restaurants. Now, it's entirely possible to call this endpoint without any query parameters. A straight call to http get/restaurants, and that will return a list of all of the restaurants in the system. However, as we're focused on searching in this particular project, I've added some additional query parameters to help with the search. So the first query parameter is simply queue, and that will allow us to provide a query. And we can use this for fuzzy matching inside of Elasticsearch. For example, if you can only remember the first few characters of a restaurant's name, you would type that in, and Elasticsearch may be able to match it to the particular restaurant that you're looking for. So we'll use queue for fuzzy matching. And then we have latitude, longitude, and radius. And we're going to use this for our geospatial search. Latitude and longitude are used to specify a point on the Earth. And then we're able to use radius in order to return all records within the specific radius to the point as denoted by latitude and longitude. So these three query parameters allow us to do geospatial search. And then we have cuisine type to allow us to filter by cuisine type, min rating for allowing us to filter by a minimum rating. Perhaps we only want to see restaurants with a minimum of 4 stars, for example. And then we have page in size for pagination. So let's minimize this endpoint here. We have a post endpoint to allow us to create a new restaurant, /restaurants, HTTP post, where the request body is a representation of our restaurant. And that will allow us to create new restaurants in the system. Let's minimize this. And then we have get restaurant details, where we specify the restaurant ID in the URL and use a HTTP get. And that will allow us to retrieve the details of one particular restaurant. Let's minimize that. Update restaurant details. Again, we'll specify the restaurant ID in the URL and then use a HTTP put in order to update the details of the restaurant to match what we provide in the request body. This is different from a partial update where we would only provide the properties that we wish to update. In this case, we need to provide the full representation of the restaurant. So let's minimize that. The delete restaurant endpoint, fairly straightforward. We provide an ID of a restaurant using the HTTP delete verb, and that will allow us to delete a restaurant in the system. Of course, we should probably set up some authorization around this, so we only allow authorized individuals to delete restaurants. So now we have our endpoints for reviews. This first endpoint here gets all of the reviews for a particular restaurant as identified by the restaurant ID. And if we look down here, we have sort, page and size for pagination, and then sort, which allows us to sort our results. For example, we might want to get the oldest reviews first, or perhaps the newest reviews first, sort by rating, etc. Let's minimize this. Then we have an endpoint to create a review for the specified restaurant as denoted by the restaurant ID, with the request body being a JSON representation of the review. We can see here the content, which is a string, and then a rating, and then a list of photo IDs. Let's minimize that. We have an endpoint to update a restaurant review. So we specify the restaurant ID and the review ID in this URL. And then the request body will be a representation of the review. Again, this is a HTTP put, so a full update. So we need to provide the full representation of the review in the JSON body. Let's minimize this one. We have a delete endpoint, which allows us to delete a particular review for the specified restaurant. Again, we'll need to be careful with this one and set up the relevant authorization. And then we have a couple of endpoints for managing photos. The way I see this working is that the post photos endpoint is used for uploading photos. And once we upload a photo, we would get a photo ID back. And then we can provide that photo ID when we create a restaurant review or create a restaurant listing. And then, of course, we have an endpoint to be able to delete that photo. And there we go. That is the first iteration of the restaurant review platform REST API. So let's recall what we've achieved in the What We'll Build module. In Review Project Brief, we established that the platform enables restaurant discovery and reviews. We should implement core features, including search, authentication, and image handling. The project focuses on advanced search functionality, which is why we're going to use Elasticsearch for this build. And this build includes geospatial capabilities. In Domain Overview, we've seen that a user can create restaurants and write reviews with basic profile info. Each restaurant has core details, ratings, photos, and will store these in nested structures. A review includes content, a 1 to 5 star rating, and photos, and can be edited within 48 hours of it being created. And we'll need to create supporting objects like address and operating hours to help organize our data. In UI Overview, we've seen that the homepage displays restaurant cards with images, ratings, and cuisine types. The restaurant details page shows the location map, reviews, and a form to submit new reviews. We have search functionality, which supports search and filtering by rating. Users can submit reviews with ratings, text, and photos. And restaurant owners can add new establishments via a dedicated form. In Architecture Overview, we've seen that the frontend uses Next.js to handle the user interface and client-side interactions. The backend uses Spring Boot for business logic and API endpoints. Elasticsearch stores data and enables advanced search features. And Keycloak manages authentication using OAuth 2 and OpenID Connect. In REST API Overview, we've seen that the REST API allows for managing restaurants, reviews, and photos. In this module, we'll set up your development environment, ready to build the application. The module is structured as follows. We'll first create a new Spring Boot project. We'll look to understand the initial project structure. We'll then set up Elasticsearch with Docker, install and configure Kibana, again using Docker, set up Keycloak with Docker. We'll configure MapStruct to work with Lombok, and we'll run the front-end application. So now for the learning objectives. So by the end of this module, you will be able to create a new Spring Boot project using the Spring Initializer, describe the initial project structure, run Elasticsearch locally using Docker Compose, log into Kibana and know where to find the indexes, run Keycloak locally using Docker Compose, configure MapStruct to work correctly with Project Lombok, and run the front-end code. So with that covered, let's get started. Let's begin building our restaurant review platform by creating a new Spring Boot project. The Spring Initializer will help us to set up a project with all the dependencies that we need, saving us time and ensuring we follow best practices from the start. So here we are on the Spring Initializer, and you can get to this by visiting start.spring.io in your browser. The Spring Initializer is a web-based tool that generates Spring Boot projects with your chosen configuration. So let's set up our new project. In the project, we're going to select Maven. We're going to use Maven as our build tool. And then for language, we're going to ensure that Java is selected. If we scroll down to the Spring Boot version, we're going to use the latest general release version, which at the time of filming is 3.4.2. Now, by the time you visit the Spring Initializer, there may be different versions. So as a general rule, ignore everything with snapshot or M1 or RC next to it, and just go for the highest numbers. So in this case, 3.4.2, we're going to ignore 3.3.8. 3.4.2 is the latest general release version. And now let's specify some project metadata. For the group, I'm going to use Devtiro, but you can use any group value that you like. For the artifact, we're going to name this one restaurant. The name restaurant pre-populates, that's fine for us. For the description, let's delete that. And let's say a restaurant review platform. Take that title case. Package name, Devtiro restaurant, that works fine for us. And we'll want to make sure that jar is selected, not war. When we select jar, it means that we get a bundled version of Tomcat when we select Spring Web in a minute. If we do war, then we'll have to deploy this to a running application container, which is the traditional way of doing things, but a lot more overhead. So we're just going to stick with jar. And for Java version, I'm going to select Java 21 as the latest long-term support release at the time of filming. So with the project metadata complete, let's scroll up here. And we're going to select some dependencies now. So as I alluded to a moment ago, the first one that we'll need is Spring Web. We're going to be exposing a REST API that a front-end interacts with. So we're going to select Spring Web. We could go Spring Reactive Web and use the reactive programming model, but I believe it's not going to give us a lot of benefit for this particular project, and it does come with its own overhead. So I'm going to select Spring Web for this. Also going to need Spring Security, as users are going to be authenticating with our system. We're also going to need Spring OAuth 2 resource server. The means by which users are going to authenticate is going to be OAuth 2 and OpenID Connect. We're going to be using Keycloak as our authorization server, so we're going to select OAuth 2 resource server. Let's add another dependency, and this one is going to be Spring Data Elasticsearch. We're going to be using Elasticsearch to store all of our restaurant review data in order for us to be able to search on it really effectively. So we're going to select Spring Data Elasticsearch to be able to work with Elasticsearch effectively. And we'll also select validation, so we can make use of the validation annotations. And we'll also select Lombok, so we can make use of Project Lombok and reduce the boilerplate code in our project. So Spring Web, Spring Security, OAuth 2 Resource Server, Spring Data Elasticsearch, Validation, and Project Lombok. And with that done, if we click on Generate now, that will download a zip file. And all that's left to do now is to unzip that zip file and then open it up in IntelliJ, and then we can start working on our project. So in summary, we've created a new Spring Boot project using the Spring Initializer. We've selected Java 21, Maven, and Jar packaging. We've added the required dependencies for building a restaurant review platform. We've generated and downloaded the project. And now the project is ready for development with all the necessary dependencies. After creating our project with the Spring Initializer, let's now explore the structure and components that make up our restaurant review platform project. As an intermediate project, you're almost certainly familiar with the general project structure of a fresh Spring Boot application. However, to make sure that we're all starting from the same page, we'll briefly go over this now. So here we are in our IDE, and here we have the standard Maven project format: source, main, Java, Devtiro restaurant, and then we have our restaurant application, with the @Spring Boot application annotation marking it as a Spring Boot application. And we can also see the green triangle here, which will allow us to run our application. We take a look in resources. We have static templates, which we won't need, so let's delete those. We do have application.properties, which simply just has the property for the name of the application at this moment. If we look in our test directory, we have our single test, which just makes sure that the Spring context loads. If we were to run this, we can see it passes initially, which is great, so let's minimize that. However, the really interesting thing that we want to check on is our pom.xml file. So let's open this and let's expand this. So we can see that we're using version 3.4.2 of Spring Boot. That's specified in the Spring Boot starter parent. And then we have all of the metadata that we selected: Devtiro restaurant, the version, the name of the application restaurant, description. And if we scroll down here, we're using Java version 21. And then we have our dependencies. So if we were to do a find and then go Spring Boot starter, these are all of the dependencies that we selected from the Spring Initializer. So we have Data Elasticsearch, OAuth 2 Resource Server, Security, Validation, and Web. And then we can see Lombok, which isn't attached to a starter, but is now available in our project. We have Spring Boot Starter Test and Spring Security Test as well. So it looks like we have all of the dependencies in our project, which is perfect. And we have our bundled Maven wrapper as well. So let's take this opportunity just to build our project and make sure that we're in a good place. And for that, I'm going to use the Maven wrapper, mvmw, clean, install. Great, so we have a build success. Now, if you do get any errors, and you may get some Java errors at this point, then I'd recommend taking a look into how you've installed your JDK or configured your JDK. Otherwise, if you see build success here at the moment, it means we can continue on and develop our project. So in summary, the project follows the standard Spring Boot directory structure. pom.xml contains our selected dependencies for web, security, and search features. The main application class serves as the entry point to our application, and that's one that's been annotated with Spring Boot application. And we have resource files such as our application.properties stored in source main resources. Very quickly, if you have any questions or if you do get stuck, you can ask for help from the Devtiro community. We're all on Discord and you can join us for free. Link in the description below. In this lesson, we'll set up Elasticsearch and Kibana using Docker Compose, allowing us to add powerful search capabilities to our restaurant review platform. So here we are back in our IDE. Now the first thing that we'll want to do is go to the root of our project directory. We'll go new, file, and we'll call this one docker-compose. Here we go. And it's in here that we'll configure our Docker Compose environment. Now, rather than write this line by line, you will find the environment YAML that you'll need in the lesson notes. So I'm going to paste this in now and we'll go through it so we understand what's going on. So here we are. So we have several services in this Docker Compose file. We have Elasticsearch here. Scroll down, we have Kibana, and then we have some volumes and network specified as well. Let's start with Elasticsearch here. We're pinning the version 8.12 of Elasticsearch, which is the latest version at the time of filming. We're specifying a container name of Elasticsearch, and then we have some environment variables here. We won't necessarily go into the specifics of each one, but just know that this is typically how I run Elasticsearch locally. Here we're specifying things like the node name, which in this case we're just calling Elasticsearch. We're disabling XPack security, and we're specifying some Java memory options. Of course, feel free to read up on each of these configurations, but I found that this particular combination works rather well for local development. Then we specify some ulimits here, setting the memlock soft and hard to -1, which essentially is unlimited. Although the specifics of this configuration are sort of outside of the scope of this is important because the process can now lock as much memory as it needs, which is important for persistence technologies like Elasticsearch. And overall, it helps to make performance just a little bit more predictable. Next, we specify some volumes, so Elasticsearch data, which we'll come on to in a moment. And then we're mapping the port 9200 to 9200, and that will make Elasticsearch available on localhost 9200, which is how the Spring Boot application is going to connect to it. And then we specify the network of Elastic here. So that's Elasticsearch. Now let's take a look at Kibana. Again, we are specifying the Kibana version in the Docker image name, giving this one the container name of Kibana. And then we are mapping the port 5601 to 5601, that being the default port that Kibana runs on. So that will make it available on localhost 5601. And then we specify the environment variable here, Elasticsearch host, and that tells Kibana how to access Elasticsearch. Note that we're using the name Elasticsearch here, which refers to the container name Elasticsearch rather than localhost. So that's to say that Kibana will connect to Elasticsearch inside of the Docker network, not going via the host. And here we specify that it depends on Elasticsearch and it's inside of the Elastic network, much like Elasticsearch. Scroll down here. We're specifying our volume of Elasticsearch data, which has the driver of local. So that will persist what's ever stored in the volume of Elasticsearch data on the host, depending on how you configured Docker on that particular host. Scroll down a bit further. We've then just specified our networks, Elastic, with the driver of bridge. And we use that so Kibana and Elasticsearch can communicate with each other, isolated from the host. But again, a lot of this configuration is based on personal preference as well. At the end of the day, it will allow us to run both Kibana and Elasticsearch, so we can hit both on localhost and they can communicate between themselves as well. So with that done, all that's left for us to do is open up a command prompt or a terminal here, and I'm going to write docker -compose up, and that will run both Elasticsearch and Kibana. Let's try this out. And there we go. We can see that Elasticsearch is started up fine, and we can see some output from Kibana here as well. So it looks like both Kibana and Elasticsearch are running fine now. Of course, there's one way to test this, and that's to try and hit these services in a browser. So that's what we're going to do now. So here we are in a browser. So if we try hitting Elasticsearch on localhost port 9200, we can see that we get this JSON printout. So it looks like Elasticsearch is running and available on localhost 9200. And if we change the port from 9200 to 5601, great, okay, so this looks like Kibana is running as well. Explore on my own. Yep, it looks like Kibana is running fine. So now that Elasticsearch and Kibana are running, let's update the configuration in our application to point to our running instance of Elasticsearch. Here we are back in our IDE. Let's minimize this. Let's go to source, main, resources, application.properties, and let's expand this. Now, strictly speaking, this line of configuration isn't necessarily needed because it's the default value that Spring Data Elasticsearch will use. However, if we add Spring Elasticsearch.uris, we can explicitly tell our Spring Boot application where to find our running Elasticsearch instance. In this case, on localhost port 9200. And once we start creating entities for use with Elasticsearch, we'll be able to test out this particular configuration. So, in summary, we've configured Docker Compose to run Elasticsearch and Kibana locally. Elasticsearch runs on port 9200 and Kibana on port 5601. And we've configured our application to connect to Elasticsearch, and data will be persisted through container restarts using Docker volumes. Kibana is a powerful web interface for viewing and managing your Elasticsearch data. In this lesson, we'll briefly explore how to access Kibana and locate our indexes, which will be valuable for monitoring and managing the restaurant data in our application. As we learned in our previous lesson, we can get to Kibana by going to localhost port 5601, and we'll see a page that looks a little bit like this. Now, there is tons of functionality inside of Kibana. However, we just need to know about a very small part of this in order to develop our application. So we open up the hamburger menu here, and we'll scroll down, and under management, we're looking for stack management. And on the left here, we have this index management, so we click that. Here we are. So this is where we'll manage our Elasticsearch indexes. Now, an index is similar to a relational database table in the sense that we'll have a Java object which maps to an index in the same way that we might have a Java object which maps to a table. But other than that, an index follows very different rules and a very different structure to a database table. Now, at the moment, we don't have any indexes. When we start to create our entities and run our application, these indexes will be created automatically. At which point you'll be able to see the indexes here, and if you ever do need to, delete them. So just as an example, if we were to create an index, give it the name of test, save, we now have the test index here. In our application, once we start creating our entities, we'll see two indexes, one for our users and one for the restaurant, which will also include things like the reviews, the opening times, etc. Now, during development, much like when you use a database, you might want to clear out your data. And to do that, you will simply select the index, go to manage indexes here. You have all these different options, but I find the best approach most of the time, in development at least, click on delete index and delete the index. And then when you restart your application, the indexes will be created fresh from your entities. And this really is a crucial feature of Kibana. So in summary, we've successfully accessed Kibana through the web interface at port 5601. We've located the index management section in stack management, and we've explored the available index actions and management features. Now that we've added the Spring Security and Spring Security OAuth 2 resource server dependencies to our application, we now need to add Keycloak to handle our user authentication and potentially authorization. So here we are back in our IDE, and we have the docker compose.yaml file open. So let's expand this. So we already have our Elasticsearch service. We can minimize that. And we already have Kibana. We can minimize that too. So let's add an additional service here for Keycloak. Again, you can find the configuration in the lesson notes. Here we are. So we've added the Keycloak service here. Again, we've got the image for Keycloak. We are pinning the version 23. And then we're mapping the ports 8080 to 9090. So by default, Keycloak runs on port 8080. However, our Spring Boot application also runs on port 8080. So we're going to remap Keycloak's ports to be on port 9090. And then we're specifying some environment variables here, Keycloak admin and Keycloak admin password. And we're setting both to admin. Of course, we're only doing this because we're in development. I don't recommend setting a simple username and password like this in production, and certainly not including it as plain text in any configuration files. But again, as our local Docker Compose development environment, this should be fine for us for the moment. Now we can also see the environment variable here, kcdb h2 file. And we're also running with the argument down here, db dev file. And this means that Keycloak is going to use the h2 database. Now the h2 database can run in a number of different ways. One is completely in memory, and another is to store its data in a file on disk. And that's what this configuration specifies. So Keycloak will use the h2 database, with the h2 database storing its data in a file on disk. And then we have a volume here, Keycloak data, which again, we've specified some additional configuration down here. Driver local means that the h2 file will be persisted between application restarts. So with this configuration included, let's open up a terminal or a command prompt. Here we have Docker Compose still running. So let's Control C out of this. Great. Now if we run Docker Compose up once more, there we go. So in addition to the Elasticsearch outputs and Kibana outputs, we also have now some Keycloak outputs. Now it's worth noting that Keycloak will take about 30 seconds to start up successfully. And once it has started up, we can access it via our browser. So let's do that now. So because we've remapped ports 8080 to 9090 for Keycloak, if we hit localhost 9090 in our browser, we can see the Keycloak user interface here. If we go to Administration Console, we have a login screen, and we should be able to log in with admin, which is the admin username and password that we specified in our configuration. We click on Sign In. Great, so it looks like Keycloak is running and we're able to log in successfully. Now, in order to use Keycloak with our Spring Boot application, the restaurant review platform we're building, let's go up to the top left here and let's create a new realm. And for the realm name, we'll call this one restaurant-review. We don't need to worry about providing a resource file. We need to make sure that the realm is enabled and then click on Create. Great, and that's the realm created successfully and it's populated up here. You can think of a realm as a tenant, and this is going to include configuration specific to our restaurant review platform. So now that we've created our tenant, let's go back to our IDE. Let's minimize this, and let's now tell our application where to find the particular realm inside of Keycloak. So let's open up our project on the left here. Let's go to Resources, Application.Properties, expand this, and we need to add an additional property. You'll find this in the lesson notes below. So here we're specifying Spring Security OAuth 2 Resource Server, JWT Issuer URI, and here you can see localhost 9090, so that's where we're running Keycloak, realms, and then the realm of Restaurant Review. And the Spring Security OAuth 2 Resource Server library is going to use this, but more on that a little bit later. So in summary, we've added the Keycloak service configuration to our Docker Compose file. We've started all of our services using Docker Compose, which now includes Keycloak. We've accessed Keycloak's administration console on port 9090, and we configured our Spring Boot application to use Keycloak for JWT validation. In this lesson, we'll integrate MapStruct with our restaurant review platform application, and this will allow us to efficiently handle object mapping between different layers of our application. And a special note here is that we'll need to ensure it works smoothly with Project Lombok. So here we are back in our IDE, and I've just opened the pom.xml file, so let's expand this. Now if we scroll down in our pom.xml file, let's look for Lombok. So you'll notice that we already have the project Lombok dependency. However, we are going to make a small change to this. We're going to pin the version to a version that I know that works and is compatible with MapStruct. So if we go version, and I'm going to add the version 1.18.36. However, rather than leave it like that, if we highlight it, right click, refactor, and let's extract out to a property, which we'll call lombok.version, and that's now available at the top of our pom.xml file. Now, whilst we're here, let's also specify the version of MapStruct that I know is compatible with this version of Lombok. So let's go org.mapstruct.version. We'll specify the version of 1.6.3. And now if we scroll down, in fact, let's put this dependency next to our project Lombok dependency. And this is where we're going to place our MapStruct dependency. You'll find the code for this in the lesson notes. So here we are, org mapstruct, and there we can see org mapstruct version, which is the property that we created just a moment ago. Now that we have both of the dependencies available in our project, Lombok and MapStruct, we now need to configure the Maven compiler plugin to use them appropriately. So to do that, let's scroll down, and here we can see the configuration for the Maven compiler plugin. And I'm going to go ahead and update this configuration. Again, you'll find this configuration in the lesson notes below. So here's the new updated configuration. Let's go through this. So both Lombok and MapStruct work with annotations. So we need to tell the Maven compiler plugin about them. And the order is important here. So first we specify Lombok, and that will generate code from the Lombok annotations. And then we specify MapStruct, which will use the generated Lombok code when the MapStruct mappers are then generated. And there's a third bit of configuration down here, which is specifying the Lombok MapStruct bindings. And that allows for both Lombok and MapStruct to work nicely together. So with that done, let's just make sure that everything is still working. So let's open up a terminal here, open up a new terminal, and let's run the Maven wrapper clean install. Great, so we still have a build success. So everything looks to be working for the moment, but the real test is when we start making our entities. So in summary, we've added the MapStruct dependency and version property to the project. We've configured the Maven compiler plugin for annotation processing, and we've set up the Lombok MapStruct bindings for compatibility purposes. In this lesson, we'll explore how to run the front end. So once you've downloaded the front-end code, opened up the zip file somewhere on your computer, you want to navigate to it using a command line or a terminal. So that's exactly what I've done here. So this is where I've stored my front-end code. It should be noted that this is the Windows command prompt. So if you're on Linux or Mac OS, you may see a slightly different view. However, the commands we will run will be identical across the platforms. So the first thing that we'll need to do is install the front-end's dependencies. And we'll do that by running npm install. After a few seconds, all of the dependencies should be installed, and all that's left for us to do now is to run the front end. And we can do that by running npm run dev. And with that, the Next.js development server will start up and our application will be available on localhost 3000. So in summary, we've downloaded the front-end source code, we've installed the front-end dependencies with npm install, and we've ran the front-end project with npm run dev. So let's recall what we've achieved in the project setup module. In create a new project, we created a new Spring Boot project using the Spring Initializer. We selected Java 21, Maven, and Jar packaging. We added the required dependencies for building a restaurant review platform. We generated and downloaded the project. And now the project is ready for development with all the necessary dependencies. And explore the project structure. We established that the project follows a standard Spring Boot directory structure. The pom.xml file contains our selected dependencies for web, security, and our search features. The main application class serves as the entry point to our application, and the resource files are stored in source main resources. In running Elasticsearch, we configured Docker Compose to run Elasticsearch and Kibana locally. Elasticsearch runs on port 9200 and Kibana on port 5601. Our application is now configured to connect to Elasticsearch. And we've ensured that data persists through container restarts using Docker volumes. In Kibana, we successfully accessed Kibana through the web interface at port 5601. We located the index management section in Stack Management, and we've explored the available index actions and management features. In running Keycloak, we added Keycloak service configuration to Docker Compose. We started all services using Docker Compose, accessed Keycloak's administration console on port 9090, and configured Spring Boot to use Keycloak for JWT validation. In setting up MapStruct, we added the MapStruct dependency and a version property to the project. We configured the Maven compiler plugin for annotation processing, and we set up the Lombok MapStruct bindings for compatibility, so they should now work nicely together. In running the front end, we downloaded the front-end source code, installed the front-end dependencies with npm install, and ran the front-end project using the command npm run dev. In this module, we'll build the foundation of our application by creating the domain entities and repositories that represent our data model. These domain objects will serve as the building blocks for our restaurant review application, enabling us to store and manage information about users, restaurants, reviews, and more. This module is structured as follows. We start by creating the user entity, and then the address entity, the operating hours entities, the photo entity, the review entity, the restaurant entity, and then finally wrapping up by creating the restaurant repository. And now for the learning objectives. So by the end of this module, you will be able to create the user entity for use in the application, create the address entity for use in the application, create the operating hours and time range entities for use in the application, create the photo entity for use in the application, create the review entity for use in the application, create the initial restaurant entity for use in the application, and implement the restaurant repository for use in the application. So with that covered, let's get started. In this lesson, we'll create a user entity that will store basic information within our restaurant review platform. While Keycloak will handle user authentication and management, we need a lightweight user entity to store basic user information within our application. This approach allows us to efficiently access user details when displaying restaurants and reviews without making additional calls to Keycloak. However, it's important to note that this creates eventually consistent data. If a user updates their details in Keycloak, our stored information won't automatically be updated. So here we are in our IDE. Now let's create a package to store all of our domain objects. So over here in com Devtiro restaurant, I'm going to create a new package and I'm going to call this one domain. And within domain, I'm going to create a new subpackage, and I'm going to call this one entities. And this will allow us to separate out our entities from our data transfer objects that we'll use later on in our presentation layer. So within the entities package, I'm going to create a new Java class, and I'm going to call this one user. And let's expand this. So this class is going to represent our user entity. Now, in order to reduce the boilerplate code on this class, I'm going to use some Lombok annotations. So we'll use @data, and this will generate the getters, setters, toString, equals, and hash code for us. We'll go allArs constructor to generate a constructor with all arguments, noArs constructor to generate a constructor with no arguments, and then we'll go @builder, and that will create a builder for us, so we can therefore use the builder pattern to create new users. Now, it's worth mentioning that there is some advice out there which says not to use @data on entities, which is then used with Spring Data JPA, or in this case, Spring Data Elasticsearch. And a lot of that has to do with @data automatically generating equals and hash code methods. If we have a bidirectional relationship set up, then the automatically generated equals and hash code for each of those classes will result in a cyclical reference, which can lead to Stack Overflow exceptions. However, in this case, because we don't have any bidirectional relationships, we should be safe. So now that we've created our class and added the Lombok annotations, let's now add the instance variables. So the first one we're going to add is for our ID, private string ID. So now we need to tell Elasticsearch what type we want this information stored in inside of our Elasticsearch index. In order to do that, we'll use the @field annotation, which comes to us from Spring Data Elasticsearch. And then inside of this annotation, we can specify a type argument, and then we can specify a field type, and then we have several options to choose from. In this case, we're going to use field type dot keyword. And this type is used for exact matches and aggregations. We're not going to need to do a partial search on our ID, so we'll use the field type of keyword for our ID when we store it in Elasticsearch. So let's now do our second instance variable, which is going to be a private string username, of course, storing our username. The @field annotation for this one is going to be field type dot text. Now, what makes field type text different from field type keyword is that field type text is used for partial searches. Now, we may want to search for our username, but let's say we can only remember the start. We would want our username to be returned in this instance. We'd want a partial search, so therefore we use field type text instead of field type keyword here. Next, we're going to create another instance variable, this time to store the user's given name, private string, and we'll call this one given name. And as we may want to do a partial search on the user's given name, we'll add the field type of text. Let's just scroll down a bit here. And we're going to add another instance variable. This is our last one, and this one is going to be the user's family name. And with that, we have our initial implementation of our user entity, with the ID of the username of the user's given name, and the user's family name. In summary then, we've created a user entity to store basic user information. We've used Lombok annotations to reduce the boilerplate code. We've configured the @field annotations for Elasticsearch. We've used the field type keyword for exact matching of IDs, and we've used the field type of text for searchable name fields. Restaurants need locations, and to represent these locations in our application, we'll need an address entity that will store all the necessary address components. So let's create ourselves an address class that will hold all the various components of a physical address. So here we are back in our IDE, and inside of domain entities, I'm going to create a new Java class, and we'll call this one address. And let's expand this. Now, just like before, we're going to add these same Lombok annotations to our class here. Data, allArs constructor, noArs constructor, and builder. And now we can start adding instance variables. Now, the first piece of information that we'll want to store is the street number of the address. Private string street number. Alternatively, we could use an integer to store this information, but we'll use a string in this case. And to this instance variable, we're going to add the field, where the field type is going to be keyword. We don't need to do a partial search on the street number, so we'll use the field type of keyword. Now let's store a private string variable for the street name. Now we may want to do a partial search on the street name. in which case we'll not use keyword for street name, but we'll use text. For the next instance variable, we'll store the unit, which is often used with business addresses. So private string unit, and we'll not want to do a partial search on unit, so we're going to use the field type of keyword for unit. Let's just scroll down a bit. So the next piece of information that we'll want to store is going to be the city, which we'll store as a string variable. And inside of Elasticsearch, we'll use the field type of keyword. Judging by the system's requirements at the moment, I don't think we'll need to do a partial search on city, so we'll use the field type keyword here. So the next piece of information that we'll store will be a private string instance variable called state, and that will be the state in which the address is. And for this field type, we'll use the field type of keyword. The next instance variable that we'll store will be a private string, and this will be the postal code of the address. Again, we'll not need to do a partial search on postal code, so we'll use the field type of keyword. And finally, we'll do an instance variable private string, and this will be the country in which the address is. And again, we'll use the field type of keyword for country, as we'll not need to do a partial search. Now, as you've likely inferred from the implementation of this class, is we've defaulted to the field type of keyword in all cases, unless there's a possibility that we'll need to do a partial search on the information in that instance variable. And that's because it's more efficient to store a keyword than it is a text. In order to enable partial searching, we need to store a lot more information about that particular instance variable. So therefore, we default to keyword in all cases, unless we need to do a partial search. And with that, we have our initial implementation of our address entity. So in summary, we've created the address entity class with Lombok annotations. We've added address-specific fields with appropriate Elasticsearch annotations. We've used field type.keyword for exact match fields like postal code, and we've used field type text for searchable fields like street name. And we prepared the entity for nesting inside of the restaurant entity. In this lesson, we'll build two interconnected entities that will help us manage restaurant opening hours. Restaurant opening hours can be complex, requiring a structured approach to store opening and closing times for each day of the week. The TimeRange entity will represent a single opening period with a start and an end time, while the operating hours entity will contain a time range for each day of the week. So here we are in our IDE. Let's start by creating our TimeRange entity. So inside of domain entities here, we'll create a new Java class, and we'll call this one TimeRange. There we go, and let's expand this. So let's first add the Lombok annotations at data, all hours constructor, no hours constructor, builder, and now we can start to add the instance variables. So TimeRange will have both an open time and a close time, and we're going to represent these as strings, just to keep things simple. So we'll go private, string, open time, and we're going to add the at field annotation to the top here with the type of field type dot keyword, private, string, close time, and again, we'll use the field type of keyword. So we could store the time using a type dedicated to storing times. However, to keep things simple, we've gone with a string. That said, we will be using a local date time a little bit later, so you will see how we can store that inside of Elasticsearch. And with that, we have our initial implementation of our TimeRange entity. So let's now move on to our operating hours entity. So let's open up our project here, and then inside of domain entities, we'll create a new Java class, and we'll call this one operating hours. And let's expand this. So again, to the top of the class, at data, all hours constructor, no hours constructor, and builder. And now we'll add the instance variables for each day of the week. Private, time range, so the entity that we've just created, and this will be an instance variable called Monday, of course representing the opening and close time on Monday. And now for the field annotation. Let's specify the type, and the type's going to be a bit different in this case, as we're going to use the field type of nested. And we use this to tell Elasticsearch we want to store the TimeRange entity inside of the operating hours entity inside of Elasticsearch. Or put another way, we want it nested. So now that we've created an instance variable to represent Monday, let's complete our operating hours entity by creating an instance variable for each day of the week. Tuesday, Wednesday, let's scroll down a bit, Thursday, Friday, Saturday, and finally, Sunday. There we go. And with that, we have our initial implementation of our operating hours entity. So in summary, we've created the TimeRange entity to store opening and closing times. We've built the operating hours entity containing the nested TimeRange objects. We've used the field type nested to maintain the relationship between the operating hours and TimeRange. And we've prepared both entities for integration with the restaurant entity. In our restaurant review platform, we need a way to store and manage photos that users can attach to their restaurant listings and reviews. So let's now build our photo entity, which will store information about uploaded images in our application. So here we are back in our IDE. So inside of domain entities, let's create a new Java class, and let's call this one photo. Let's expand this, and let's add the Lombok annotations we've been using at data, all hours constructor, no hours constructor, and builder. And the photo entity is going to contain two pieces of information. The first one is a private string URL, which is the URL of the photo. And we'll store this with the field annotation type equals field type dot keyword. We don't need to do a partial search on the photo's URL, so we'll use keyword. The next piece of information we'll want to store is the uploaded date of that photo. For that, we'll use a private local datetime, and we'll call the instance variable upload date. And we'll add the field annotation to this one, where the type is going to be field type dot date. But this is where it gets interesting. Because our local datetime stores both date and time, we need to add an additional argument. And this one is going to be format. And we have to specify the date format, again using an enum, to something quite specific. Date underscore hour underscore minute underscore second. And this will allow us to store our local datetime appropriately inside of Elasticsearch. And with that, we have our initial implementation of our photo entity, ready for nesting inside of the review and restaurant entities that we'll create very shortly. In summary, we created the photo entity with the URL and upload date fields. We've used fieldType.keyword for the URL field for exact matching, and we've configured the local datetime with the proper date format. And we've prepared the entity for nesting in restaurant and review entities that we'll create very shortly. Reviews are a key component of our restaurant review platform, allowing users to share their experience and ratings. In fact, the review entity will contain several important pieces of information, including the review content and rating, who wrote the review, when it was posted and last edited, and any photos attached to that review. So let's create our review entity. So here we are back in our IDE. So let's go into our domain entities package and create a new Java class, and we'll call this one review. There we go. So let's expand this. And as we've been doing, we'll add the @data, all hours constructor, no hours constructor, and builder annotations to the top of our class. And now we can start adding some instance variables. So the first one that we'll add is going to be the ID of the review. Private string ID. And we're going to add the field annotation to the top of this instance variable, declaring the type as field type dot keyword. The next instance variable is going to be the content of the review. Private string content. And we'll add the @field annotation, declaring the type in this case to be field type dot text. We may want to do a partial search on the content, perhaps searching for a keyword, for example. So we'll make that one field type text. And the next piece of information that we'll store is the rating. And this is a number between 1 and 5, which represents how many stars the user has given that restaurant. So we'll say private, integer, rating, and we'll add the @field annotation, declaring the type as field type dot. And because we have an integer, we're going to use field type dot integer. And this is the first time that we've seen this. So now that we've stored our rating, let's just scroll down and let's add our next instance variable. And this is going to be the date and time that the review was posted. Private local datetime, and we'll call this one date posted. We'll add the @field annotation to the top here, where the type is going to be field type dot date. And we've seen this done already before. And we know that we'll also need to specify the format, which is going to be date format dot date underscore hour underscore minute underscore second. And next we'll do the time and date that the review was last edited. And it's going to be exactly the same as date posted, with a different instance variable name. We'll call this one last edited. Let's scroll down. Now let's store a reference to the photos associated with this review. Private list of photo, the entity that we've just created. Let's import list. We'll call this instance variable photos, and we'll initialize it to a new array list. And that will make handling a little bit safer. For the field type on this one, we're going to declare the type of field type dot nested. We're going to nest a list of photos inside of our review entity. And finally, we'll want to store a reference to the user that wrote this review. Private user, and we'll call this one written by. And for the field type, we're also going to use the field type of nested. And with that, we have our initial implementation of our review. It has an ID, some content, a rating, which is a star rating between 1 and 5, the date and time that the review was posted, the date and time it was last edited, a list of photos associated with that review, so the photos that the user has taken as a part of the review, and then of course a reference of the user that wrote the review. So in summary, we've created the review entity with content and rating fields. We've added timestamp fields with proper date format configuration. We've used field type integer for the first time with the rating field. We've included nested photos and user relationships, and we've initialized the photos list for safe handling. Now that we have created all of our supporting entities, we'll bring them together to create the main restaurant entity, which will serve as the central model for our restaurant review platform. So let's go ahead and create our restaurant entity. So here we are back in our IDE. So over in domain entities, I'm going to create a new Java class, and I'm going to call this one restaurant. And to the top of the class, we'll add the same annotations that we've been using: at data, all hours constructor, no hours constructor, and builder. However, in this case, we're going to add one additional annotation to the top here, and we'll call it at document. And inside of the arguments to this annotation, we're going to specify the index name, and we'll call this one restaurants. The at document annotation, which comes to us from Spring Data Elasticsearch, allows us to specify that this entity is a document inside of Elasticsearch, and it should be stored in the index name of restaurants. We've not needed to add the at document annotation to any of the entities that we've created so far, because these will be nested inside of our restaurant entity. So that's to say that any entity that you want to store in its own index should have the at document annotation on the top, specifying the index name. So with that done, let's now add some instance variables to our class, starting with the ID, private string ID. And because this is an entity with the at document annotation, we're going to add the at ID annotation to this instance variable. Next, we'll specify the name of the restaurant, private string name. And to this one, we'll use the field annotation, specifying the type of field type dot text, as we may want to do a partial search on the restaurant's name. Let's scroll down here. Next, we'll store the cuisine type that the restaurant serves, private string cuisine type. And for cuisine type, we'll also use field type.text, and that will allow us to do a partial search on the cuisine type. Next, we'll store the restaurant's contact information, private string contact information. Now, we could store this in a more complex object, but for the current requirements, a string should work fine. So we'll add the field annotation to this one, but we'll not use field type text, but field type keyword. We'll not need to do a partial search on the contact information as far as we can see. Let's scroll down. So next we'll store the average rating, which we'll store as a float. Let's call this one average rating. Because of course, even though users are given a rating between 1 and 5, and that's an integer, so a whole number, when we take an average, we can get a float. And we'll use the field type annotation on the top here, specifying the type of field type dot float. This is the first time that we've seen this field type, but of course it matches the instance variable type that we're using. Next, we're going to want to store the geo point, so the point on the Earth where this restaurant is located. And we represent that with a latitude and a longitude value. So we'll declare this by saying private geo point, which we can see comes to us from Spring Data Elasticsearch, and we'll call this one geolocation. And to the top of this instance variable, we're going to use the geo point field annotation. Again, we can see it comes to us from Spring Data Elasticsearch. And this will allow the geolocation to be stored in the appropriate way inside of Elasticsearch. Let's scroll down. So now we can start adding the nested entities that we've just created, starting with the address. Private, address, address, and we use the @ field, specifying the field type of nested. And we'll copy this because all of the others that we create from here on out are going to be nested. So we've created the address. Next, we'll create the operating hours instance variable. Private, operating hours. We'll call this one operating hours. And again, this will be field type nested. Now for the list of photos. Private, list, photo. Let's import list. We'll call this one photos, and we'll initialize it to a new array list, and that will make handling a little safer. And we'll put the field type of nested on the top. Now for reviews. So we'll say private, list, review. We'll call this one reviews, and it will be a new array list, and we'll add the field type of nested. Let's scroll down. And finally, we're going to add the user that created this restaurant. So we'll say private, user, created by, and we'll add the @ field annotation with the field type of nested. And with that, we have our initial implementation of our restaurant entity. It has an ID, the name of the restaurant, the cuisine type the restaurant serves, contact information for that restaurant, the average rating of all reviews given to that restaurant, the geolocation, so the point on the earth that restaurant is located at, the physical address of that restaurant, the restaurant's operating hours, photos of the restaurant's reviews, and then the user that created that restaurant. So in summary, we've created the restaurant entity with the appropriate @document configuration for Elasticsearch. We've added basic fields, including name, cuisine type, and contact information. We've integrated the @geopoint field for storing the restaurant location data. And we've added nested relationships to address, operating hours, photo, review, and user. Now that we have our restaurant entity and all its related entities set up, we need a way to store and retrieve restaurant data from Elasticsearch. We'll create a repository interface that gives us the basic operations we need to work with restaurant data. So here we are back in our IDE. Now, in order to keep things organized, inside of Devtiro restaurant, I'm going to create a new subpackage, and I'm going to call this one repositories. And inside of repositories is where we'll create our new Java class, and we'll call this one restaurant repository. And this will be an interface rather than a class. And let's expand this. So before we go any further, let's add the @repository annotation to the top of the class, marking this as a repository. And just like any Spring Data repository, we're going to extend the appropriate repository. In this case, the Elasticsearch repository. And now we'll need to specify two types. First, the entity that this repository deals in, and that's going to be the restaurant entity. And then the type of the ID, which in this case is string. And with that, we have our initial implementation of our restaurant repository. That said though, we will be adding several custom queries to this repository. So we'll say custom queries, and we'll do that as and when we need them when we implement our business logic. But with this implementation alone, we already have the functionality to save new restaurants, find them by their ID, list them out, delete them, and count them. So in summary, we've created the restaurant repository interface extending the Elasticsearch repository. We've added the @repository annotation for Spring configuration, and we've gained access to basic CRUD operations through inheritance. And this sets up the foundation for future custom query methods. So let's now recall what we've achieved in the domain module. In the Create the User Entity lesson, we created a new user entity to store basic user information, used Lombok annotations to reduce boilerplate code, configured the @field annotation for Elasticsearch, used the field type keyword for exact matching of IDs, and the field type text for searchable name fields. In Create the Address Entity, we created the address entity class with Lombok annotations, added address-specific fields with appropriate Elasticsearch annotations, used the field type keyword for exact match fields like postal code, and used the field type text for searchable fields like street name. And we prepared the entity for nesting in the restaurant entity. In Create the Operating Hours entities, we created a TimeRange entity to store opening and closing times. We built the Operating Hours entity containing nested TimeRange objects. We used field type nested to maintain relationships between fields. and prepared both entities for integration with the restaurant entity. In Create the Photo entity, we created the photo entity with URL and upload date fields. We used field type.keyword for the URL field for exact matching, and configured local datetime with the appropriate date format, and prepared the entity for nesting in restaurant and review entities. In Create the Review entity, we created the review entity with content and rating fields, added timestamp fields with proper date format configuration, used field type integer for the rating field, included nested photo and user relationships, and initialized the photos list as an empty list for safe handling. In Create the Restaurant entity, we created the @restaurant entity with the @document annotation, which defines configuration for Elasticsearch. We added basic fields including name, cuisine type, and contact information. We integrated the @geopoint field annotation for storing restaurant location data, and added nested relationships to address, operating hours, photo, review, and user. And finally, in Create Restaurant Repository, we created the restaurant repository interface extending the Elasticsearch repository. We added the @repository annotation for Spring configuration, gained access to basic CRUD operations through inheritance, and set up the foundation for future custom query methods. Authentication is a core part of application security that helps confirm users are who they claim to be. In this module, we'll learn how to add OAuth2 and OpenID Connect authentication to our application using Keycloak as our identity provider. This will give our application a robust and standards-based way to verify users' identities. This module is structured as follows. We'll start by creating users in Keycloak, and then we'll configure our Spring Boot application as an OAuth2 resource server, allowing those Keycloak users to authenticate with our application. And now for this module's learning objectives. So by the end of this module, you'll be able to create users in Keycloak and create the initial Spring Security configuration to configure security in the application. Now let's create our first user who will be able to interact with our restaurant review platform. So here we are back in Keycloak. Now we need to make sure that we're on the restaurant review realm here. And once we are, if we go to users on the left-hand side, and let's click on add user. Now for the username, I'm going to specify test user. For the email, I'm going to go testuser@devtiro.com. Email verified. And for the first name, let's go test. And for the last name, let's go user. We'll not worry about adding any groups for the time being. Let's just click on create. So that's our test user created. Let's now set the password for this user. To do that, let's click on the credentials tab. Let's go set password. And let's now set a password, which I'm just going to set to the string of password, password confirmation, password, temporary. We're going to toggle that to be off. Now I can't stress enough, don't do this in production. We're only doing this as it's a local development environment. There's a number of things wrong with this. First, we're setting a very simple password. In fact, perhaps the most common password in the world, the word password. And that's only appropriate because it's our local development environment. And we've also set temporary to off. And that means the user, once you log in, won't have to reset their password. It will remain just the string password, which is what we want in order to make development simpler, but certainly not what you want in a secure production environment. For the time being, if we click on save and then save the password, great. So we now have a user called test user with the password of password. And we'll be able to use the test user to log into our application during development. So in summary, we've added a test user with basic profile information, and we've set the password for our test user manually for use in development. Now that we have set up our users in Keycloak, we need to configure Spring Security in our application to protect our endpoints and validate access tokens. So here we are back in our IDE. Now let's create a dedicated package for our configuration. So let's go over to Devtiro restaurant, create a new package, and we'll call this one config. Inside of config, we'll now create a new Java class, and we'll call this one security config. And let's expand this. So this, of course, is a configuration class, and it's a configuration class for web security. Now, this particular annotation isn't required as Spring Boot will work it out for you. However, I find that it does label the particular class as containing web security, which can be helpful, so I like to include it. So let's now create our filter chain configuration. So we'll do a bean declaration, public security filter chain, call this one filter chain, and for the arguments, HTTP security, call that HTTP, And this one will throw an exception. So the standard layout. Now let's get to implementing this. So we'll say HTTP dot authorize HTTP requests. And this is where we do our path matching. So auth dot any request, and we'll say authenticated. So this is just the catch-all mapper. So we're basically saying here that every single request that we make to our backend should be authenticated, should require an authenticated user. In fact, let's just put that on a new line. Format. Great. So next, let's configure our OAuth 2 resource server. So we'll say OAuth 2 resource server, OAuth 2. Then on OAuth 2, we're going to call JWT because we will be using JWTs from Keycloak. JWT. This is also a Lambda. Let's just scroll down. And on JWT, we'll call JWT authentication converter. And we need to now pass in an authentication converter. So I think we'll use the default one that comes along with Spring Security. So for that, just keep things nice and organized, I'm going to create a new bean declaration down here. Public JWT authentication converter, which we'll call JWT authentication converter. And we'll return a new JWT authentication converter. There we go. So it's the job of the JWT authentication converter to take the JWT that Keycloak has provided us with and turn that into the authentication object in the Spring Security context. So the logged in user with all the appropriate authorities. Of course, authorities are less of a concern for us in this build as we'll not be doing authorization, but we do need that logged in user. So we'll now use the JWT authentication converter inside of this call here. There we go. And let's just format this. So there we go. So we've configured the endpoints to say that all endpoints must be authenticated. And then we have configured the authentication mechanism, if you will, which is OAuth 2 resource server. And we've configured the JWT authentication converter to use the default implementation here. And this default implementation will be able to handle the tokens from Keycloak to create authenticated users, but not necessarily authorization and authorities. But again, not a concern for us in this build. So next we have session management. We're building a stateless REST API. So let's configure our Spring Security configuration as such. So we'll say session creation policy, and we can use the session creation policy of stateless. We don't want any sessions to be created. We want this to be stateless. And finally, we'll call CSRF. We'll say CSRF. This is also a Lambda. There we are. And we're going to disable CSRF for the moment. As a stateless REST API, it could be said that the risk is a lot lower. However, for production systems, you can certainly create a CSRF token mechanism. However, we won't do for this particular build. And then we will return http.build. There we go. And we have our security filter chain configuration. All endpoints must be configured. We're using OAuth 2 for our authentication mechanism. So we won't create any sessions to handle the security configuration. And we've disabled CSRF. But for this build at a high level, all endpoints need authentication. We're using JWT, OAuth 2, stateless session management, and we've disabled CSRF. So in summary, we've created the security config class to manage our application's security settings. We've configured our application to require authentication for all endpoints. We've set up stateless session management for our REST API, and we've enabled JWT validation with Keycloak. So let's recall what we've achieved in the authentication module. In creating users, we added a new user, test user, with the basic profile information, and we set up user credentials with the password of password. In create security config, we created a security config class to manage our application security settings. We configured our application to require authentication for all endpoints. We set up stateless session management for our REST API, and we enabled JWT validation with Keycloak. Modern web applications often need to handle photo uploads from users. In this module, we'll build a complete photo upload system that safely stores and retrieves photos. This functionality will allow our application to accept, store, and serve photos through a REST API. The module is structured as follows. We'll first look to understand the file storage design principles. And in this part, we'll design an interface for storing and retrieving files. We'll then create some custom exceptions for error handling of our file storage. We'll then implement core file storage operations. We'll then build photo upload and retrieval. We'll create data transfer objects and mappers. We'll develop our REST API endpoints. And then we'll make sure that we implement error handling in our REST API. So now for the learning objectives. So by the end of this module, you'll be able to implement and explain the store service interface, create a custom exception for use in file storage service, implement file storage functionality in the application, implement file retrieval functionality in the application, implement the necessary logic in the service layer to allow callers to upload and retrieve photos, implement a photo data transfer object and a mapper to convert to and from photo entities and DTOs, implement the REST API endpoint a caller can use to upload photos, implement error handling in the REST API implementation, and implement the REST API endpoint a caller can use to retrieve uploaded photos. So with that covered, let's get started. In our restaurant review platform, users need to upload photos of their dining experiences. Let's design a simple yet effective way to handle file storage that will serve as the foundation for our photo upload feature. You see, when building web applications that handle file uploads, you have multiple storage options available. The most straightforward approach is saving files directly to the server's disk. While cloud storage services like AWS S3 or Azure Blob Storage are popular choices, we'll start with local disk storage to keep our implementation focused and manageable. So here we are back in our IDE. Now the first thing that I'm going to do is go over to the Devtiro restaurants package and create a new subpackage, and this will be called services. And if we minimize everything else, and this is where we're going to design our storage service interface. So let's create a new Java class, and we'll call this one storage service. And this will be an interface rather than a class. So here we go. Let's expand this. So the storage service that we're implementing doesn't know anything about it being a photo. It only cares about it being a file. We'll implement all of the photo specifics in a different service that uses this storage service. So there's only two things that this storage service really needs to do. And that's to store a resource and to load a resource. So let's add two methods to this storage service interface which define that. So the first one is going to be our store method. So this is going to return a string. So the unique identifier, let's say, of the resource that's been stored. And we'll call this method store. And this will take two arguments, a multi-part file, which we'll call file, and then the string, which will be the file name. Now we're using the multi-part file type because that's the type that you get when you upload a file to a Spring Boot controller. And of course, we'll want to know the file name. And now for the loading. So let's have this return an optional of resource that's coming to us from Spring Framework Core IO. And we'll call this one load as resource. And then we'll say string, and that will be the ID of the resource to load. And that defines a very simple storage service, one method to store the multi-part file that's uploaded to our Spring Boot controller, and the other one to load that file as a resource, returning optional empty if the file with the specified ID doesn't exist. So in summary, we created the storage service interface for managing file operations and defined methods for storing and retrieving files from disk. In our restaurant review platform, we need a way to handle errors that are specific to our application's needs. Custom exceptions help us to communicate domain-specific errors in our application, going beyond the generic exceptions provided by Java. So let's go ahead and create some custom exceptions that we can then use when we implement our storage service. So here we are back in our IDE. So the first thing that I'm going to do is go over here to Devtiro restaurant and create a new package, and we'll call this one exceptions. Now we could go right ahead and create a, say, storage exception that we can then use to throw inside of our storage service implementation. However, I'm going to go one step further, and I'm going to create a base exception that the storage exception can then be a subclass of. And the main reason that I'm creating this exception hierarchy is if we wanted to declare that we catch all of the custom exceptions in our application, it's a lot easier just to declare that we catch the base exception. So over in the exceptions package here, I'm going to create a new Java class, and I'm going to call this one base exception. And let's expand this. So let's create our base exception class. So we're going to say extends a runtime exception. And this means that our base exception, and therefore anything that extends it, will be an unchecked exception. In contrast, we could extend exception, and that means that base exception and its subclasses would be checked exceptions, meaning, of course, that anything that throws this exception would need to declare it in its method signature. However, we're going to use runtime exception. Uncle Bob makes a great argument why you should use an unchecked exception over a checked exception in the clean codebook, and that's because the checked exceptions break the open-closed principle. And you can feel free to research this, but just know there's rationale behind using a runtime exception here. So let's now override the constructors. So we'll go generate, constructor, and we'll go for no arguments, the constructor with a string and throwable, and just throwable. There we go, and we now have our base exception. So let's go ahead and create our storage exception. So the one that we can throw to communicate there's been an error in either retrieving or saving a file. To do that, I'm going to create a new Java class inside of the exceptions package, and I'm going to call this one storage exception. Let's expand this. And storage exception is going to extend our base exception. And then we will generate our constructors, no arguments, message string throwable, and throwable. There we go. And we now have a storage exception that we can use when we go ahead and implement our storage service. So in summary, we created a hierarchy of custom exceptions for our application. Base exception serves as the parent for all custom exceptions. The storage exception class extends the base exception class and will use storage exception for any file operation errors. And we've used the runtime exception class to avoid the constraints of using a checked exception. Building on our previous work with the storage service interface, we'll now create a concrete implementation that stores files on disk for our restaurant review platform. So here we are back in our IDE. So inside of the services package here, I'm going to create a new sub-package and I'm going to call this one import. And this is where we're going to store our implementations just to keep things nice and organized. So inside of import, I'm going to create a new Java class and we'll call this one file system storage service. And this will be a Java class. There we go. And let's expand this. So the file system storage service is going to implement the storage service. And we now get this red squiggle. So if we hover over here, we can implement methods, select both, okay. And now we have the store method and the load as resource method ready to implement. We have our method stubs. Now, before we go any further, I'm going to add the @service annotation to the top of the class. And because we'll want to use a logger, I'm going to use the self4j annotation from Lombok, and that will make a logger available for us via the log variable. So let's scroll down. So before we can implement either of these methods, we need to configure some file system specific things. For one, where we're going to actually store and retrieve these files from. So for that, I'm going to create a private instance variable here, private string, and I'm going to call it storage location. Now it would be great to get this from configuration. So on the top here, I'm going to use @value, making sure that I use the one from Spring Framework and not Lombok, so Spring Framework. And inside of there, I'm going to use an argument, $braces, app.storage.location. So we can specify this particular argument in our application.properties or application.yaml, etc. And that will allow us to specify where we're going to store and retrieve our files from. However, let's just put a default in there of uploads, and that will be an uploads directory in the root of this project. So we now have the storage location where we can store and retrieve files from on disk. But this is just a string. Ideally, we would want a path, and we'll call that one root location. So in order to go from this string representation to the actual path, we could do this in the constructor. However, this could throw an exception. And I really don't want to throw an exception inside of our constructor. So with that in mind, let's use a public void init method for initialize. And we'll put the @post construct annotation on the top here. So after the class is constructed, this method will be run. So let's say root location equals paths.get, and we'll pass in storage location. So the string representation. And now we have a path representation of our storage location. However, what if it doesn't exist? We certainly don't have an uploads directory at the moment. So let's create one. So we'll say files.create directories, and then we'll pass in our root location. But of course, this throws a checked exception. So let's just hover over here, use this little light bulb, and we'll surround with a try catch. However, rather than throwing a runtime exception here, I'm going to throw a new storage exception. So we can use our custom exception because something's gone wrong with storage. And we'll say could not initialize storage location. And we'll also pass in the exception E using that constructor where we specify the string message and the throwable. There we go. So we load the string representation of where to store and retrieve our files from. We then create a path inside of a postConstruct init method here. And once we've got that path, we attempt to create a directory at that location. And if we cannot do that, we'll throw a new storage exception, which is our custom exception that we created in the last lesson. So with that in place, then let's now implement our store method. So the first thing that I'm going to do is check that the file is not empty. So we'll say if file is empty, then we're going to throw a new storage exception and we'll say cannot save an empty file. So at this point, we know the file is not empty. So let's attempt to work out what the file extension is, because of course we'll want to save it on disk with the same file extension. There's no point in saving a JPEG as a ping because when we get it back, it won't be in the right format. So let's say string utils dot get file name extension, and we'll say file dot get original file name. And we'll save that to a variable which we'll call extension. So we now have the file extension. So let's work out the name of the file that we're going to save. So for that, we'll say final file name. And our final file name will be the file name specified as the second argument. And then we'll say dot, and then the extension. And this will allow us to save the file as the specified file name, but with the correct extension. But of course, this is just a string representation right now. So let's create a path. So we're going to say root location dot resolve. Then we'll say path dot get, passing in the final file name, and then we'll say normalize to absolute path. We'll save that as a variable, and we'll call this variable destination file. And let's just format this. In fact, let's put that on some new lines so we can read everything. There we go. So we now have a path representation of where we're going to save this file. So inside of our root location, which is what we've created up here, and then with the specified final file name, the correct extension, and the file name as specified as the second argument in the store method. So now that we have a path representation of where we're going to save the file, let's just do a quick security check to make sure that there isn't any dots or anything like that being used, which break us out of where we're supposed to be saving that file. So let's say if destination file dot get parent dot equals, and then we'll say root location dot to absolute path, and we'll say not. So essentially what we're saying here is if the parent directory of our destination file does not equal the root location, then it means somehow this destination file represents a place on disk that isn't inside of the root location. And that of course is means for concern. We don't want to store files outside of where we specify them in our configuration. So we're going to throw a new storage exception, and we'll say cannot store file outside specified directory. So this is a great example of one of the constraints, one of the things you need to bear in mind when you're implementing file-based storage. This is going to be a very basic implementation, but in a full production implementation, you will need to think about things like scanning the file for malware, making sure that the file size is appropriate, making sure that the right file types are saved, making sure that the files have the correct permissions, etc. So please do bear this in mind if you're planning on taking this sort of implementation to production. This is a very basic implementation. But that said, we've done a very brief security check to make sure that we're storing the file in the correct location. So now we can go ahead and store that file. So we'll go try, and then we'll say input stream, which we'll call input stream, equals file.get input stream. Remembering that file is the file passed in as the first argument up here. So we now have an input stream for that file. Let's go ahead and use it inside of this method. So we're going to say files.copy from the input stream to the destination file. And then we'll say standard copy option, and we'll go with replace existing. And this will allow us to overwrite a file by specifying the same name. Again, this may not be something that you want to do in a different implementation, but in our case, this is what our storage service will do. And now we're going to say return final file name as the ID of the file. Now, we do have some red squiggles here, an IO exception, and copy throws another IO exception. So let's now wrap this in a try to make sure that we catch any of those IO exceptions. Try, and then we'll close it here, and we'll say catch IO exception. And if we get an IO exception, we'll throw a new storage exception, and we'll say failed to store file. And then we'll also provide the IO exception as well. There we go. So brief recap. We get the storage location, so the place that we're going to store and retrieve files from the app.storage.location configuration, or else we default to the uploads directory in the root of the project. We then create a path representation of this string path here via this init method with the post construct annotation. We've then implemented the store method here. We check that the file is not empty, otherwise throw a storage exception. We then work out the file extension of the file being uploaded and use that to create the final file name by using the file name argument passed in here. We then get a path representation of where to store the file to. We make sure that it's in the correct location, so in the root location configuration specified up here. If it's not, we throw a storage exception. We then actually do the file copying by creating an input stream from the file passed in, and then writing that to the destination file, and then we return the final file name. And if we do get an IO exception, we catch that and throw a storage exception with the message failed to store file. And with that, we have our first implementation of our storage service store method. So in summary, we've implemented the file system storage service to store files on disk. We've used the app value annotation to configure the storage location path. We've initialized the storage directory inside of a method annotated with app post construct. We've implemented a secure file storage and path validation. However, do bear in mind those security concerns that I've raised for production. And we've added error handling using the storage exception. Now that we can store files on disk, we need to implement the functionality to retrieve them. This will complete our storage service implementation by implementing the load as resource method. So here we are back in our IDE, and we're inside of the file system storage service. And we have our load as resource method ready to implement. And we're going to be using the Spring resource abstraction, and that provides a unified way to handle different types of resources, including files. So in order to create a resource, the first thing that we're going to need to do is get a path. So let's say root location, remembering that is the directory where we've stored all of the files. So root location dot resolve, and we're going to look to resolve the ID, which may be better to, rather than call it ID, let's right click refactor, and we'll call this one file name. So we're going to look to resolve the file name inside of the root location, and we'll assign that to the path of file. So now that we have a path representation, let's create a resource. So we'll create a new URL resource extends resource. So URL resource passing in the file. But we can't pass in a path, we'll need to get a URI. So we'll say to URI, and we'll assign this to a variable, which we'll call resource. And just to prove that URL resource extends resource, we'll do that. Let's see where we've got this red squiggle, unhandled exception. So we'll come back to that in a moment. So we now have a resource representation of our file. So let's make sure that it exists. So we'll say if resource exists or resource is readable. Let's just take a look at the isReadable method here. So we can create a get input stream from it. Then we're going to return an optional of resource. Otherwise, we're going to return an optional of empty. So basically, if the resource exists and it's a readable resource, then we're going to return an optional of that resource. However, if the resource doesn't exist or if it's not readable, we're going to return optional empty. Now let's handle this exception. So we're going to go try around the outside here, and we're going to catch. Let's just hover over here and see what we're catching. A malformed URL exception. Malformed URL exception, E. And I'd want to know about this in the log. So I'm going to say log.warn, and we'll say could not read file, and then we'll say file name, and then we'll also log the exception, and then we're going to return an optional of empty. Okay, we have a minor warning here. So let's replace the concatenation with the formatted call. There we go. So essentially, if we find the file and the file is readable, we return the file. If not, we return empty. If the file name represents a malformed URL, then we also return an optional empty. Now we could throw a storage exception instead of a optional empty. However, I feel it's going to be a fairly common occurrence that we're attempting to load resources that don't exist. Perhaps a photo has been deleted, for example. So rather than treating that as an error case, we'll just return an optional empty. Of course, this is a design decision, so feel free to take the exception route if that's your preference. So in summary, we've implemented the load as resource method to retrieve stored files. We've used Spring's resource interface for file handling. We've implemented error handling with optional. We've used URL resource to represent file system resources. And we've added logging for debugging file access issues. Building on our previous work with the storage service, we'll now create a dedicated service for handling photo operations, which will create unique identifiers for photos and maintain additional metadata about uploaded images. So here we are back in our IDE. So let's head over to the services package here and let's right click, go new, Java class, and we'll create ourselves a photo service. And this will be an interface rather than a class. Let's expand this. So in our system, we need to do two things with a photo. We need to be able to upload a photo and we'll need to be able to retrieve a photo. So let's model those two methods here. So let's first model the upload photo method. So this will return a photo. So that's our domain entity. And we'll call this one upload photo. And this will accept a multi-part file, which we'll call file. Remembering that the multi-part file, we saw that used in the storage service a little while ago. So this method models being able to provide a file and then we get a photo back, assuming that that photo was then stored somewhere. So that's the upload photo. Let's now model the retrieve photo. So this will return an optional. Optional empty for when the photo doesn't exist, but a optional resource when the photo does exist. Remembering that resource comes to us from Spring Framework Core IO. And we'll need to import optional there. Perfect. And we're going to call this method get photo as resource. And to this method, we'll pass a string ID. So with that done, let's get to implementing this service. So let's go back over to our project. And inside of impl, we'll right click, go new, Java class, and we'll call this one photo service impl. And this will be a class. And let's expand this. So before we go any further, let's put the service annotation on the top here, marking this as a service. And let's also put the required arguments constructor on the top as well. And that will generate a required arguments constructor for us. And now we can say implements photo service. And we'll get a red underline because we need to implement those methods. Okay. So now we have two method stubs. We have our upload photo method stub and we have our get photo as resource method stub. So let's first implement upload photo. And for this, we're going to need the storage service that we created a moment ago. Private, final, storage service, which we'll call storage service. And because we have required arguments constructor here, generating the constructor, this will be injected and is now ready to use. So remembering that the storage service has the store method, which takes a multi-part file and then a file name, let's work out what the file name should be. I think just a random UUID should work perfectly fine. So let's say UUID, random UUID, and then we'll call toString on there. And this will be our photo ID. So we can pass in the file, so the argument to the upload method, and then the photo ID. And then this will give us the URL to that file on disk. So we need to represent this as a photo. So what we'll do is we'll create a new photo using the builder, photo.builder, build, return, and now we can populate the photo with some information. So let's say URL, it's going to be the URL, and then the upload date will be local date time .now. There we go. So a bit of nuance here, but this upload date isn't actually stored anywhere. This is just transient data. But we're modeling it for the moment because we've modeled our photo to have an upload date. The real important piece of information for the caller is going to be the URL of the stored photo. So that's our upload photo method. Let's now move on to our get photo as resource method. And this one is rather straightforward. We're going to return storage service dot load as resource, passing in the ID, which is going to be the URL of the photo. So here we have our first initial implementation. So we're using our storage service, so our generic way of storing and retrieving files, firstly in the upload photo method, whereby we generate a random name for our particular photo using a UUID so we don't get any conflicting names. We then store our photo using the random ID that we've just generated, and then we get the URL back. We then return the URL as a photo to the caller. In the get photo as resource, we're simply passing through to the storage service loading as resource, where the ID is going to be the URL of the stored photo. This will return the resource if it exists, otherwise we'll get an optional empty. So in summary, we've implemented the photo service interface, defining upload and retrieval operations. We've created the photo service import class to manage our photo storage and retrieval. We've used a UUID to generate unique identifiers for our photos. And we've leveraged the existing storage service for file operations. Now that we have our photo service implementation ready, we need to create a data transfer object, or DTO, to represent photos in our REST API responses. So here we are back in our IDE. So inside of our domain package here, we're going to create a new sub-package to live alongside entities, which we'll call new package DTOs. So let's put it inside of the entities package. Let's just refactor and we'll move the package to directory domain. There we go. So that means we have com Devtiro restaurant, domain, DTOs, and then entities. Inside of the DTOs package here, we'll create a new Java class and we'll call this one photo DTO. And let's expand this. So this is to represent the photo in our REST API responses. So let's start by putting the @data, all R's constructor, no R's constructor, and builder annotations on the top there. Then all that's left for us to do is to add our instance variables, which in this case is going to be a private string URL to represent the URL of the photo, and then a private local datetime upload date to represent the date that the photo was uploaded, which, if you recall, if we take a look at the photo entity, is near enough exactly the same as the photo entity. The difference being, of course, is that the photo entity exists in our persistence and service layers, whereas the DTO models requests and responses to and from the REST API. So we have a photo entity and we have a photo DTO. Now we need a way of converting from one to the other. And the way that we're going to do that is by creating ourselves a mapper. So let's minimize some of these packages. So within of com Devtiro restaurant, we'll create ourselves a new package, and this one will be called mappers. And inside of mappers, we'll create a new Java class, and this one will be called photo mapper, and it will be an interface rather than a class. Let's expand this. So this photo mapper is going to be responsible for converting between a photo DTO and a photo. And we don't actually need to provide an implementation for this. MapStruct will do that for us, as long as we set up this interface correctly. So let's first put the @mapper annotation on the top, coming to us from MapStruct. The component model for this one is going to be Spring. This is a Spring Boot application after all. Unmapped target policy, we'll set that to be reporting policy.ignore. So if MapStruct finds an instance variable that it doesn't know how to map, it will simply ignore it. Of course, feel free to change that configuration if you'd rather it throw an exception. So inside of photo mapper, we're going to specify a single method returning a photo DTO. We'll call this method toDTO, and its argument will be a photo of type photo. We'll just need to import photo. There we go. So this method goes from our photo entity to the photo DTO. So in summary then, we've created a photo DTO to represent the photo in our REST API, and we've created a mapper to go from a photo entity to a photo DTO. So we now have everything that we need to implement our photo endpoints. So in summary then, we created the photo DTO to represent photos in our API responses. We've used Lombok annotations to reduce the boilerplate code in the DTO. We've implemented the photo mapper interface using MapStruct, and in doing so, we've set up automatic mapping between the photo entity and the photo DTO. In this lesson, we'll create a REST API endpoint that allows users to upload photos to our restaurant review platform. We'll build on our existing photo services and create a controller that handles the upload process. So here we are back in our IDE. So let's go over to Devtiro restaurant and create a new package, and we'll call this one controllers. And inside of the controllers package, we'll create a new Java class, and we'll call this one photo controller. There we go, and let's expand this. So to the top of this class, we're going to put the @REST controller annotation, marking this as a REST controller. We're going to put the required arguments constructor, which will create a constructor for us and inject those dependencies. And we'll specify a request mapping, and we'll set the base path of this controller to be /API/photos. Now for injecting our dependencies. In order to create an upload endpoint, we're going to need two dependencies. Private, final. We're going to need our photo service, which we'll call photo service, private, final. And of course, we'll need our photo mapper that we've just created. We'll call that one photo mapper. And now that we have these dependencies in play, we can implement our endpoint. This is going to be a post endpoint. So we'll use the post mapping annotation on top of a public method, which returns a photo DTO. And we'll call this one upload photo. We could very well wrap the photo DTO in a response entity, but we'll not, just to keep things simple. What we'll do instead is focus on the request. And we're going to use the @request param annotation here, specifying file. And this will be a multi-part file, which we'll call file. And in doing so, we now have reference to the file that's uploaded to this particular endpoint. And now we can call our photo service .upload photo, passing in the file. And then that will be not just a photo, but our saved photo. And then we can return photo mapper .toDTO, passing in our saved photo. And like that, we've created an endpoint where we can upload a file. And then we'll call the upload photo method on our photo service to then save that using the storage service. And then we're able to take the photo, convert it into a photo DTO, and then return that to the caller. And this represents our first endpoint. So this is a great opportunity for us to test two things in our user interface. One, that our authentication is working correctly, and two, that we can upload a photo. So let's try it out. So let's go over to our project here, and let's go to the restaurant application, so the entry point. Let's expand this. Now, before we go any further, let's open up a terminal and make sure that everything's running in Docker. So docker-compose and up. Okay, with everything started up successfully, we're now going to click the triangle on the left and then click on run. Perfect, and that's our backend application started up fine. So let's head over to our browser now. So here we are in our browser on localhost 3000, and we can see our front end is running. Currently doesn't display any restaurants or anything like that because, of course, we haven't implemented those endpoints. However, we have implemented two things. One, authentication, and two, the ability to upload photos. So let's try these out. So let's go inspect and open up our network panel so we can see everything that's happening. There we go. And let's click on login. Great. So we've been redirected to Keycloak. So let's go test user, which of course is the name of our user, and then password, which is the password. Click on sign in. Perfect. So we've been able to successfully sign in. We can see the little U up here for our test user. So with that done, let's now try uploading a photo. Now I've created an admin page for this. If we go to /admin, we can see a very basic image upload test interface. So what we can do with this is upload an image. So let's select an image from our disk. Here we are. So here we have some images that I was trying out earlier. So let's select this burger and let's click on open. There we go. We can see that our burger has been selected now. So if we click on upload image, let's see what happens. Okay, so we have ourselves here a 200 status and we have a response with a URL. So this is a different URL from the one that we uploaded. So this is generated fresh and we have an upload date. If we take a look at our network panel, we can see that everything is confirmed there. We've been able to successfully post, getting a HTTP 200 OK back. The payload, of course, is our binary file, and the response matches what we can see here. So it looks like our photo upload has been successful. Before we go looking for that file, though, let's just double check these headers. And if we scroll down here, we can see the request headers, and there we can see our authorization header. So we've been able to successfully upload an image because we provided the relevant authorization header. Great stuff. So let's go looking for this image on our disk. So let's head back to our IDE. Here we are back in our IDE. Now we didn't specify any configuration in our storage service. So if we go to services, import, and file system storage service, expand this, we set this configuration property at the top here. You can either provide app.storage.location, or otherwise we default to the uploads directory, which is in the root of the project directory. So if we go back to our project navigator here, here's our uploads directory. If we look in here, double click this, we have our burger image. So it looks like our photo uploads is working as expected. So in summary then, we've created a photo controller to handle the REST API requests. We've implemented API Photos endpoint for photo uploads. We've used Spring's multi-part file for file handling. We connected the controller to our existing photo service, and our endpoint returns a photo DTO with the photo UUID and metadata. When building REST APIs, proper error handling ensures users receive clear, consistent responses when things go wrong. In this lesson, we'll implement error handling for our custom exceptions. So here we are back in our IDE. Now to standardize our error responses, we'll create an error DTO class that defines the structure of error messages sent to API clients. So let's head over to our domain package to DTOs, right click in here, new Java class, and we'll call this one error DTO. And let's expand this. And to the top of this class, we're going to add data, all R's constructor, no R's constructor, and builder. And now to define the instance variables. I think two pieces of information are going to be useful. We'll go private, integer, and then we'll do status, and that'll be the HTTP status. Again, you could likely just get that from the request, but we'll encode that in the error DTO as well. And then we'll say private string message, and that will just be a string message as to the nature of the error. Of course, you can build this out to include any information that you like. This is just what we're going to choose is our standard error response that our REST API will conform to. So with that done, let's now create our error controller with the controller advice annotation. So we'll go project, and then inside of controllers, right click, new, Java class, error controller. And let's expand this. And to the top of this class, we're going to add REST controller for it's a REST controller, controller advice. And we're also going to add the SLF4J, so we get access to that log variable as well. So let's start by handling our storage exception. So let's go to the top here, and then we're going to go public response entity, which will return our error DTO type. And we're going to call this one handle storage exception. And it will take a storage exception as an argument, which we'll call EX. There we go. And to the top of this method, we're going to add the exception handler annotation there, specifying that this method handles the storage exception class. Great, so now we get to decide what we do with a storage exception. Well, the first thing that we're going to do is do a log.error, and we'll say caught storage exception, and then we'll pass in the storage exception, so it's printed out into the logs. And now we'll create our error DTO. Error DTO.builder.build. We'll assign that to a variable, which we'll call error DTO. And now we can start populating the error DTO. So let's start with the status. HTTP status dot internal server error dot value. So if we get a storage exception, it means that something's gone quite wrong. We're unable to save or retrieve files. So we'll go with an internal server error for this one. And then with the message, we'll say unable to save or retrieve resources at this time. There we go. And now we're going to return a new response entity, passing in our error DTO with the HTTP status of internal server error. There we go. So this is going to handle any storage exceptions that are thrown and bubble right up to the controller. And it's going to handle them by catching them, returning a standard error DTO, internal server error, unable to save or retrieve resources at this time, and it will respond with a HTTP 500. Now, whilst we're here, let's also handle the base exception, which all of our custom exceptions extend. And let's also just handle exception, the root exception class. And I'm going to just paste in the values for this. Again, you'll find this in the lesson notes below, but it will help us speed things along. So exactly the same setup as our storage exception, handle base exception, again, returning a HTTP 500 with an unexpected error has occurred, and then a catch-all for all the unexpected exceptions. Again, caught unexpected exception occurred, internal server error. But it will all be responding with our error DTO. So in summary, we've created an error DTO to standardize API error responses. We've implemented global error handling with controller advice, added specific handlers for storage exception and base exception, included logging for debugging and monitoring, and we've used response entity to control the HTTP status codes. Now that we can upload photos, we need to implement the endpoint that allows users to retrieve them. This is particularly important because we want to display restaurant photos to users before they log in, making using the site more engaging. So here we are back in our IDE. So let's head over to our photo controller here, expand this, and let's get to work on our new endpoint for retrieving photos. So this one is going to be a get mapping, and it's going to use the path / and then we're going to use a regex matcher, I think. So we're going to go ID is dot plus one or more of anything. So we'll say public, and this will return a response entity of a resource. We're using a response entity in this case because we want to control the response code. And then we'll call this one get photo, and then we'll declare our path variable, which is the string of ID, which matches this up here. So a get endpoint where the user provides the ID of the photo that they want to view in the URL path, and we extract that, and now we can use it by calling photoservice.getPhoto as resource, passing in the ID. And this will return an optional. So we're going to say .map, and in the case that the photo exists, we're going to say response entity. So actually, let's just scroll down. Response entity .ok .content type, which is going to use the media type factory for this, .get media type from the photo, which is a resource. And then we'll say, or else will return as media type .octet stream. There we go. Let's just put this on some new lines so we can read it. There we go. That's better. So we need to return the correct content type in order for the photo to be displayed correctly. And we're going to get that from the resource, which is returned from getPhoto as resource. So we've dealt with the content type. Now let's specify the header of HTTP headers dot content disposition, and we'll set that to be in line, which will prevent the browser from downloading the image and just displaying it instead. And then we can pass in the body, which is our photo. And now we'll need to deal with a case where the photo doesn't exist. So we have an optional empty. So we'll say, or else response entity, not found, build. And then of course we'll need to return this. There we go. So there we have our get photo endpoint. Take the ID from the URL, use it to look up a photo using the photo service. If it exists, then return it with the correct media type. We use the media type factory for that. Otherwise, we return a HTTP 404 not found. Now, this is all well and good, but at the moment, users will only be able to hit this endpoint if they're authenticated. Let's make it public because users will want to see images before they log into our site. So let's go over to the left-hand side here to project. We'll go to config, security config, and we'll expand this. So we're going to add a new request match in here. So we're going to put a new line after auth, and we're going to put a new matcher in here that says request matches, and we'll match the HTTP method of get to /API photos, and then we'll put a double asterisk just for anything after that. And we're going to permit all. There we go. So that means that any request sent with a HTTP get to this endpoint or anything after this endpoint will go permit all. So the user doesn't have to be authenticated to hit this endpoint. So with that done, let's try this out. So let's restart our backend. There we go. That's all done. So let's head back to our browser. So here we are back in our browser. So let's log in, test user, password. And now that we're logged in, let's head over to the admin page. Here we are. So let's now try uploading an image like we did before. This time, let's select this sushi. And if we click on upload, Great, that's uploaded fine, and this is the URL. So let's just open up the networks panel here. Network, scroll down. Let's select all in this case. Now let's paste in the URL from up here. And if we click on retrieve, perfect. We can see the sushi image that we uploaded. We take a look here. It's calling our API photos and then the ID of the image afterwards. We're getting a HTTP 200 back and everything seems to be working as expected. If we were to type in an image that doesn't exist, take a look at that request, 404 not found. Wonderful stuff. So in summary, we've implemented a GET endpoint at API photos ID to retrieve photos. We've used the response entity to control response headers and content type. We've updated our security config to allow public access to photo retrieval, and photos are served with inline disposition for the browser to display them. So let's recall what we've achieved in the photo upload module. In file storage design, we implemented the storage service interface for managing file operations, and we defined the methods for storing and retrieving files from disk. In custom exceptions, we created a hierarchy of custom exceptions for our application. Base exception serves as the parent for all custom exceptions. Storage exception extends base exception for file operations. And we've used runtime exception to avoid checked exception constraints. In storing files, we implemented file system storage service to store files on disk. We've used the @value annotation to configure the storage location path. We've initialized the storage directory with @postconstruct. We've implemented secure file storage with path validation and added error handling using storage exception. In retrieving files, we implemented the load as resource method to retrieve stored files. We've used Spring's resource interface for file handling. We've implemented error handling using optional. We've used the URL service to represent file system resources. And we've added logging for debugging file access issues. In uploading and retrieving photos, we implemented the photo service interface for defining upload and retrieval operations. We created the photo service import class to manage photo metadata and storage. We've used UUIDs to generate unique identifiers for our photos, and we leveraged the existing storage service for file operations. In Photo DTO and Mapper, we created a Photo DTO class to represent photos in API responses. We've used Lombok annotations to reduce the boilerplate code in the DTO. We implemented the Photo Mapper interface using MapStruct, and we set up automatic mapping between Photo and Photo DTO classes. In Photo Upload Endpoint, we created a photo controller to handle REST API requests, implemented the /API/photos endpoint for photo uploads. We've used Spring's multi-part file for file handling, connected the controller to our photo service, and returned a photo DTO with the photo's UUID and metadata. In error handling, we created an error DTO to standardize API error responses. We implemented global error handling with the controller advice annotation, added specific handlers for storage exception and base exception, included logging for debugging and monitoring, and used the response entity to control HTTP status codes. And finally, in photo retrieval endpoint, we implemented a GET endpoint at /API/photos/ID to retrieve photos. We used response entity to control response headers and content types. We updated the security config to allow public access to our photo retrieval, and photos are served with inline disposition for the browser to display them. In this module, we'll build the REST API endpoint that allows the creation of restaurants in our application. The module will be structured as follows. We'll first design the restaurant creation feature. We'll create a geolocation service, albeit a dummy one. We'll create the domain objects and interfaces. We'll implement the core business logic. We'll create data transfer objects, or DTOs. We'll create the object mappers. We'll create the REST controller, and then we'll set up some test data. Now for the learning objectives, so by the end of this module, you'll be able to implement a dummy geolocation service for use in this module. Implement the necessary service level domain objects and interfaces for the create restaurant functionality. Implement the service classes for create restaurant functionality. Implement the data transfer objects, or DTOs, for the create restaurant functionality. Implement the mapper classes for create restaurant functionality. Implement the controller classes for the create restaurant functionality. And finally, implement a manual test to import test restaurants data into the application. So with that covered, let's get started. In this lesson, we'll explore how to add location capabilities to our restaurant review platform by implementing a simplified geolocation service. Geolocation services convert postal addresses into geographical coordinates, that's latitude and longitude. And while a real-world application may use a live service such as OpenStreetMap, we'll create a simplified version that just generates a random coordinate somewhere within London. And this approach lets us focus on implementation without integrating with a third-party service. So here we are back in our IDE. Now, in order to represent the latitude and the longitude, let's create a geolocation domain object. So inside of the domain package here, I'm going to create a new Java class, and I'm going to call this one Geolocation. There we go, and let's expand this. So as we've been doing, we're going to add the @data, all_ours constructor, no_ours constructor, and we'll add the builder annotation as well. And now we'll specify the instance variables, private, double, and our first one will be latitude. And then the second one, private, double, will be longitude. There we go. So with that done, let's now create our geolocation service. So back into project here, let's go to services, and inside of services, we'll create a new Java class, and we'll call this one geolocation service, and this will be an interface rather than a class. And let's expand this. So the geolocation service is only going to have a single method, returning a geolocation. We'll call this method geolocate, and we'll pass a single argument to this method, which will be our address. We'll call this one address. So with that done, let's now go to our import package here and create a new Java class, and we'll call this one random London geolocation service. And let's expand this, and we'll say implement geolocation service. And if we hover over the red squiggle, implement methods, okay. And now we have a method stub of our geolocate method ready to implement. Before we do, however, let's put the @service annotation on the top of this class so we don't forget. And let's get to implementing geolocate. So this class is the random London geolocation service. So we'll need to represent the bounding box that we're going to generate our random coordinates in. The bounding box roughly covering London. So let's represent the minimum and maximum latitude and longitude that we're going to be using, and we'll create some private static finals for this. So private static final, and let's copy that. And this first one will be a float, and we'll call this one min latitude. And the value for this will roughly be 51.28. And our next one will be a float again, max latitude, and the value for this one will be 51.686. So that's our minimum and maximum latitude. Let's now represent the minimum and maximum longitude. Private static final float, min longitude, minus 0.489f. Private static final float, max longitude equals 0.236f. So don't worry too much about the values that we're using here. You can use any bounding box anywhere in the world. This one happens to roughly be over London, so we're going to use this one for this service. So now that we have our bounding box, we can use it inside of our geolocate method. Let's create a new random. Let's assign that to a variable. Of course, we could do this inside of a constructor or inject it, but as this is a test class, we'll just create a new one inside of this method. And let's work out a random latitude to begin with. So latitude, and we'll say min latitude plus random next double, and then we'll multiply that by the max latitude minus the min latitude. And that should be enough to give us a random latitude. Let's now do longitude. Double longitude equals min longitude plus random next double multiplied by max longitude minus min longitude. There we go. And with those values, we'll now return a geolocation build, populating the latitude with latitude and the longitude with longitude. Okay, let's just format everything and let's review our implementation here. Okay, we'll need to change max longitude to be min longitude as the base. That would be a bug otherwise. Otherwise, the random generation functionality looks correct. And with that, we have our initial implementation of our random London geolocation service. So in summary, we created a geolocation domain class to represent the geographical coordinates. We defined the geolocation service interface for our location operations. We implemented a random London geolocation service to generate test data, and we used the bounding box concept to limit the coordinates to London. In this lesson, we'll build the foundation for creating restaurants in our review platform by designing the service layer components. This builds upon our previous work with the geolocation service, adding the necessary structures to handle restaurant creation requests. So here we are back in our IDE. Now let's look to create the restaurant create update request class, which will capture all of the information that we need to create and update restaurants. So over in domain here, I'm going to create a new Java class, and we'll call this one restaurant create update request. There we go, and let's expand this. And we'll put the @data, all R's constructor, no R's constructor, and builder annotations on the top here. And now we can start populating this class with some instance variables. So the first thing that we'll need to know is the name of the restaurant to create. We'll also want to know the cuisine type. So we'll create an instance variable for that one too. We'll want to know the contact information of the restaurant. We'll also want to know the address of the restaurant. So import address. We'll want to know the operating hours of the restaurant. Operating hours. There we go. And we'll also want a list of photos, so a list of string, which represents the photo IDs. So once a photo is uploaded, an ID is returned, and that ID will be provided in this list. And that's it for the class. All of the boilerplate code is going to be handled for us by Lombok. So let's now create our restaurant service. So let's go over here to project. Inside of services, we'll create a new Java class, and we'll call this one restaurant service, and this will be an interface. And let's expand this. There we go. So let's declare our create restaurant method. So this will return a restaurant. The method is called create restaurant, and we'll pass in our restaurant create update request, which we'll simply just call request. There we go. So passing in a restaurant create update request should return a restaurant after it's been created in the persistence layer. And that will do for the moment. We'll handle all of the service and the web layers in the upcoming lessons. So in summary, we created a restaurant create update request class to capture the restaurant details. And we defined the restaurant service interface with the create restaurant method. In this lesson, we'll implement the restaurant service interface by creating a new service class that handles the restaurant creation, building on our previously designed domain objects and interfaces. So we're back in our IDE. Inside of our import package here, let's create a new Java class, and we'll call this one restaurant service import. And let's expand this, and let's say implement the restaurant service. There we go. We'll hover over the red squiggle, implement methods, okay, and that will give us our create restaurant method stub ready to implement. Before we do so, let's put the @service annotation on the top of this class, and now we can get to implementing create restaurant. Now the implementation is going to need two collaborators. So let's put the required R's constructor on the top here, and then declare a private final, and we'll need the restaurant repository, and we'll also need the private final geolocation service, which we'll call geolocation service. So let's delete return null, and let's start our implementation. So let's first get the address from the request. So we'll say request dot get address, and let's assign that to a variable. We'll simply call that address. Now let's call the geolocation service dot geolocate on the address, and that, if we assign that to a variable, we'll call geolocation, and we happen to know that's going to give us a random location somewhere in London. But if this geolocate method was calling an actual live service, this should give us the latitude and longitude of the postal address here. So we now have a geolocation. Let's move on to handling the photos. So first, let's get hold of the photo IDs. So we'll go request dot get photo IDs. We'll assign that to a variable called photo IDs. But this is just a list of strings. We'll need to save photo objects in Elasticsearch. So let's go ahead and create those. So we'll say photo IDs stream.map. We'll call the argument photo URL, and then we'll say photo.builder.build to create ourselves a photo object, and we can define the URL as the photo URL, And then we'll define the upload date as local date time.now. And then we can call toList, assigning this to a variable, and that will be our photos. So we have our geolocation, and now we have a list of photo objects. Let's just scroll down. Let's now look to create our restaurant object. So we'll say restaurant.builder.build. Let's assign this to a variable called restaurant. And now let's work on this builder. Specify the name of the restaurant as request.name. So we'll get that directly from the create update request. The cuisine type will do the same thing, request, get cuisine type. Contact information, exactly the same, request, get contact information. Address, we'll pass in the address. The geolocation, we'll pass in the geolocation that we created just up here on line 27. We seem to have a red underline, let's see why. Yes, of course, because we want to save a geo point rather than a geolocation. The geolocation is our object. However, the geo point is Elasticsearch representation of the latitude and longitude. So let's go back up here. And from the geolocation, let's create a geo point. So we can say new geo point, making sure that we get the one from Elasticsearch. And then the arguments for this one are a latitude and a longitude. So we can say geolocation gets latitude, geolocation gets longitude. We'll assign this to a variable, which we'll call geopoints. And then we can pass in the geopoint like so. Next, let's do operating hours. Let's just scroll down. Specifying the operating hours that were passed in the request. Request, get operating hours. Average rating. Well, this is a brand new restaurant, so I think the average rating is going to be 0 because it doesn't have any reviews at this point in time. And then we'll pass in the photos, this requiring a list of photo objects. So we can pass in photos from up above. And with that, we have our restaurant object. All that's left for us to do now is to save this in Elasticsearch and return it. And to do that, let's just scroll down. We can call the restaurant repository dot save, passing in our restaurant, and then we can return this. There we go. So in summary then, we're extracting the address from the request here, calling the geolocation service, passing in the address in order to get a geolocation back, so a latitude and longitude. We then convert that into a geopoint, which is the type that Elasticsearch needs. We then extract our photo IDs, creating photo objects, and then we create our restaurant object, passing in all of the information from the request. In addition to the geopoint and the photos that we've created here, we initialize the average rating to be 0 because there's going to be no reviews, at least not initially anyway, and then we return the restaurant repository. Now we'll likely have to revisit this when we update our restaurant. However, for the time being, setting it to be 0 because we're implementing the create case should be enough to get us going. So in summary, we implemented the restaurant service import class to handle the restaurant creation. We used the geolocation service to convert the address to coordinates. We created the photo entities from the provided URLs. And we built the complete restaurant entity with an initial 0-star rating. And then we saved the restaurant using the restaurant repository. Let's now implement DTOs for our create update restaurant request. So back in our IDE, let's now go to our DTOs package, and we're going to create a new Java class, and we'll call this one restaurant create update request DTO. Let's expand this. Let's just fix the typo in restaurant. There we go. So let's now put the Lombok annotations on the top, data, all R's constructor, no R's constructor, and builder. And now we can start adding some instance variables. In fact, let's go over to our restaurant create update request. So this one here, we're going to copy these instance variables and we're going to place them directly into our DTO. Expanding that once more, but that's not all. Let's now add some validation to these instance variables. So for the name, let's add the not blank annotation coming to us from Jakarta validation constraints. And we'll add the message here, restaurant name is required. So when the name isn't provided, then we get that validation response. For cuisine type, we'll also use the not blank annotation, but let's say the cuisine type is required. For the contact information, let's also put the not blank annotation on there, saying that the contact information is required. And now we have the address. Of course, we don't want to use an address entity inside of a DTO. We'll want an address DTO, which currently doesn't yet exist. So let's create one now. Let's go over to project here inside of DTOs, we'll create a new Java class, and we'll call this one address DTO. The same lombok annotations on the top. And to speed us along, let's go to the address entity. Let's copy all of the instance variables, place them inside of our address DTO, removing the field annotations because we won't need those inside of our DTO. There we go. And now we have an address DTO to work with. So we'll also add some validation annotations to the address DTO class. We'll add the not blank annotation to the street number, which of course we're representing as a string. So let's also put a regex on here to make sure that it's valid. And we can do that by using the app pattern annotation. For street name, let's use the not blank annotation again. For unit, we won't do any validation because that's optional. For city, we'll also use the not blank annotation, saying that the city is required. For state, we'll also do not blank. State is required. Postal code also. Postal code is required. We could also put a regex on the postal code, but as that differs by region, we won't do it in this case because that could get quite complicated. And then country, we'll say not blank. Country is required. So that's our first iteration of our address DTO, which we can now use inside of our restaurant create update request DTO, which is here. So address DTO, very good. Of course, we'll also want to use an operating hours DTO as well. So let's specify that there so we don't forget. And let's get to creating an operating hours DTO. Inside of DTOs, new Java class, operating hours DTO. We'll do the same as we've done before. So let's find our operating hours. Let's take these fields. Let's put them into our operating hours DTO, expanding this. Let's remove the field annotations. There we go. And this one is using TimeRange, which is also an entity. So we'll need to go ahead and create a TimeRange DTO. Let's replace all references to TimeRange with TimeRange DTO. And then we can create a new Java class, TimeRange DTO. Data, all hours constructor, no hours constructor, builder. So we'll do the same, go over to TimeRange. This has an open time and a close time. So open time, close time. And let's now put some validation on the top of these instance variables. We'll say not blank with the message open time must be provided. And we'll do the same for the close time. Close time and open time must be provided. But let's also put a regex validation annotation on here as well to make sure that it's in the correct format. So a string representing a time. So we can use the app pattern annotation for this. And we can see here the colon in the middle and then the numbers on either side. So this pattern will work for both the open time and the close time. Breaking this regex down is sort of outside of the scope, but it's enough to say that this will represent a time format, the same time format for both open time and close time. So that's our TimeRange DTO. So we can go back to our operating hours DTO, make sure we've got the annotations on here, all hours constructor, no hours constructor, and builder. And then we have a TimeRange DTO representing Monday through Sunday. But we do have our operating hours DTO, which we can now use if we go up one level more to our restaurant create update request DTO, where we're specifying operating hours. Now, as both the address DTO and the operating hours DTO are nested objects, and they have validation annotations on the top, we can put the @valid annotation on the top of each of them to make sure that the validations are evaluated. So that's name, cuisine type, contact information, address, operating hours. That just leaves us with photo IDs. And we want to make sure that at least one photo ID is provided. And for that, we can use the @size annotation. So we'll say min of 1 with the message, at least one photo ID is required. There we go. So we now have a DTO representation of our restaurant create update request. And in doing so, we've created an address DTO, which we can see here with validation annotations on the top. We've also created an operating hours DTO, which required us to create a TimeRange DTO, which again, we can see the annotations on the top here. So to make sure that they are evaluated, we can put the @valid annotation on the top here. And then we have our photo IDs, which complete our restaurant create update request DTO. And that's all the DTOs that we'll need on the create side of things. But we're going to need to return a representation of a restaurant, so we'll need to create a restaurant DTO now. So let's open up our project here. And then in DTOs, we're going to create a new Java class, and we're going to call this one restaurant DTO. And let's put the data, all hours constructor, no hours constructor, and builder annotations on the top here. And then we need to add some instance variables to our restaurant DTO. So for that, let's go to our restaurant entity. Let's copy all of the fields that we have here. Let's place them into our restaurant DTO. And let's remove all of the annotations because we won't be needing those. So ID is removed, field is removed. Let's remove the rest of these. There we go. So for things like string and for float, we can leave those as is, but anything that's an entity, we'll need to replace with a DTO. So the GeoPoint in this case isn't strictly an entity, but it comes to us from Elasticsearch. So we'll want to decouple this and create a presentation layer representation of our GeoPoint. So let's go over to our project here. And then inside of DTOs, we're going to create a new Java class, and we'll call this one GeoPoint DTO. Data, all hours constructor, no hours constructor, and builder. Now the GeoPoint DTO is just going to have two values, a private instance variable of the double type, which we'll call latitude, and a private double, which we'll call longitude. We don't need to add any validation to these instance variables because we'll only ever use this DTO on the return path, not on the create or the update path. So we can use our GeoPoint DTO now inside of our restaurant DTO. There we go. For the address entity, we already have an address DTO, so let's replace that there. Operating hours, we already have an operating hours DTO. List of photos, well, we already have a photo DTO, so we can use a list of photo DTOs there. List of reviews, we don't yet have a review DTO. So let's copy all of the instance variables from our review, and then let's create a new class in our DTOs package here, and we'll call that one review DTO. Data, all hours constructor, no hours constructor, and builder. Again, we'll copy those instance variables in. We'll remove the field annotations from the top because we won't be needing those. So if we look at the instance variables, ID is fine, content's fine, rating's fine, date posted and last edited are fine. List of photo we'll replace with photo DTO. And now for user. So we don't yet have a user DTO. So let's go ahead and create one of those. New Java class, user DTO, data, all hours constructor, no hours constructor, and builder. And we'll need to represent the same information in our user here. So we're going to copy these instance variables, go back to the user DTO, paste them in. Let's delete all of the field annotations. There we go. And now we can take our user DTO and we can use that in our review DTO. We can then use our review DTO inside of our restaurant DTO. There it is. And the created by in restaurant, we can replace that with the user DTO that we've just created. So with that, we also have the return path. So the restaurant DTO representing the restaurant that we've just created. So in summary, we created the TimeRange DTO and OperatingHours DTO classes to handle restaurant opening times. We created the address DTO to represent the restaurant's postal address. We created the restaurant create update request DTO for new restaurant creation. And we created the restaurant DTO to represent the created restaurant. In this lesson, we'll implement the mapper classes to go from our entities to DTOs and back again during our create restaurant flow. So here we are back in our IDE. So let's scroll down to mappers here and we're going to create a new Java class and we'll call this one restaurant mapper. And this will be an interface rather than a class. And let's expand this. To the top of the class, we're going to add the mapper annotation where the component model is going to be Spring. And just like before, we're going to use the unmapped target policy of ignore. So ignore any fields that you can't map. So this restaurant mapper needs to deal with the entities and DTOs, both on the information that's received from the user and also returned to the user. So I'll create update restaurant DTO and also the restaurant DTO that's returned. So let's first do the restaurant create update request. So we'll create a method that returns a restaurant create update request. And we'll call this method to restaurant create update request. And we'll pass in our restaurant create update request DTO. And we'll call that one DTO. And because these objects are near enough identical at this point in time, we don't need to do any additional configuration. That should be enough to take our create update request DTO and convert it into our create update request object that can then be used in the service layer. Now let's do the return path. So this one will return a restaurant DTO, and we'll call this one to restaurant DTO, and we'll pass in a restaurant, which we'll call restaurant. Now there's an additional piece of configuration that we need to do at the moment because we're using that Elasticsearch GeoPoint object. We need to tell MapStruct how to convert between the GeoPoint and our GeoPoint DTO. To do that, we're going to declare a new method down here, returning a GeoPoint DTO, and we'll call this one to GeoPoint DTO, and it will accept a GeoPoint, which comes to us from Elasticsearch, and we'll call that one GeoPoint. And now we'll add two mapping annotations to the top here. And here we can specify how to do the mapping. So the target is going to be latitude, and we're going to specify a Java expression here, Java, which is going to be geoPoint.getLat, which is the method that returns the latitude on the GeoPoint. And then we'll need to do the same for the longitude. Mapping target equals longitude, where the expression is a Java expression, geoPoint.getLon. And there we go. With the exception of the review, which we'll deal with more later, that should be enough to convert everything that we need from the restaurant to the restaurant DTO and then return that to the user when they call our REST API. So in summary, we created a restaurant mapper with custom mapping methods and added support for geolocation data conversion. Now that we have our service layer, DTOs and mappers in place, let's create the REST API endpoint that allows users to create new restaurants in our application. So here we are back in our IDE. So let's go to our controllers package here and create a new Java class, and we'll call this one restaurant controller. And let's expand this. So let's add the @REST-controller annotation to the top of this class, marking this as a REST controller. And then we can add a request mapping for the class, and we'll specify the path of API restaurants. And as we'll also want several collaborators in this class, we're going to add the required args constructor. So that combined with the REST controller annotation will inject our dependencies for us. So we'll say private final, and the first dependency we'll need is the restaurant service. There we go. We'll call that one restaurant service. And we'll also want the restaurant mapper that we've just created, restaurant mapper, and we'll call that one restaurant mapper. So now that we have these two dependencies, we can use them in the endpoint. This endpoint is going to be a post mapping. The user is going to post the restaurant to this endpoint. Public, we're going to return a response entity of restaurant DTO. So the DTO representation of the restaurant that was created. And we'll call this endpoint create restaurant. Now for the arguments, it's going to accept a restaurant create update request DTO. We'll call this one request. We'll need to mark this with the request body annotation. And we're also going to mark this with the @valid annotation, which will make use of all of those validation annotations that we've put on our DTOs. So now that we have our request body, which is a representation of our restaurant create update request DTO, let's now use it. So let's convert this DTO into the object that we're using in our service layer. So restaurant mapper dot to restaurant create update request, passing in our request. We'll assign this to a variable like so. And let's just format this. There we go. So we now have the object that we can use in our service layer. So let's call our restaurant service dot create restaurant, passing in our restaurant create update request. And that should create for us a new restaurant. So all that's left for us to do with this restaurant is convert it into a DTO and return it to the user. So we're going to say restaurant mapper dot to restaurant DTO, passing in our restaurant. We'll call this one created restaurant DTO. And then we can return a response entity dot OK, passing in the created restaurant DTO. And there we have our create restaurant endpoint. So let's try it out. Let's start or restart our application. There we go. That's our application started up fine. So let's now head over to our front end. So here we are back in our browser on localhost 3000. So let's go ahead and log in. And we'll use the user test user, and the password is password. Click on sign in, and we have signed in. We have the U for user here. So if we then click on add restaurant, we have the create new restaurant form. So before we fill this in, let's go to inspect and then go to the network tab. And then we can start filling this information in. So restaurant name, let's go with test restaurant. Cuisine type, test cuisine. Contact information, 123.123.123. This, of course, is test data. For the address, we'll go with 123 Fake Street. We'll not provide a unit as it's optional. For the city, we'll go with the City of London. For the state, I believe that would also be London. And now for a postcode, we'll make one up, LO123ND. And the country, that will be the United Kingdom. So now we can populate some operating hours, remembering that we don't have to provide operating hours for each day, but when we do, we have to provide both the opening time and the closing time. So let's select some times here. Bearing in mind at the moment, we haven't any validation to say that the closing time must be after the opening time. So we can provide any value, providing it's in the correct format. So numbers, a colon, and then another set of numbers. So we're going to leave Saturday and Sunday as blank, which models the restaurant being closed on both Saturday and Sunday, but open every day during the week. So with that done, let's scroll down here, and now we can select some photos of our restaurant. So we'll use these dumplings here, I think. Great, so we can see the call to the photos endpoint. So if we scroll down here, we now can click on submit restaurant, and this will create the restaurant using the new REST API endpoint that we've just implemented. Let's try it out. Okay, so we've got our request here. We have a HTTP 200. So let's take a look at the payload. So we can see our address modeled here. We haven't provided a unit, contact information, cuisine type, test cuisine, the name, test restaurant. We take a look at the operating hours here. We can see Monday, Tuesday, Wednesday, Thursday, Friday have an open and close time specified, but Saturday and Sunday are null. And if we look at the photo IDs here, we have the photo ID of the photo that we've just uploaded. So it looks like our create restaurant endpoint is working as expected. So in summary then, we created a restaurant controller to handle HTTP requests for restaurant creation and tested the new endpoint worked using the user interface. Now that we've implemented the restaurant create endpoint, let's add error handling for our validation annotations. So here we are back in our IDE. Now, inside of our restaurant controller, we've added this @valid annotation to our restaurant create update request DTO. Now, providing all of the values are valid, then this object can be used in our service layer. However, if any of those validation annotations are triggered, then an exception will be thrown. And as we're not handling that exception at the moment, we'll get a HTTP 500. So let's deal with this. So let's head over to our error controller here. Let's scroll up to the top. And we'll add our new exception handler right here. So let's just expand this. So the exception that we're to handle is the method argument not valid exception. So we're going to add an exception handler annotation with the method argument not valid exception .class. We'll then say public response entity, and we're going to return an error DTO, and we'll call this one handle method argument not valid exception. And we'll need to pass in the method argument not valid exception, which we'll call EX. Now we'll follow the pattern that we've been doing so far. So we'll first log out the error. So we'll say caught a method argument not valid exception, and then we'll print that out. Now we can build our error DTO, but we want to provide a helpful error message here. So let's extract the details of the validation failure from the method argument not valid exception. And the way that we do that is by going ex.get binding result, and then we'll call get field errors. In fact, let's put this on some new lines, and then we'll call stream.map error, and then we're going to say error.getField, and we'll concatenate that with the error.getDefault message. And then we'll collect that. However, as our error DTO takes a string, we'll need to join this. So we'll say collectors.joining, and then we'll pass in a delimiter, which is going to be a comma and a space. So that will join all of the field and error message together into a single string that we can then assign to a variable here, which we'll call error message. There we go. So now that we have our error message, let's go about creating our error DTO. So we'll say error DTO.builder.build. We'll assign this to a variable called error DTO, and then we can start populating some values. So the status to begin with will return a HTTP status of bad request, so a HTTP 400. And for the message, we'll use the error message that we've just created. And we can now return a new response entity, passing in the error DTO, and we'll return a HTTP status of bad request. There we go. And with this addition, the method argument not valid exception will now be caught and handled, returning the relevant error DTO with some information that the caller should find helpful. So let's try this out. So let's start our application. Okay, that's the application started fine. So let's head over to our browser. So here we are back in our browser. So let's go ahead and log in. And we'll log in with test user and password. And there we go, we're logged in. We have the U up here. So let's add a restaurant. So here we are on the create a new restaurant form. So let's go ahead and fill this form in and try and trigger those validation errors. So we'll need to provide values for the restaurant name, cuisine type, contact information. The street number we have a validation set up for such that it requires a number. So let's provide some letters instead. That should trigger a validation error. Street name, unit, city, state, postal code, country. Now for operating hours, let's only provide the opening time and not the closing time. That should also trigger a validation error. And let's not provide any photos either. So if we now click on Submit Restaurant, we can see an error here. We can see that the street number is invalid. The operating hours, Monday close time is invalid there. We can see that the close time must be provided. And we can also see that at least one photo ID is required. So these are the validation messages that we've set on our annotations. Now it looks like our validation exceptions are being handled as expected. So in summary, we added error handling for the method argument not valid exception. Now that we have the restaurant creation functionality in place, we need to populate our application with some test data for development and testing purposes. So here we are back in our IDE. So let's now create ourselves a directory where we can save those test images. So this will be in our test directory here. We need to create a new directory in here called resources. And inside of resources, I'm going to create a new subdirectory called test data. And to test data, I'm going to add some images that I've downloaded from Unsplash. I'll attach those images to this lesson so you can use them too. So let's paste those in. Okay. And we now have the different images available to use. So that one for burger joint, that one for rustic olive. So these are the images that represent each of the fictional restaurants. So with that done, let's now create a test to load in this test data to our application. This is going to be a manual test, so we won't run it as a part of a test suite. We'll only run it when we want to load in that test data. So I'm going to create a new package inside of our test here, and we're going to call it Devtiro restaurant manual. And within there, I'm going to create a new Java class. I'm going to call this one restaurant data loader test. And let's expand this. So this is going to be a Spring Boot test. And now we can implement our test class. Now, I'm not going to write this one line by line because there's quite a lot of boilerplate code in here. So I'm going to make this code available to you so you can paste it in as well. So if we just do a high level summary of what we have here, we're auto wiring in our restaurant service, our random London geolocation service, our photo service, and then a resource loader so we can load our images. We have a test method here, which is create sample restaurants, which loads the images, uploads them. You can see here using the photo service. And then we create our restaurant data. You can see here the information for each of the restaurants. And then we have methods for creating the restaurant. So we have here the restaurant create update request, creating the address, and creating the standard operating hours. So basically it just creates all of these objects with test data and puts them into Elasticsearch via our services. So with our application running, if we were to run this test, there we go. Let's take a look at the output. Perfect. So we can see it's created all of the restaurants in the test data there. And it's done so successfully because the test has passed, which means in our next module, when we implement the search functionality, we'll be able to see all of this information in our user interface. So in summary, we created a test resources directory for our sample restaurant images. And we implemented the restaurant data loader test class to populate that test data. So let's recall what we've achieved in the restaurant create module. In geolocation, we created a geolocation domain class to represent geographical coordinates. We defined the geolocation service interface for location operations, and we implemented the random London geolocation service for test data. And this used a bounding box concept to limit coordinates to London. In create restaurant design, we created a restaurant create update request class to capture restaurant details, and then defined the restaurant service interface with the create restaurant method. In create restaurant service, we implemented the restaurant service import class to implement the restaurant creation. We used the geolocation service to convert addresses to coordinates, although our implementation just gives us a random location somewhere in London. We created photo entities from the provided URLs, built the complete restaurant entity with an initial 0-star rating, and then saved that restaurant using the restaurant repository. In create restaurant DTOs, we created a TimeRange DTO and OperatingHours DTO to handle restaurant opening times. We created the address DTO to represent the restaurant's address. We created the restaurant create update request DTO for new restaurant creation, and then we created a restaurant DTO to represent the created restaurant that we returned to the caller. In create restaurant mappers, we created the restaurant mapper class with custom mapping methods, and added support for geolocation data conversion, remembering that we're using Elasticsearch GeoPoint in our implementation. In create restaurant controller, we created a restaurant controller class to handle HTTP requests for restaurant creation, and tested a new endpoint worked using the user interface. And finally, in import test data, we created the test resources directory for sample restaurant images, and implemented the restaurant data loader test to populate test data in our running application. In this module, we'll add search functionality to our restaurant application by building a REST API endpoint. This will allow users to find restaurants based on search criteria. The module is structured as follows. We'll start by implementing our repository layer, and this is where we'll implement our custom Elasticsearch queries. We'll then move on to implementing our service layer, and this is where we'll choose which queries we want to use. We'll then implement our DTOs and our mappers, before then implementing our restaurant search REST API endpoint. So now for the learning objectives. So by the end of this module, you'll be able to update the restaurant repository to support restaurant search, update the restaurant service to support restaurant search, implement the necessary data transfer objects and mappers to support the restaurant search functionality, and implement a REST API endpoint that allows a caller to search for restaurants. So with that covered, let's get started. In this lesson, we'll enhance our restaurant repository interface with search capabilities. This will allow users to find restaurants based on criteria such as cuisine type, rating, and location. So here we are back in our IDE. So let's open up our restaurant repository here and let's expand this. We have a to-do here for some custom queries, so let's go ahead and add some. The first query that we're going to add is going to be a simple query. And we'll use this query to return restaurants that have so many stars or above in their average rating. So for example, only show me restaurants with over 4 stars. And to implement this, we can use Spring Data JPA's naming conventions. So we'll say we want to return a page of restaurant, that's import page, and we'll call this one find by average rating greater than equal, and then we'll provide a float, which we'll call min rating, and then we'll provide our pageable object because we're using pagination for this. So pageable. Now the naming convention is very important here, find by average rating greater than equal. Spring Data Elasticsearch is then able to work out the query based on this particular naming convention, similar to how we do in Spring Data JPA. So let's add another query now, and this will do fuzzy matching based on the restaurant's name and cuisine type. And we'll also make it so that this query can also filter based on average rating. This is one of those times where we're going to paste because the query is quite complicated. So let's do that now. You can find this in the lesson notes. So here we have our query, find by query and min rating. The name doesn't matter too much for this because it's the @query annotation where we specify the actual query. Now the details as to how to write an Elasticsearch query are sort of outside of the scope of this project. However, let's just go through this at a high level and understand what's going on. So there's 2 main parts to this query. The first part says that the average rating must be greater than or equal to $1, which is to say the first argument in a 0 index argument list. So query would be 0, min rating would be 1. So average rating must be greater than or equal to the min rating value provided here. Bear in mind that we can provide the value 0 as well. Now the second part to this query is here, and this is where our fuzzy matching happens. So first of all, we're doing fuzzy matching based on the name field, providing the value of $0, which is this query value here. We've set the fuzziness to auto to let Elasticsearch handle that for us. We also have another fuzzy match here, cuisine type. Again, we're passing in the same query, so $0, again, fuzziness auto. And this will make it so the query that we pass in matches either the name or the cuisine type. It doesn't matter which. And then we have this line here, which says that at least one of these should match. So we only return results where either the name or the cuisine type matches, fuzzy matches, our query. Let's just fix that brace there. And we're going to write one more query in our repository. And this one is going to be used for geospatial search, which we'll see a little bit later. Again, this is one of those times where we'll paste in and explain what we have. You'll find this in the lesson notes. So here we have the query find by location near, and we provide a latitude, a longitude, and a radius to this one. Although we could potentially update this query in order to do things like fuzzy matching on name and cuisine type, we're going to use this purely for geolocation search. And you can see the query here. We're using geodistance, where the distance is $2. So it's going to be 0, 1, 2, the radius. And then we have our geolocation object, $0 and 1, which is latitude and longitude. So that's to say, this is the point that we're concerned with. Return all records that are within the radius of this point. And we're using kilometers for this. And although we won't be using this on our restaurant search page, we will see this used a little bit later. And there we go. These are the 3 search queries that we're going to need for our project. So in summary, we've implemented basic search methods using Spring Data Elasticsearch naming conventions. We implemented fuzzy search using the @query annotation. And we created a location-based search method using Elasticsearch geoqueries. In our last lesson, we created repository methods to search for restaurants in various ways. Now, we'll build the service layer that will use these repository methods to provide an API for searching for restaurants. So here we are back in our IDE, and let's open up our restaurant service here and let's expand this. So we already have our method for creating a restaurant. Let's now add one for searching for restaurants. So this one is going to return a page of restaurant. Let's import page. And we'll call this one search restaurants. And this one's going to take several arguments. The first is going to be a string, which is our query. The next is going to be a float, which is going to be our min rating. A float, which is going to be the latitude. Another, which is going to be the longitude. Another one, which is going to be the radius. And then we'll have our pageable object. Now it's worth noting that with the exception of the pageable object, every single one of these objects can be null. And we'll handle that in our implementation. So let's head to the implementation now. So let's go to the implementation class, hover over here, we'll go implement methods, okay, and this will create us our method stub. Now let's put this on a new line so we can actually see the arguments that we're working with here. Let's put another one there we go. So let's now work through our search logic. So the first thing that we'll implement is when a user just provides a min rating and everything else is null. And this is the equivalent on the front end of clicking, say, the 4-star button and only getting restaurants 4 stars and above. We'll handle this one first because we're going to be using our min rating again when we do our fuzzy searching. So it's simpler that we just get this one out of the way. So we'll say if null does not equal our min rating, so if we have a min rating, and now we'll do another check to say if the query is null or the query is empty. And this makes sure that we don't have a query provided, because if so, we'll do that fuzzy matching. Then we're going to call restaurant repository dot find by average rating greater than or equal. And to that, we're going to provide our min rating, and we're going to provide our pageable object. Returning this, there we go. So if we just have a min rating, then we'll call that method there. So the next thing that we'll want to do is our fuzzy searching. And the query that we've written makes use of this min rating. And I've done that so we don't have to have 2 separate queries. But you very well could have one that uses min rating and one that doesn't. The way that we're going to handle this is when min rating is none, we're going to default it to 0, which essentially takes min rating out of the search, because all restaurants will have a min rating of 0 or above. So we're going to say float, And we'll call this one search min rating. And we'll say if min rating is null, then we're going to provide the float of 0. Otherwise, we're going to use the min rating as it's provided. And we can now use this in our query. So we'll say if null does not equal query. And in fact, we'll also say, and the query.trim is empty. So that's to say that we don't just have a white space query. Then we're going to return restaurant repository dot find by query and min rating, passing in our query string, the min rating, which we've normalized, so search min rating, and our pageable object too. So this will do a fuzzy search on both the restaurant's name and the cuisine type. And if we provide the min rating, it will also do a search based on min rating. The difference, of course, is that where we're doing a fuzzy search on the restaurant's name and cuisine type, we're not when it comes to min rating. That's hard criteria that we'll need to meet. Otherwise, we won't get that restaurant back in our search results. Now, next, we're going to handle our geospatial searches. So like I say, we're only going to be using this in a very specific place. And we're only going to call it providing that we don't have a query, a min rating, but we do have a latitude, a longitude, and a radius. So let's write that if statement now. So if null does not equal latitude, and null does not equal longitude, and null does not equal radius, so that's to say that we have everything we need to do a geospatial search, then we're going to return restaurant repository dot find by location near, passing in our latitude, longitude, and our radius, and of course our pageable object. There we go. And finally, if every single argument to this method is null, we're just going to return all of the restaurants. And for that, we can use one of the methods that we get on our repository for free. So we'll say restaurant repository dot find all, passing in our pageable object, and we can return this. And with that, we have our initial implementation of our search restaurants method. It takes several arguments, all of which can be null except for pageable. And then we call our various restaurant repository methods here. So returning average rating greater than or equal to, or find by query and min rating to do our fuzzy searching, find by location near to do our geospatial searches, or just return all restaurants that we have saved in Elasticsearch. So in summary then, we defined the search restaurants method in the service interface. We then integrated fuzzy text search for flexible matching, and added support for rating specific searches. When returning search results, we only want to return the data that's needed in order to populate the user interface. So let's create some dedicated DTOs for this now. So back in our IDE, let's head over to our DTOs package here and create a new Java class. And we're going to call this one Restaurant Summary DTO. Let's expand this, and we'll add our Lombok annotations of data, all ours constructor, no ours constructor, and builder. And now we'll add the instance variables that we need for this particular use case. Private string ID. We'll need the ID. We'll need the name of the restaurant because we'll need to display that on the card on the front end. We'll need to know the cuisine type, so private string cuisine type. Of course, we'll need to know the average rating. So we'll put average rating in there as well. We'll say private integer, and then we'll say total reviews because we'll need to display that number on the front end too. We'll also need to display the address of the restaurant. So we'll say address DTO, address. And finally, we'll need a list of photos. So a list of photo DTO, and we'll call this one photos. And of course, we'll need to import list. There we go. So this DTO only contains the instance variables that we'll need in order to populate the front end. So if we were to open up our restaurant here, put it on the right, expand this, like that, we can see that we have a very cut back version of our restaurant in our restaurant summary DTO, only returning the instance variables that we need for our particular use case. So with that done, let's now handle the mapper. So let's go over to our restaurant mapper, expand this. And now we'll need to add a new method to this one, returning a restaurant summary DTO. And we'll call this one to summary DTO, taking a restaurant, which we'll call restaurant. Now we'll need to do some configuration on our toSummary DTO method here because our restaurant summary DTO has this total reviews instance variable. And we're not storing that in Elasticsearch, so we'll need to work that out. So what we'll do is we'll create that method to begin with, which we'll call private integer populate total reviews. And then we'll pass in our list of review, which we'll call reviews, and we'll simply return reviews.size. We need to import list, of course. There we go. So we'll now put the @named annotation on the top here, and we'll call this one populate total reviews. So we can then reference it up here on our toSummary DTO mapping annotation, where the source is going to be reviews, the target is going to be total reviews, and qualified by name, of course, is going to be the name that we've just given it, populate total reviews. So that's to say we're going to take reviews from our restaurant, which we pass in here. The target is total reviews on our restaurant summary DTO. That's the name of the instance variable there that we want to populate. Qualified by name, populate total reviews, of course, references this named annotation here, which is to say that this is the method that we'll use to populate total reviews using reviews. So in summary, we created a restaurant summary DTO for lightweight search results. We added the toSummary DTO and populate total reviews mapping methods to the restaurant mapper. Now that we have our service layer and DTOs ready, we can create the REST API endpoint that will power our restaurant search functionality. Our goal is to make this endpoint accessible to everyone, whether they're logged in or not. So here we are back in our IDE. So let's open up controllers here and then go to our restaurant controller and let's expand this. So we have our create restaurant endpoint. Let's just minimize that. And let's add ourselves a new endpoint to search for restaurants. This one is going to be a get mapping. Of course, this is a public method, returning a page of restaurant summary DTOs. And we'll call this one search restaurants. And this is going to take several arguments. So let's define those now. So the first one is going to be the string Q, which is query. Naming the query parameter Q is a bit of a convention that you'll typically see for search queries passed as query params. But of course, you can name this whatever you like. We'll need to put the request param annotation on here, and we'll need to populate some information saying that required is false, because of course Q can be null. Next, we're going to provide a float, which is going to be the min rating. In fact, we'll just copy this annotation here because it's largely going to be the same for a lot of our arguments here. So the float of min rating, which of course can also be null. The float of latitude, which again can also be null. The float of longitude, which can also be null. Let's just scroll down. The float of radius, again, also nullable. And then we're going to say int page and then int size. And now we can use these to create our page request. So we're going to say request param on this one, but we're going to set a default value of 1. So the default page is 1. And for size, we're going to add a request param where the default value is going to be 20. So that's to say that we'll start on page 1, and by default, we'll return 20 results, or a maximum of 20 results. Now I'm defaulting to page 1 because that's what we're using in our front end. In actual fact, Spring Data Elasticsearch and Spring Data JPA uses 0 indexed page, so it actually starts at 0. So we'll need to handle that in our logic. So let's say restaurant service dot search restaurants. We'll need to pass in Q, which is our query, our min rating, our latitude, our longitude, our radius, and we'll need to create our pageable object. So we're going to say page request dot of page -1. That's where we're going to handle making it 0 indexed. And we're going to pass in our size. So let's assign this to a variable, which we will call search results. And then we'll return search results dot map. And then we'll call our restaurant mapper toSummary DTO. There we go. So we have our new search restaurants endpoint, and we've declared the request params that we're expecting. We then pass them on to our service layer search restaurants method. And then the results that are returned, we convert each to a restaurant summary DTO before returning them to the caller. So before we try this out, we'll need to make this public. So let's go over to our project here. We'll go to config, security config. Let's expand this. And we'll need to add a new line to our request matches. So request matches, and we're going to say HTTP method get, where the pattern is /API, restaurants, and then we'll do a double asterisk. And then we'll need to call permit all. There we go. So that's to say that any GET requests made to API restaurants and then we don't really mind anything after that will be permitted. So in our case, this is only the restaurant search endpoint. Because we go back to the restaurant controller here, we have API restaurants on the top here, and this is using a GET mapping. So all that's left for us to do is to try this out. So let's start or restart our application. Okay, we have an error here. Let's see why. No method found annotated with. Perhaps I've made a typo. Populate total reviews. Populate total reviews. Let's try again. Of course, it's private, where let's just make that default. Now if we try again, there we go. Okay, so that's our application started up fine. Let's now head over to our browser and try this new endpoint out. So here we are back on our front end. And if we scroll down here, we can immediately see that we are seeing restaurants, complete with their images, their names, their locations, etc. So to get a bit more information, let's go to inspect. Let's open up our networks tab here. Let's refresh the page and let's make sure the fetch XHR filter is on. So we can see that we're getting requests, a 200 response, but the request made to API restaurants and then passing in our page information. Page of 1, we only want 8 records returned. Of course, HTTP 200, and if we look in the response here, we can see our restaurant summary DTO. So we've got our ID, name, cuisine type, the average rating, total reviews, which of course is 0 for the moment because we haven't implemented that. We have an address, and then the photos, and the same for the other restaurants. If we scroll down to the bottom here, because we're handling that pagination, we should expect to get some different restaurants back. Yep, perfect. We got our last 2, Thai Orchid and the Burger Joint. If we take a look here, we can see page 2, go to headers. Page 2 is passed in the query params, size 8, but of course we only have 2 records left, so that's the only 2 that are returned. Now, unfortunately, we can't try out properly our filter by average rating because we haven't implemented ratings yet. However, if we do click that, we take a look at the queries that are being sent. Take a look at that last one perhaps. Min rating of 2, we don't get any results back. We take that off and we do. Not a great test, but once we implement some actual reviews later, we should see this working a little bit more impressively. So let's now try out our text search. So let's search for, I don't know, let's search for olive to try and get the rustic olive. So we'll go olive. Perfect. So we get the rustic olive back. Now let's try searching for a cuisine type. Perhaps we want to search for Japanese cuisine. Perfect. We get the sushi master back, which of course is our fictional restaurant. So it looks like we have some basic search working. We're able to filter by the average rating, and we're also able to search on the restaurant's name and cuisine type. The other type of search that we implemented was geospatial search. And the UI elements that are using this we'll see later, so we can't really test it via the user interface right now, but we can test it via Postman. So let's go ahead and do that. But the first thing that we'll need to do is try and work out the latitude and longitude of some of these restaurants. And to do that, we'll head over to Kibana. And we're going to use the console dev tool for this. And this allows us to send a query. The query that we're going to send looks like this, and you'll find this in the lesson notes. We simply want all of the restaurants to be returned. So let's go ahead and do this. There we go. So we have all of our restaurants returned now, and we can see the geolocation with the lat and the long. So I'm going to take these values and we're going to use them inside of Postman when we send our query. So here we are back in Postman, and I've populated the latitude and the longitude in the query string here. So we can see that we're calling localhost 8080 API restaurants. We're not passing in a query, page of 1, size of 8. So similar to how the user interface would do it. And then we're passing in our latitude, our longitude, and a radius of 1. So that's to say within 1 kilometer of the point on the Earth as represented by this latitude and longitude. So if we send this, we can see the restaurant which I took the latitude and longitude from, so the Golden Dragon here. If we scroll down, we don't see any other restaurants because there's no other restaurants within a kilometer of this one. Now, if we were to change this to say be 10 kilometers, send that and scroll down, we still don't have any. So let's change this to be 50 kilometers. So there's the Golden Dragon still. We have a restaurant here. We have another one here and another one here. So we get more restaurants back because we've increased the radius. I'm sure there's probably a radius which we can choose to only get a minimal amount of restaurants back. The Golden Dragon, the Greek House, Okay, yep, only 3 on that one. So there's only 3 restaurants within 20 kilometers of our initial search. So it looks like the initial implementation of our search is working as expected. So in summary, we've implemented the search results endpoint in the restaurant controller. We added support for multiple search parameters using @request_param, and we updated the security config to allow public access to API restaurants. So let's recall what we've achieved in the restaurant search module. In restaurant search repository, we implemented basic search methods using Spring Data Elasticsearch naming conventions. And we then created a location-based search method using Elasticsearch geoqueries. In restaurant search service, we defined the search restaurants method in the service interface. We integrated fuzzy text search for flexible matching, and we added support for the rating-specific searches. In restaurant search DTO and mappers, we created the restaurant summary DTO for lightweight search results, and added 2 summary DTO and populate total reviews mapping methods to the restaurant mapper. In restaurant search controller, we implemented the search restaurants endpoint in the restaurants controller. We added support for multiple search parameters using @request_param, and updated the security config to allow public get access to API restaurants. In this module, we'll build a REST API endpoint that allows clients to retrieve restaurant details from our application. The module is structured as follows. We'll create the service layer for the restaurant lookups first. We'll then build the REST API endpoints, and then we'll test our new REST API endpoint in the user interface. Now for the learning objectives. So by the end of this module, you'll be able to implement the service functionality required to retrieve a restaurant, and implement the REST API endpoint used to retrieve a restaurant. So with that covered, let's get started. In this lesson, we'll implement the functionality to retrieve detailed restaurant information by the restaurant ID, which will power the restaurant details page of our application. So here we are in our IDE. So let's head over to the services package here. Let's scroll down and let's open up the restaurant service, and let's expand this. So to the restaurant service, we're going to add an additional method, this one returning an optional of restaurant. Let's import optional, and we'll call this one get restaurant. I'm passing in a string ID. So we pass in the ID of the restaurant, and then we'll get the restaurant back if it exists. Otherwise, we'll get an optional empty. So with that done, let's go to the implementation. Let's hover over the red squiggle here, go implement methods, click on OK, and now we have our method stub ready to implement. So the implementation of this method is rather straightforward. We're just going to pass through the call to the restaurant repository. So we'll go restaurant repository dot find by ID, passing in the ID argument, and then we can return this. So find by ID is one of those methods that we get for free in our repository, and it's all that we need in order to implement our get restaurant method. So in summary, restaurant retrieval is implemented in the service layer via the get restaurant method. The method returns an optional restaurant to handle cases where restaurants aren't found. In this lesson, we'll build on our restaurant retrieval service to create a REST API endpoint that allows users to fetch detailed information about a specific restaurant. So here we are back in our IDE. So let's head over to the restaurant controller here and let's expand this. So let's add a new endpoint to this controller. So let's just minimize that and let's put a new line there, and let's specify a get mapping where the path for this one is going to specify the restaurant ID. So we'll say restaurant underscore ID, just like that. So the full path will be API restaurants and then the restaurant ID. And we'll say public, and this one will return a response entity of restaurant DTO. So that one there. And we'll call this one get restaurant. And then we'll specify our path variable. And we'll say restaurant underscore ID. In fact, let's just copy that from there, put that in there. There we go. And we'll say string, and we'll call this one restaurant ID. Let's just fix that typo. There we go. So that gives us access to the value that's in the path here. And now we can use it inside of our implementation. So we will return our restaurant service dot get restaurant, passing in our restaurant ID. Now we'll need to handle the case where it's either present or not present, because of course this returns an optional of restaurant. So we'll say map, giving this the name of restaurant. And in the case that we have a restaurant, then we're going to return a response entity dot OK, passing in the restaurant mapper dot to restaurant DTO, and then we'll pass in restaurant. And now we need to handle the case where the restaurant doesn't exist. So for that, we'll say or else. We're going to return a response entity dot not found dot build. There we go. So in this endpoint, we're calling through to the restaurant service using the argument passed in here, which is restaurant ID, which is the restaurant ID that's specified in the path. The service then uses the repository to look up the restaurant from Elasticsearch, and if it exists, it returns it. We convert it into a restaurant DTO, and then we return that. Otherwise, we return a HTTP 404 without a body, which is this response entity not found. So with that done, let's try this out. So let's start or restart our application. There we go. That's our application started up fine. So let's head over to our browser. So here we are back in our browser on our user interface. Here we can see all of the restaurants from our search restaurant endpoint. Let's now try out our get restaurant endpoint. So before we do, let's go inspect, go to our network panel. Now the way that we're going to try this new endpoint out is simply by visiting one of these restaurant pages. So let's click on the first one here. And if we scroll down, we can first of all see that the information is being displayed. That's great. There's our photo. We have the location on a map there. Bear in mind that the location for these restaurants is completely random. And if we scroll down, we can see some restaurants nearby, and then we can see that we don't have any reviews yet. So let's take a look at our networks panel and see what's going on. So we can see our call to our API restaurants and then the restaurant ID endpoint. So our get restaurant endpoint is returning a HTTP 200. We take a look at the response. We can see the restaurant details there, including the average rating, geolocation, the address of the restaurant, operating hours, and any photos associated with that restaurant. And this information is being used to populate this page. So we can see here information from the address, contact information, the cuisine, the name of the restaurant, of course. Now the front end's made a couple of these calls, but these two are exactly the same. If we take a look at this third one here, we have a call to the restaurant search endpoint. This one is specifying the latitude and the longitude of this restaurant, and with the radius of 20. So if we scroll down here, in fact, let's just pull this down a bit, we can see the restaurants nearby is being populated with this information. So we can see that these three restaurants are within 20 kilometers of this one here. So it looks like our search endpoint using geolocation is working as expected. Again, the front end has made a couple of these calls. And if we take a look here, we can see a couple of errors, some 500 internal errors. And that makes sense because this is our reviews endpoint, which we haven't implemented yet. So it looks like our get restaurant endpoint is working as expected. So in summary, we implemented the get endpoint at API restaurants and then the restaurant ID, and we leveraged the optional API for clean null handling. So let's recall what we've achieved in the restaurant retrieval module. In restaurant retrieval service, we implemented the get restaurant method in the service layer, and that method returned an optional restaurant to handle cases where the restaurants weren't found. In restaurant retrieval controller, we implemented the get endpoint at API restaurants and then the restaurant ID, and again we leveraged that optional for clean null handling, returning a HTTP 404 when the restaurant wasn't found. Our application needs to allow users to modify restaurant data after they've initially created them. In this module, we'll build a REST API endpoint to allow users to do just that. This module is structured as follows. We'll first design the update functionality. We'll then add error handling for restaurants that don't exist. We'll then implement the service layer, and then we'll create the REST API endpoint and test it out in the user interface. And now for the learning objectives. So by the end of this module, you'll be able to implement the necessary functionality in the service layer in order to update a restaurant. Implement an exception to represent a restaurant not being found and handle this exception in the presentation layer. Implement service layer functionality that allows a caller to update a restaurant. And implement a REST API endpoint which allows the caller to update a restaurant in the application. So with that covered, let's get started. In REST APIs, put operations typically require the complete representation of the resource being updated. Therefore, we're going to reuse the restaurant create update request domain object when implementing our restaurant update functionality. So here we are back in our IDE. So let's head over to our restaurant service here and let's add a new method to this interface, which we're going to use for updating our restaurant. Let's just expand this. And we're going to add a new method and we're going to return a restaurant from that method. This is going to be the updated restaurant. And we'll call this method update restaurant. And we're going to pass in the string ID of the restaurant to update. and we're going to pass in a restaurant create update request, which is going to represent the information that we'll use to update our restaurant. Now, before we go ahead and implement this method, we are going to have to deal with another error case here. So in order to update a restaurant, we must first retrieve the restaurant from Elasticsearch. We've already done this in our getRestaurant method here, and we're returning an optional restaurant. However, it doesn't make sense for us to return an optional from update restaurant. So we'll handle this error case by introducing a new exception. So in summary, update operations require the complete resource representation in REST, which is why we're reusing our restaurant create update request. And we've added the update restaurant method to the restaurant service interface. In our restaurant update functionality, we need to handle situations where a user attempts to update a restaurant that doesn't exist. Let's create a dedicated exception and handler to manage this scenario effectively. So back in our IDE, we're going to head over to the exceptions package here, and we're going to create a new Java class, and we're going to call this one restaurant not found exception. And let's expand this. And we're going to extend our base exception, remembering that's the class that we created a little earlier. That's going to be the parent exception of all of our custom exceptions in this application. Now we're going to right click, go generate, constructor. We'll select all of these. And there we go. We now have our custom exception that we can throw. So while we're here, let's head over to our error controller, expand this, and let's add the code to handle our new exception. So we're going to add a new method here, @exception handler. This one for the restaurant not found exception. We'll say public response entity error DTO. The error DTO, of course, representing our standardized error format. And we're going to say handle restaurant not found exception. And of course, we need to pass that in restaurant not found exception, which we'll call EX. So just like before, we're going to log.error, saying that we caught a restaurant not found exception. And then we'll pass in the exceptions that's logged out as well. And now we can get to returning the response. So we're going to need an error DTO. So we'll say error DTO.builder.build. We'll assign this to a variable, which we'll call error DTO. Now for the status, let's return a HTTP status of not found, which of course is a HTTP 404. The restaurant wasn't found. And for the message, we'll say the specified restaurant wasn't found. And that's our error DTO. So let's now return a new response entity. We'll pass in our error DTO and we'll say HTTP status not found. Now, whenever a restaurant not found exception bubbles up to the top, this method will catch it, returning a HTTP 404 with this error message to the caller. So in summary, we created a restaurant not found exception for handling non-existent restaurants. And we added an exception handler to return HTTP 404 responses. In this lesson, we'll implement the complete update functionality for restaurants in our service layer. So here we are back in our IDE. Let's head over to our restaurant service here. And we can see here we have one related problem, and that's because we haven't implemented our new method. So let's go implement methods, click on OK. And we now have our method stub for the update restaurant method. So let's expand this and let's get to implementing this new method. So the first thing that we'll need to do is get the existing restaurant from Elasticsearch. And for that, we're going to call getRestaurant, so this method up here, passing in the restaurant ID. Now this is going to return an optional. So we're going to say or else throw, and this is where we're going to throw our new restaurant not found exception. We'll pass in a message here which says restaurant with ID does not exist, and then we'll just pass in the ID of the restaurant there. Let's assign this to a variable, and there's our restaurant. So now that we have our restaurant, we can go about updating it. But before we do, we need to geolocate the new address that's been provided in the restaurant create update request. So we'll call geolocation service dot geolocate, passing in the restaurant create update request get address. And we'll assign this to a variable, which we'll call new geolocation. Let's just put this on some new lines. There we go. Scroll down. But of course, we can't pass in a geolocation to our restaurant. We're going to have to convert this into an Elasticsearch geopoint. So let's do this now. So let's say new geopoint, and And we're going to pass in the new location, get latitude, and then new location, get longitude. I'm going to assign this to a variable, which we'll call new geo point. So just like before, in our create method, we had to convert our photo IDs into photos. So we could use a private method for this, but I'm just going to copy this for the time being, and we'll place that in there. Restaurant create update request, which in fact we will just rename to be request, because that line's just getting a bit long. There we go. So we now have our photos, and now we can go about updating each of the individual fields on our restaurant. So let's say restaurant.setName, and we'll get that from request get name. Next, we'll do cuisine type, set cuisine type, from request get cuisine type. Contact information, request get contact information. And now the address, set address, from request get address. Now we'll set our geolocation, and we'll pass in our new geo point. Operating hours, so we'll say restaurant.set operating hours from our request.get operating hours. And now we'll do photos, so restaurant.set photos, and then we'll assign our photos variable up there. Now these names, restaurant and request, are quite similar, so just make sure that we've got them correct. Restaurant request, okay, so that's incorrect, that should be request, new geopoint request, and our photos. If we just scroll down a bit now, all that's left for us to do is call our restaurant repository.save, passing in the restaurant, and then we can return this to the caller. So in summary, we've taken our request here. We've retrieved the restaurant from Elasticsearch, throwing a restaurant not found exception if we can't find it, and that will result in the user getting a HTTP 404. We've then taken the address provided in the request and created a new geolocation object, which we then converted into a geopoint for use in Elasticsearch. We've then taken the photo IDs from the request, converting those into photo entities. This logic could be a bit more refined in order to maintain the upload date. However, as we're not really using this metadata anywhere, we'll not worry about that for the time being. And now we're updating our name, cuisine type, contact information, address, geolocation, operating hours, and photos before saving our restaurant and returning the new updated restaurant. Now, something you may notice is that we haven't updated the average rating, and that's because we want to maintain that between updates. The average rating is determined by the reviews and not the restaurant information, so we won't need to update that. But otherwise, this updates everything else on our restaurant. So in summary, we've implemented the full update method in the restaurant server simple. We've used the restaurant not found exception when the restaurant's not found, and we've preserved the average rating during updates. In this lesson, we'll implement the REST API endpoint that allows users to update restaurant details in our application. So back in our IDE, let's head over to our restaurant controller here and let's expand this. Now let's scroll down and let's minimize our get restaurants method because we're going to add a new one, a new endpoint. This one's going to be a put mapping, and the path for this one is going to specify the restaurant ID just like we have done above here. In fact, let's just copy this and place that in here. Public, this is going to return a response entity of the restaurant DTO, so the updated restaurant, and we'll call this method update restaurant. And of course, we'll need to get reference to that path variable like we have done in our get restaurant method. So path variable, restaurant ID. We'll assign that to a string called restaurant ID. And we're also going to get a valid request body, which of course is our create update request DTO, because we require a full representation of our restaurant when we update it, at least on a put endpoint, and we'll call this one request. Let's scroll down. So let's use our restaurant mapper to convert the DTO into a restaurant create update request. So let's pass in our request here, and let's assign this to a new variable. Put this on a new line. There we go. In fact, these lines are getting a bit long, so let's rename the request to be request DTO, and then we can call this one request. So now we can call our restaurant service dot update restaurant, passing in the restaurant ID and the request, so our restaurant create update request, and that will give us an updated restaurant, which we'll call updated restaurant. Alternatively, it may throw a restaurant not found exception, but that will be handled by our error controller. So all that's left for us to do now is to call response_entity.ok, and then we'll pass in the restaurant mapper to DTO, passing in our updated restaurant, and then we can return this to the caller, and that will return the updated restaurant with a HTTP 200. And with that, we've implemented our update restaurant endpoint. So let's start or restart our application. There we go. That's our application started up fine. So let's now head over to our front end and try this out. So here we are back in our front end. So let's go ahead and log in, test user and password. Great. And we're now logged in. So let's pick a restaurant here. Perhaps let's go to the second page. Let's pick El Toro. So here we can see the details of the restaurant. We have El Toro, picture, map, some restaurants nearby, no reviews just yet. Now, if we click on this little pencil icon here, we're able to update the restaurant. We're only able to see this because we're logged in. So let's make some changes to the information that we have here. El Toro, it might be at 20. And if we were to make some changes, it actually opened at 8. And we have our photo, which we'll leave as is, but we could very well delete it. So before we click on save, let's go to our inspect here. Let's go to network, clear that down. We have the API filter on to only see calls made to the API. So if we click on submit restaurant now, we're redirected back to the landing page. Let's take a look at our request. So we have a HTTP put and we have a HTTP 200 back. Let's take a look at the payload. So we can see the new name with some exclamation marks and street number 20. If we scroll down, let's take a look at the operating hours here. 8:01, 8:01, 8:01. So let's see if our restaurant information has been updated. First things first, let's go looking for El Toro. First of all, we can see the exclamation marks in the name there. And perhaps the easiest way to see our updates is if we just click on this pencil icon once more. Street number 20, 8:01, 8:01, 8:01. So it looks like our update endpoint is working as expected. So in summary, we've implemented a put endpoint with validation in our restaurant controller. And we've used the existing error handling for missing restaurants. That's our restaurant not found exception. And our endpoint returns updated restaurant details in the response. Let's now recall what we've achieved in the restaurant update module. In restaurant update design, we established that update operations require the complete resource representation in a REST API. And we added the update restaurant method to the restaurant service interface. In restaurant not found exception, we created a restaurant not found exception for handling non-existing restaurants. And we added an exception handler to return HTTP 404 responses. In restaurant update service, we implemented the full update method in the restaurant service import. We used the restaurant not found exception when the restaurant wasn't found. And we preserved the average rating during updates, as this is going to be based on the review and not the restaurant information. In restaurant update controller, we implemented a put endpoint with validation in our restaurant controller. We used the existing error handling for missing restaurants, and the endpoint returns updated restaurant details in the response. Every application needs a way to remove data that's no longer needed. So in this module, we'll build a REST API endpoint that allows callers to delete restaurants from the application. The module is structured as follows. We'll start by creating the service layer functionality to delete restaurants, and then we'll build the REST API endpoint to delete those restaurants. So now for the learning objectives. So by the end of this module, you will be able to implement the functionality in the service layer to allow a caller to delete a restaurant, and implement the REST API endpoint, which allows a caller to delete a restaurant. So with that covered, let's get started. In this lesson, we'll implement the delete restaurant method in our service layer to enable the deletion of restaurants from our platform. So here we are back in our IDE. So if we head over to the restaurant service, expand this, and if we head to the bottom here, we'll add a new method. This one's going to be a void method, which we'll call delete restaurant. And this method will only take a single argument, which is the ID of the restaurant to delete. So in comparison to some of the methods we already have, this one is rather straightforward. Now, if we go to the implementation, we hover over the red squiggle here, go to implement methods, make sure delete restaurant is selected, we'll go OK. And now we have our method stub ready to implement. The implementation of this method is just as straightforward. We're going to call the restaurant repository here, delete by ID, passing in the ID of the restaurant to delete. So the implementation is simply a pass through to the restaurant repository. Now you might be wondering about those two cases that we have. The case where the restaurant exists and we delete it, and the case where the restaurant doesn't exist, and therefore it already doesn't exist and we don't have to delete it. In both cases, Elasticsearch is going to handle this safely. So we don't have to worry about handling any exceptions in this case, at least none specific to our delete by ID operation. So in summary, the delete restaurant method is added to the restaurant service interface. There's no need to check the existence of the restaurant before deletion, as both cases are handled safely, and therefore the delete operation is safe to call multiple times. Building on our previous work with the restaurant service, we'll now implement the REST API endpoint that allows users to delete restaurants from our platform. So back in our IDE, let's head over to the controllers package here and let's open up the restaurant controller and let's expand this. So let's minimize update restaurant, as we'll not need to make any changes to that. And let's add a new method here. So this one is going to be a delete mapping. The path is going to specify the restaurant ID. So let's copy this from up here and place it here. This is a public method, returning a response entity of void. And we're using void because there's not going to be a response body in this case. It's going to be empty. We'll call the method delete restaurant. And then we'll need to get a reference to that path variable, so our restaurant ID. So let's copy this from up here because it's going to be exactly the same. Let's just scroll down. So the implementation of this method is going to be as straightforward as the service layer. We're going to call our service layer, restaurant service, dot delete restaurant, passing in our restaurant ID. And then we'll simply return the response entity dot no content dot build. And that will return for us a HTTP 204. So the HTTP 204 communicates that the operation was successful and there's no content returned to the caller. But it does communicate clearly that the resource no longer exists. And that's exactly what we want from our delete restaurant endpoint. So with it implemented, let's try it out. So let's start or restart our application. There we go, that's the application started up fine. So let's now head over to our front end. So here we are back in our front end. Here's all of our restaurants. So let's go ahead and log in so we have access to those buttons that we need. Test user, password. There we go, we're logged in. So let's head to the burger joint, I think. And now we don't just have an edit button, we also have a delete button now. But before we press it, let's go to inspect, open up our network panel, make sure that we're filtering by calls to API. And now we can try deleting our restaurant. So to do that, we're going to click on the delete button here. We get a modal. If we cancel, nothing happened, of course. If we click on delete, however, we can see that we're redirected back to the landing page. First and foremost, we're not seeing the burger joint in our list anymore. Let's take a look at the request. We have a HTTP delete call being made to restaurant specifying the restaurant ID, and we're receiving a HTTP 204. And of course, there's nothing to preview, there's no body because we're returning that response entity void. So just to be on the safe side, let's check page 2. Nope, there's El Toro, but we're not seeing the burger joint. So it looks like our delete restaurant endpoint is working as expected. So in summary, we've implemented the delete restaurants endpoint, and the delete operation returns a HTTP 204 on success. So let's recall what we've achieved in the restaurant delete module. In restaurant delete service, we added the delete restaurant method to the restaurant service interface. We established that there was no need to check the existence of the restaurant before deletion, as Spring and Elasticsearch will handle both cases safely, and therefore the delete operation is safe to call multiple times. In restaurant delete controller, we implemented the delete restaurants endpoint, and the delete operations return a HTTP 204 on success. In this module, we'll build a REST API endpoint that allows users to create restaurant reviews in our application. This functionality forms an essential part of the application, enabling users to share their dining experiences with others. The module is structured as follows. We'll start by designing review creation. We'll then tackle exception handling for reviews that aren't allowed. Then we'll implement the review creation service layer, then our data transfer objects and mappers, and finally our REST API endpoint. So now for the learning objectives. So by the end of this module, you'll be able to implement an exception to represent a review not being allowed and handling for this exception in the presentation layer. Implement the functionality in the service layer, which allows the caller to create a review. implement the data transfer objects and mappers required to implement the create review functionality, and implement the REST API endpoint that a caller can use to create a restaurant review. So with that covered, let's get started. In this lesson, we'll design the core components needed for creating restaurant reviews in our application. We'll create a foundation that allows users to submit reviews with text content, ratings, and photo references. So here we are back in our IDE. Let's start by creating a class that represents the data structure for creating and updating reviews. So let's open up source here, main, Java, and inside of the domain package, we're going to create a new Java class, and we're going to call this one review, create, update, request. Of course, the name of this class mirrors what we have on the restaurant side, but of course, this is devoted to reviews. So let's add those long block annotations, data, all hours constructor, no hours constructor, and we'll have builder too. We're going to have a private string called content to represent the text content of our review. We're going to have a private integer, and that's going to represent the star rating, the number between 1 and 5 representing the number of stars that the reviewer has given that particular restaurant. And we're going to have a private list of strings, and that's going to be our photo IDs. And let's import list. So there we go. That's our review, create, update, request class. So let's now look to use this in our service layer by creating ourselves a review service. So let's go to the services package here, and let's create a new Java class, and we'll call this one review service, and this will be an interface. And let's expand this. So as we're focused on creating reviews, let's define that method. So this will return a review, so the review that was created, and let's call the method create review. And to this method, we're going to pass in the user, which is the author of that review. And we're also going to pass in the string, which is the restaurant ID. And we're also going to pass in the review create update request, which we'll call review. So when we create a review, we need to know the author that wrote it. We also need to know the restaurant that it's associated with. And then, of course, we'll need the information about the review using the class that we've just created, review create update request. So in summary, we've created the review create update request class to capture the review submission data. We've used long block annotations to reduce the boilerplate code in those domain objects. And we've defined the review service interface with the create review method. In our restaurant review platform, we need to prevent users from reviewing the same restaurant multiple times or attempting to edit their review after the window is closed. We'll implement this by creating a custom exception and then adding the appropriate handling in the error controller. So back in our IDE, let's go to the exceptions package here, and we'll create a new Java class, and we'll call this one review not allowed exception. And let's expand this. Now, just like our other custom exception, we're going to extend base exception. Base exception being the parent exception for all custom exceptions in our application. We'll now right click, we'll go to generate, override methods, and we're going to select all of the constructors here and then click on OK. And with that, we now have our review not allowed exception, our custom exception, ready to use. So while we're here, let's add handling for our review not allowed exception. So let's open up our project here. We're going to go to controllers, error controller, and let's expand this. So we're going to add a new handler here. So let's define the annotation exception handler, and we'll pass in the review not allowed exception as the argument here. Public response entity, returning an error DTO, and we'll call this one handle review not allowed exception. And of course, we'll pass in the exception, so review not allowed exception, which we'll call EX. Now, just like we've been doing, we're going to log.error this out, saying we've caught, and let's just copy that, review not allowed exception, and then we'll also pass in the exceptions, that's printed out too. And now we'll create our error DTO to return to the user. So error DTO.builder.build, let's assign that to a variable, which we'll call error DTO. Now let's populate this with some data. So the status, this is going to be a HTTP 400. It's a bad request because the user has tried to update a review that they're not allowed to do. So we'll specify the HTTP status of bad request.value because of course we need the integer. So that will be 400. And for the message, let's say the specified review cannot be created or updated. There we go. And with that done, let's just scroll down. We'll return a new response entity, passing in our error DTO, and we'll use the HTTP status of bad request. There we go. So with that done, we've created ourselves a review not allowed custom exception, and we've handled it inside of our error controller. So in summary, we've created our review not allowed exception to handle duplicate review attempts, and also for when a user tries to update a review outside of the allowed window. We've added an exception handler in our error controller, returning a HTTP 400 response. And just like our other custom exceptions, this exception extends base exception for consistent error handling. Building on our review service interface from the previous lesson, we'll now implement the core logic for creating restaurant reviews, including handling photos and updating restaurant ratings. So we're back in our IDE, let's create ourselves an implementing class for our restaurant service. So we'll go to our services package here, we'll go to impl, and we're going to create a new Java class in here, and we're going to call this one review service impl. Let's expand this. Now this, of course, is going to implement the review service. And if we hover over the red squiggle, we can implement methods, selecting create review. There we go. So we can now implement our create review method. So the first thing that we'll want to do is get the restaurant using the restaurant repository. So of course, we'll need the restaurant repository. So to the top of our class, let's add the required ours constructor. And whilst we're here, let's also add the service annotation so we don't forget. Now we're going to declare a private final restaurant repository, which we'll call restaurant repository. And because of our required ours constructor, and this being final, the constructor will be generated for us. And of course, our restaurant repository is going to be injected, ready for us to use. So inside of our create review method, let's now call the restaurant repository. And then we'll go find by ID, passing in the restaurant ID. And this will return an optional. Now we've previously created a restaurant not found exception. So let's reuse that here. So we're going to say or else throw. And this is a lambda. So we're going to say a new restaurant not found exception. And we'll pass in the message here saying restaurant with ID not found. And then we'll pass in the restaurant ID. Let's put that on a new line so we can read it. There we go. And let's assign this to a variable, which we'll call restaurant. We don't need to worry about handling the restaurant not found exception because our error controller is already set up to handle that. Now that we have our restaurant, let's see if we already have a review for this user. So let's just scroll down a bit here. So we're going to say restaurant.get reviews. That will give us a list of review. And now we're going to stream on that. And we'll say any match. This is a lambda. So we'll say R for restaurant. R.get written by .get ID. And we'll say equals the author.getID. And let's reformat this a little bit. And let's assign this to a variable, which we'll call has existing review. So we'll get the reviews from the restaurant, and then we'll see if any of the reviews are written by the author passed in here by matching the IDs. And if we have a match, this will be true. And if we don't have a match, this will be false. And in this way, we can see whether or not the user has already written a review for this restaurant. So we'll say if we have an existing review, then let's throw a new review not allowed exception. And we'll say the message is user has already reviewed this restaurant. And that exception will then be handled by our error controller. So at this point, we know that the user hasn't already reviewed this restaurant. So let's go ahead and create that review. Let's start with the photos. So these are the photos that the user may have taken on their visit to the restaurant, and they're going to attach them to their review. So let's say review.get photo IDs, and that'll give us a list of string. So we're now going to convert those into a photo object. Stream.map. Now let's call that argument URL. So let's now create a new photo, photo.builder.build. We'll return that. And let's populate this with some information. Let's scroll down. So the URL of the photo, of course, is going to be our URL argument. And we'll also set the upload date to local datetime.now. And let's collect this into a list. Let's assign this to a variable, which we'll call photos. So we now have our list of photos. Let's use them when we create our review. So we'll say review.builder.build. Let's assign this to a variable called review to create. So we're going to assign a random ID to this review. So this is a nested object inside of our restaurant. Let's give it a way so we can uniquely identify it. And for that, we're just going to use a UUID. So we'll say UUID dot random UUID to string. For the content, well, we're going to get the content from the review create update request up here. So we'll say review dot get content. For the rating, we'll say review dot get rating. For the photos, we'll pass in the photos that we've created. For the date posted, well, it's going to be the time, the local date time now. So what we'll do is we're already using that here. Let's assign this to a variable, which we'll call now. Let's take it outside of the scope of that lambda. And now we can reuse that down here. The date posted is now. Last edited will be the same time. Written by, well, we'll pass in our user, which is the argument author. And then we call build, which will return our review. So we now have this review to create. So the next step is we want to add this review to our restaurant. So let's say restaurant.getReviews, and then we'll add the review to create. Let's scroll down. And now we'll want to update the restaurant's average rating. I think for this, we'll use a private method. So let's create that down here. So let's say private. Let's make this a void method. So this will actually do the updating. And we'll call this one update restaurant average rating. And it will take a restaurant as an argument. So let's first get a handle on the reviews. So we'll say restaurant.getReviews. We'll assign that to a variable called reviews. Let's scroll down. So if the reviews list is empty, then the average review is going to be 0. So let's just handle that case quickly. So we'll say if reviews dot is empty, then we're going to say restaurant dot set average rating to be 0, 0, and that's a float. Now in the case that reviews is not empty, so we actually do have some reviews, let's take an average. So we'll say reviews dot stream. Now we can call map to double. That may be the best way to handle this, or perhaps the most efficient way. So we'll say map to double review, and then we'll say get rating, and then we'll take the average, and then we'll say or else 0, 0, and let's assign that to a variable, which we'll call average rating. But of course we have a double here, and we want to use a float. So let's say restaurant dot set average rating, and then we'll simply cast to a float, passing in average rating. There we go. And that will update the average rating on our restaurant. So let's call this private methods. Next, up here, we need to pass in the restaurant. There we go. So we now have updated the average rating for our restaurant. So the next step is we want to save our restaurant into Elasticsearch. So let's scroll down. Let's call the restaurant repository.save, passing in the restaurant, and we'll assign this to a variable, which we'll call saved restaurant. There we go. And now we want to return a review from this particular method, so the review that we've created. So in order to do that, we'll need to filter out the reviews returning the created review. So perhaps the easiest way to do that is if we take our ID up here, we'll assign this to a variable, which we'll call review ID. And now we can use this to filter out the results. So we scroll down here, we can say return saved restaurant dot get reviews stream, and we'll say filter, we'll call the argument R. In fact, let's put that on a new line, and we'll say review ID dot equals R dot get ID, and we'll call find first, and that will give us an optional of our review. But of course, we'll need to handle that optional. Now, it's incredibly unlikely that will not have a review that matches our review ID because we've literally just saved it. So I think in this case, we'll just throw a runtime exception. Of course, you can create a custom exception for this, but I think it's very unlikely to ever occur on the basis that, well, we've saved our restaurant up here with the new review. So let's say or else throw, and we're going to throw a new runtime exception, and we'll create a message that says error retrieving created review. Now that runtime exception will be handled in a way, it will throw a HTTP 500, but if it is actually thrown, then a HTTP 500 would be correct because there certainly would have been an internal server error. So there we go. Let's take a look at what we have here. So first we get the restaurant, or we throw a restaurant not found exception. I think what we'll do while we're here is we'll extract this into a private method, and we'll call this one get restaurant or throw. So we get a restaurant, or we throw a restaurant not found exception. We then check to see whether or not that restaurant has any reviews written by this author. If they do, we throw a review not allowed exception, because a user can only write one review per restaurant. We then create a variable with the value of the local date time right now. We then convert our photo IDs into photo entities here. We then generate a review ID, which is a random UUID. We then go about creating ourselves a review using this builder pattern, populating it with the information from the review create update request. We then add the review to the restaurant. We update the restaurant's average rating. We then save the restaurant using the restaurant repository, so that will be saved in Elasticsearch. And then we return just the review that we've just created, filtering it out from the response. So in summary, we implemented the review service import class with duplicate review prevention. We created helper methods for restaurant lookup and rating calculations, and we updated the restaurant average ratings. Now that we've implemented the service layer for our create review functionality, let's now create the DTOs and the mappers that we'll need in our presentation layer. So here we are back in our IDE. Let's create the review create update request DTO class. So in main, in DTOs package here, we're going to create a new Java class, and we're going to call this one review create update request DTO. And let's expand this. So to the top of the class, let's add our Lombok annotations, data, all ours constructor, no ours constructor, and builder. And now we'll need to add our instance variables. So the first one that we'll add is going to be private, string, and content. But let's add some validations as well. So to the top of this, I'm going to add the not blank annotation. And we'll say the message, when it is blank, is review content is required. Next, we're going to add the private integer, which is the rating. And we'll add a few validation annotations to this one, I think. So as we're using an integer, we'll make sure that it's not null to begin with. And the message is rating is required. Next, we'll want to make sure that the rating is greater than 1. So we're going to use the @min annotation here, where the message is rating must be between 1 and 5. Let's just make sure. Oh, of course, we need to specify the value for our min, which is 1. And let's copy this. And we're going to need a max, which we'll import also. The value for our max is 5, and the message is going to be the same. So this makes sure that our integer is provided, that it's not null, it has a minimum of 1 and a maximum of 5. And that represents our star rating between 1 and 5. So finally, let's add a private list of string, and that's going to be our photo IDs. And we'll initialize this to be a new array list, and that will add some safer handling in there because it will never be null. So with our DTO in play now, let's now handle the mapper. So let's open up our project. Let's go to our mappers package, and we're going to create a new Java class. We'll call this one review mapper, and this is going to be an interface. And let's expand this. So just like before, this is going to be a MapStruct mapper. So we'll use the mapper annotation on the top. The component model is Spring. The unmapped target policy is reporting policy.ignore. So exactly the same as all of our other mappers. So now we'll declare our first method. This one is going to return a review create update request. And we'll call this one to review create update request. And this one will accept the DTO, which we'll simply call DTO. So that's our first method, and that's on the calling path. So the user will provide a review create update request DTO, will convert it to a review create update request for use in our service layer. Once we've created the review, we'll then need to return that. So we'll declare a second method, this one returning a review DTO, which is a class that we already have. We'll call this one toDTO, and it will pass into this one a review, which is our entity. And let's import review. There we go. And with that, we have our review mapper ready to use. So in summary, we've created a review create update request DTO class, and it validates incoming review data. It does that because we've added validation annotations to ensure the data quality. And we implemented the review mapper interface with a toReviewCreateUpdateRequest method and a toDTO method. In this lesson, we'll implement the REST API endpoint that allows users to submit reviews for restaurants, building on our previous work with the DTOs, services, and mappers. So here we are back in our IDE. So let's go ahead and create ourselves a new controller class here, new Java class, and we're going to call this one Review Controller. And let's expand this. So this class represents a REST controller, and we'll add the request mapping, where the path is going to be /API, and then restaurants, and then we'll have our restaurant ID, and then we'll specify reviews, and that's going to be the base path for this controller. We'll also put the required Ours constructor annotation on the top, and that will allow us to create a required Ours constructor rather easily. So let's now create our create review endpoint. This one is going to be a post method, so we'll use the post mapping annotation, and we don't need to specify any arguments to this one because the path is going to be exactly the same as the base path. We'll then say public, returning a response entity, and it's going to be a review DTO that we return. We'll call the method create review. And now for the arguments for the method. Let's first use the path variable annotation here to get a handle on the restaurant ID and the path here. So we'll call that one restaurant ID. Now the second argument is going to be the request body. So we'll say request body, and it's going to be a review create update request DTO. And we'll call this one review. And we'll also remember to put the @valid annotation as well to ensure that our validation annotations are triggered. And finally, we're going to use the authentication principal annotation, which will then allow us to get hold of the JWT, which we'll call JWT. Now, the authentication principal isn't always a JWT, but as we're using the OAuth2 resource server starter, and we've configured it to interact with Keycloak, we're going to be using that JWT. So let's now implement our method. Now, the first thing that we'll want to do is to convert our review create update request DTO into the object that we can use in our service layer. And for that, we're going to need our review mapper. So we'll say review mapper, we'll call that one review mapper, private final, and that will be injected for us. Whilst we're here, let's also say private final review service, as we'll almost certainly need to use that as well. Let's scroll down. So let's say review mapper dot to review create update request, passing in our review, which is our DTO. And let's assign that to a variable, and we'll call that one review create update request. Now, the next thing that we'll want to do is we'll want to call the review service dot create review. And the first thing that we'll want to do is pass in that user. But we don't have a user, we have a JWT. So let's go about converting between the two. There are various different options for this, but we're just going to use a simple private method. So we'll say private, this one returning a user, and we'll call this one JWT to user, passing in the JWT. And let's scroll down and implement this private method. So we'll return user.builder.build, and we'll populate the user with some information. So it's going to need the ID, given name, family name, and the username. For the ID, we're going to use the subject from the JWT. So we'll say JWT get subject. Now, because of the way our OAuth2 scopes are configured, we do have access to some additional information as well. The user's username, given name, and family name. So we're going to say JWT dot get claim as string. And for the username, the claim is preferred username. For given name, JWT get claim as string. It's given underscore name. JWT get claim as string. And for family name, it's family underscore name. If we decode our JWT using something like jwt.io, we will see this information in the JWT. All we're doing here is extracting it, placing it into our user object that we can then use in our create review method. Like I say, various different ways of approaching this one. This is just a very simple way of doing so. So let's call JWT to user, passing in the JWT, which was injected because we've used that authentication principal annotation. And we now have a user that we can pass in to this method. The next thing that we'll need to do is pass in the restaurant ID, and then we'll need to pass in the review, which is a review create update request, which we happen to have because of our mapping. This will create a review, so we'll get a review object back. So we'll say created review, And now we'll need to return this to the user as a review DTO. So let's say return response entity .ok, and then we'll call our mapper .toDTO, passing in our created review, and that will return a review DTO to the caller. So with that done, all that's left to do is for us to try out our new endpoint. So let's start or restart our application. There we go, that's our application started up fine. So let's now head over to our browser. So here we are back in our browser, and I've taken the liberty of logging in already. You can see here the little U in the top right, which indicates that we're logged in as the test user. So let's go ahead and write a review for one of our restaurants, perhaps the Greek House, as it's the first one on the list. So here we are on the restaurant details page, image, map, write a review button. Currently have 0 reviews. The stars aren't populated because, of course, the default average review is 0. We do have some restaurants nearby, however, but we don't have any reviews just yet. So let's go ahead and write a review. But before we do, let's go to Inspect, Network, and let's click on the Write the Review button. So here we can write a review. So for the rating, let's give this one 5 stars. For the content of the review, let's say the food was fantastic. And now we'll choose a photo. Any photo will do. We'll just pick that one as it's the first in the list. There we go. So we've provided a star rating. We've gone for 5 stars, the content of the review, and a photo. So let's click on Submit Review. Okay, so let's take a look at the requests. So the first request that we see here is a post to the photos endpoint. We get a HTTP 200, and we get the ID of that photo. So let's take a look at the next request, which is a post to the restaurant ID reviews endpoint. We also get a HTTP 200. We look at the payload. We can see the content, the food was fantastic, photo IDs of the photo we uploaded, the rating of 5. We take a look at the response. We can see an ID of our review, which is a random UUID, the content, the food was fantastic, rating of 5, the date and last edited photos, which is containing the ID of the photo that we uploaded, and then we have written by. And here we can see information from our test user. The username, test user, the given name is test, the family name user. And we have this ID here, which is the ID of the user inside of Keycloak. So we've been able to successfully extract this information from the token, so from the JWT. Now it should be said that we do have some requests which have failed. However, these are requests to the list reviews endpoint, which we haven't yet implemented, so that's expected. So let's take a look at this page. So the first thing to note here is that we have the stars populated. We now have 5 stars, which is great. However, we have 0 reviews. That's something that we'll need to address because we've added 1 review. Let's scroll down here. So here's our review. So we can see test user, the date, the description, the food was fantastic, and we can see 5 stars and the photo from our review. So that's looking great. But why up here does it say 0 reviews if we've added a review? So let's take a look at the restaurant details request, which is this one here. Get to API restaurants and then the restaurant ID. If we look at the response, we can see the Greek House, the average rating of 5, so that looks good. Address, operating hours, reviews, so we have a review in there. We have created by null, so we didn't actually implement the created by on the restaurant side of things, not that it'll matter too much. But the information that I'm not seeing here is the count of reviews this restaurant has received. Now we could very well just count the reviews in this array, but that's not what the front end does. Let's take a look at our back end once more. So here we are in our restaurant mapper. Let's just expand this. And we have this method populate total reviews. And what that does is it does a reviews.size and then returns that integer. Now we're using populate total reviews on our toSummary DTO. So whenever we return a restaurant summary DTO, we have total reviews populated. However, we're not using it on our toRestaurant DTO, remembering that we return a restaurant DTO from our restaurant get endpoint, which we use on our restaurant details page. Luckily, the fix is very straightforward. We're going to take this annotation, we're going to add it to our toRestaurant DTO method, and then we'll need to update our restaurant DTO to include the total reviews instance variable. This is a great example of why we use DTOs, so we can change them independently from the entities in our system. So if we go to our restaurant DTO here, let's scroll down to the bottom, I'm going to add a private integer total reviews. And if we restart our application now, there we go. That's the application restarted. Let's head back to our front end and let's refresh the page. Okay, so we can now see 1 reviews. So we take a look at the call to the restaurant details page. In fact, let's just refresh the page. There we go. We can now see total reviews in our restaurant DTO. So it looks like our create review endpoint is working as expected. So in summary, we created a review controller with a create review endpoint at API restaurants, restaurant ID, reviews. We implemented JWT processing to extract the user details. And we used the review mapper to convert between our DTOs and domain objects, adding that total reviews instance variable to our restaurant DTO. So let's review what we've achieved in the review create module. In review create design, we created a review create update request class to capture review submission data. We used Lombok annotations to reduce boilerplate code in domain objects, and defined the review service interface with the create review method. In review not allowed exception, we created the review not allowed exception to handle duplicate review attempts. We created an exception handler in error controller, returning a HTTP 400. And we made sure that the exception extends base exception for consistent error handling. In review create service, we implemented the review service import class with duplicate review prevention. We created helper methods for restaurant lookup and rating calculations, and we updated the restaurant average ratings. In review create DTO and mapper, we created a review create update request DTO class to validate incoming review data. We did so by adding validation annotations to ensure their data quality, and implemented the review mapper interface with a 2 review create update request and 2 DTO methods. In review create controller, we created the review controller with create review endpoint at API restaurants, restaurant ID reviews. We implemented the JWT processing to extract the user details, and we've used review mapper to convert between DTOs and domain objects. In this module, we'll build a REST API endpoint that allows clients to list and sort reviews for a specific restaurant. This feature is intended to enable diners to make informed decisions about where to dine by reading other customers' experiences. The module is structured as follows. We'll first implement the list review service layer, and then we'll implement the list review REST API endpoint. So now for this module's learning objectives. So by the end of this module, you will be able to implement the necessary service functionality to list restaurant reviews, and implement the REST API endpoint to list restaurant reviews. So with that covered, let's get started. In this lesson, we'll implement the functionality to list restaurant reviews with sorting and pagination capabilities. So here we are back in our IDE. So let's head to the review service here and let's expand this. Now we already have a single method to create a review. So let's add another one to list reviews. We're going to use pagination. So we're going to return a page of review, and let's import page. And we'll call this method list reviews, and it will take 2 arguments. So we need some way of identifying the restaurant. So we'll pass in a restaurant ID. And we're also going to pass in a pageable object. Let's import pageable, and we'll call this one pageable. And it's the pageable object that will include information on what page we're on, what the size of the page should be, and then any sorting behaviors as well. So let's head to the implementing class, hover over the red squiggle and go implement methods. Let's click OK. There we go. So there's our method stub for list reviews. Let's delete return null. Now, reviews are a nested object inside of our restaurant. Therefore, we're going to have to do the pagination and the sorting manually. If we had decided to use a separate Elasticsearch index for this, then we could rely on Elasticsearch to do the pagination and the sorting for us, or at least Elasticsearch combined with Spring Data Elasticsearch. However, this is one of the trade-offs for the simplicity of a nested object. We're going to have to implement this pagination and sorting behavior ourselves. So first we're going to need to get the restaurant object, and we can reuse our getRestaurantOrThrow method to do that, passing in the restaurant ID. And let's assign that to a variable, which we'll call restaurant. Let's now extract the reviews from the restaurant. So restaurant get reviews, and we'll assign this to a variable, which we'll call reviews. And that will just make handling a little bit easier. So let's determine how we're going to sort these reviews. So let's go pageable.getSort, and that will return our sort object. And that contains all the information on how we should sort the reviews. Let's just scroll down a bit. There we go. So let's work out whether or not the caller has provided sorting information. So we're going to say if sort is sorted, then we have some sorting information to work with. Now with the pageable object, a user can provide several means of sorting. However, in our application, we're only going to support one means of sorting. So that's to say a user can only provide one means of sorting per request rather than many. So if we say sort dot iterator, that will return an iterator of order, representing that you can have multiple orders per request. We're simply going to call next on that in order to get the next one in the iterator. And we'll call this one, if we refactor rename, order, and this will be the single order that we support. Now we'll need to know the name of the property that the user is trying to sort on. So for that, we can say order.getProperty, and we can assign that to the string variable property there. So this might be date posted, for example. Now, when it comes to sorting, you can either sort ascending or descending. So let's work out which one we have here. So we'll assign a Boolean variable, which we'll call is ascending, and we're going to call order get direction is ascending. So this will be true if we are returning the reviews in ascending order in relation to the property, false otherwise. So we know that the user has provided sorting in the request. We've extracted the sorting information. We've worked out the property that the user wants to sort on, and we've worked out whether or not the result should be in ascending order or descending order. Now we're only going to provide sorting based on two properties, and that's for our use case. So we're going to allow for sorting on date posted and also the rating in the review. And this will allow the user to do things like get the latest review or get the review with 5 stars or 1 star. So to do this, we're going to do a switch and we'll pass in the property. Now, when the property is date posted, we're going to return a comparator, simple that, comparing, and we'll say review, get date posted. Now, in the case that rating is the property the user wants to sort on, then we're going to return comparator, comparing, but this time it's going to be review, get rating. And the default is going to be, we'll return comparator, comparing, and we'll sort on get date posted. So what this means is when the property is date posted, then we will return this comparator for get date posted. When the property is rating, then we're going to return the comparator with get rating. And when the property is neither of these, so if the user has made a typo or tried to sort on a property we don't support, then we're going to sort on date posted. Now we're getting a yellow underline purely because this line here is the same as this line here, but I'm going to leave it as is for the sake of clarity. But you could very well delete this line and the functionality would be the same. To be clear, that's this line here. So let's assign the result of this switch statement to a variable, and we're going to call this one comparator. And now we're going to call reviews.sort, and if is ascending, then we're going to simply return the comparator. Otherwise, we're going to return comparator.reversed. And in this way, we're able to sort our reviews. Now, in the case that the user hasn't provided any sorting information in the request, let's support that in the else here. And we're simply going to say reviews.sort, and we're going to pass in comparator comparing, review, get date posted, and then we'll reverse that. And what this means is that we're going to return reviews, the newest one first. So that's our reviews sorted. We'll now need to handle the pagination, remembering that a user can provide both a page number and a page size. So we'll need to work out the pagination boundaries. So for that, I'm going to call pageable, get offset, and we're going to assign this to a variable, which we'll call start, but rather than a long, because we'll need an int in one moment, I'm just going to cast this to an int. There we go. So let's now handle the case where we have empty pages. So for example, we're being asked for a page which is greater than the number of records that we have to return up to that page. So if we say if the start is greater than or equal to reviews.size, then we're going to simply return a new page impl with collections, and we'll say empty list, pass in our pageable object, and then we'll also need to return reviews.size as the last argument to that method. So simply going to return an empty page, but we are going to provide information from our pageable object, and then we also need to provide the number of records that we have in total. So that handles the case where we have an empty page. Now let's work out when we don't have an empty page, when we're returning records. So in that case, we're going to work out the end. So we're going to want the minimum, so math.min, of either the start plus pageable get page size or reviews.size. So that's to say if the user is requesting a page size of 10, for example, and we only have 5 reviews, then the end is going to be 5. Otherwise, it's going to be the number that the user has requested. And now we can return a new page impl where we'll return a reviews sublist with the start and the end. We'll pass in our pageable object, and of course, we'll need to pass in reviews.size like we have done before. And this will return our page of reviews. So again, this might seem like a lot of work, and that's because it is. We're not able to rely on Elasticsearch in this instance. One of the trade-offs, we've been able to store reviews inside of restaurant, meaning that we only have to manage one index. However, it also means that we're not able to leverage Elasticsearch in quite the same way as if we had a dedicated index for reviews. So in summary, we implemented the list reviews method in the review service. We added sorting options for reviews by date and rating. We implemented manual pagination for those nested review objects. And that's because our reviews are retrieved from the restaurant document. In this lesson, we'll implement the REST API endpoint that enables users to list reviews for a specific restaurant. So here we are back in our IDE. Let's head to the review controller and let's expand this. Now we have our create review endpoint. Let's just minimize this for the moment. So let's add a second method to represent the list review endpoint. So this is going to use a HTTP GET verb. So we're going to use the GET mapping annotation. Public method returning a page of review DTO, let's import page, and we're going to call this method list reviews. As for the arguments to this one, we're going to need the restaurant ID, which is in the base path up here. So let's go ahead and place that into the arguments. In fact, let's put it on a new line. There we go. So now we're going to need our pageable information. Let's just take a look at how we've done things over on our restaurant controller. And let's expand that. So here on search restaurants, we're looking for the query parameter of page, and we're also looking for the query parameter of size. So this is a subset of the query parameters of a pageable object. Inside of the request here, we're then creating a pageable object. If we were to hover over this, we have page request, which implements pageable, and that's what we're passing to our search restaurants method, which expects a pageable. So with this approach, we're only explicitly looking for the page and the page size because we're not supporting sorting on the search restaurants endpoint. However, if we go back to our review controller, we are looking to support sorting on the list reviews endpoint. So in which case, we're going to make use of the pageable default annotation. And we're going to specify a size of, let's say 20. The page, which is 0 indexed, is going to start at 0. And we're going to sort by date posted. And the direction is going to be, in fact, before we fill that in, let's put this on some new lines so we can see what's going on. And the direction is going to be sort direction descending. There we go. And of course, we'll need to declare our argument, pageable, which we'll just call pageable. There we go. So what this will mean is that Spring is going to look for the size query parameter, page query parameter, and some sorting query parameters, including the property and the direction, and place them into this pageable. Where it doesn't find them, it's going to use these defaults. And then we'll be able to pass this full pageable object to our service layer. We didn't use this approach over on the restaurant controller because we weren't supporting sorting. So we didn't want that information populated in our pageable object. So with that done, let's call our review service and let's list our reviews, passing in our restaurant ID and our pageable object. So let's put this on a new line because this is going to return a list of reviews and we want a list of review DTOs. So we're going to say review mapper to DTO. And if we return this from our function, we're now returning a list of review DTO. So with that done, let's go ahead and start or restart our application. And now we can try this out in our browser. So here we are back in our browser. Now, in order to effectively test this, we're going to need multiple users because a user can only review a restaurant once. So to do that, if we take a look in Keycloak here, we go to the restaurant review realm, take a look at users. I've created a few different users, our original test user 2, and test user 3. And I've used these users to create reviews. We scroll down here on the Golden Dragon. We can see we have 3 reviews here, averaging 4 stars. So if we scroll down, we can see our reviews, review 1, review 2, and review 3. So let's open up the network panel. Let's refresh this page. There we go. Now it should be said that these reviews 1, 2, 3 on initial page load are populated from the reviews property inside of the restaurant. So if we take a look at the requests here we are. So this is a GET request to restaurants with a restaurant ID. If we look in the response, we have our nested reviews, review 1, review 2, review 3. And that's what the front end uses to populate the reviews on the initial page load. However, if we were to clear our network panel down, and if we were to scroll up here, we have this button which currently says newest first. If we were to put this to say, I don't know, oldest first, we can see that a request is sent. Let's take a look at this one. So we have a GET request to API restaurants, the restaurant ID, reviews, and then as sort query param, date posted, ascending. And that will return the oldest post first. So we look at the response here, we can see that this one was posted at 9:30. We scroll down, 9:34, 9:36. So in fact, the oldest one was returned first. If we now show the newest first, we can see that review 3 is now at the top. We take a look at the response. 9:36 is now at the top, 9:34, and then if we scroll down, 9:30. So it looks like sorting by date posted is working. If we were to look at the highest rating, we can see a request being sent here, but this time we have sort rating descending. And if we take a look at this visually, we have 5 stars, 5 stars, 1 star. If we were to choose to have the lowest rating first, we can see straight away we have 1 star at the top here. And we can see we have rating ascending as the sort. So that is going to return the 1-star review first. So it looks like our list reviews endpoint is working as expected. So in summary, we implemented the list reviews endpoint in the review controller. This method accepts sorting and pagination parameters. So let's recall what we've achieved in the review list module. In review list service, we implemented the list reviews method in the review service. We added sorting options for reviews by date and by rating. We implemented manual pagination for those nested review objects. And that's because reviews are retrieved from the restaurant document. In review list controller, we implemented the get restaurant reviews endpoint in the review controller. And we created an endpoint that accepts sorting and pagination parameters. In this module, we'll build a REST API endpoint that allows users to retrieve individual restaurant reviews. We need this functionality to populate the information on the update review page. This module is structured as follows. We'll first implement the review retrieval service layer, and then we'll implement the REST API endpoint for review retrieval. So for the learning objectives, by the end of this module, you'll be able to implement the necessary service functionality to retrieve individual restaurant reviews, and implement the REST API endpoint to retrieve a single restaurant review. So with that covered, let's get started. In this lesson, we'll implement the functionality to retrieve individual restaurant reviews in our service layer. We'll need to be able to retrieve individual reviews in order to populate the data on our edit review page. So here we are back in our IDE. So let's head over to the review service. Let's expand this. And now let's add another method. This one is going to return an optional of review. Let's import optional. And we'll call this one get review. It's going to take a string, which is the restaurant ID, and a second string, which is going to be the review ID. Remembering that we've given each view a random UUID as its ID. So let's head to the implementing class, hover over the red squiggle, implement those methods, click OK. And we now have our getReview method stub ready to implement. The implementation for this one is fairly straightforward. We'll first need to get our restaurant, so we're going to call getRestaurantOrThrow, passing in the restaurant ID, and we'll assign that to the variable of restaurant. And now we'll need to extract the very specific review that we're looking for. So let's say restaurant getReviews, and then we're going to say filter. So stream.filter r to represent our review, and we'll say review ID equals r get ID. So if the IDs match, that will be true. And then we can do find first, which returns an optional review. And then if we return this, let's just put that on a new line. We now are returning an optional review. We first get the restaurant, and then we match the review ID against any reviews with that ID. Of course, there'll only be one if it exists at all, and then we'll return that optional review. So in summary, we implemented getReview in the review service, and it returns an optional review to handle the times when the reviews don't exist. So now that we've implemented the service layer for retrieving individual reviews, let's now implement the REST API endpoint. So here we are back in our IDE. Let's head over to the review controller, expand this, and let's minimize list reviews to make it better space. And now let's get to implementing our getReview endpoint. This is going to be a get mapping, and the path for this one is going to specify the review ID in addition to the base path that we have here. So let's say / set of braces, and we'll say review ID. We'll declare the method signature public, returning a response entity of review DTO, and we'll call this one get review. So we'll need to get hold of the restaurant ID from the base path, so we can borrow that path variable declaration from up there. If we were to paste that again and change this to be review ID, we now have access to both the restaurant ID and the review ID from the path. So let's call review service dot get review, passing in the restaurant ID and the review ID, and that will give us an optional review. So we need to handle the case where the review exists, converting it into a review DTO, and also the case where it doesn't exist, returning a HTTP 404. So we'll say .map review mapper to DTO for the case where it does exist, and then we're going to map once more, and let's return a response entity .ok, and for the case where it doesn't exist, let's say or else get, and we're going to return a response entity no content .build. There we go. And if we return this, we now have implemented our endpoint to get a review or return a HTTP 404 if it doesn't exist. So let's try this out. Let's start or restart our application. That's the application started up fine, so let's head over to our browser. So here we are back in our browser. Here's all of our restaurants. So let's go to the golden dragon here, which has reviews on there. And I'm logged in as the test user. So I'm going to look for the review created by test user, which is this one here. So let's open up our networks panel and let's click on the edit review button. So we have some information here. So we have the rating, the content of the review, which was review 1, and the photo that was uploaded. Let's take a look at the requests. So we have here a HTTP GET, HTTP 200 response, API restaurants, restaurant ID, reviews, review ID. And if we take a look at the response, we can see that the review has been returned in the form of a review DTO to the user. So it looks like our getReview endpoint is working as expected. So in summary, we implemented a get endpoint for our single review retrieval, and we used a response entity to handle the found and not found cases for our review. So let's recall what we've achieved in the review retrieve module. In review retrieve service, we implemented the getReview method in the review service, and it returns an optional review to handle missing reviews. In review retrieve controller, we implemented the get endpoint for a single review retrieval and used a response entity to handle both the found and not found cases. In this module, we'll implement the functionality to allow a user to update their review after they've created it. We'll also do some additional validation, making sure that the user that is attempting to update the review is actually the review's author. And we'll also check to make sure that we are within that 48-hour window in which updating reviews is allowed. So the module is structured as follows. We'll start by implementing the update review functionality in the service layer, and then we'll implement the update review REST API endpoint. For the learning objectives, by the end of this module, you'll be able to implement the necessary functionality in the service layer to update a restaurant review, and implement the REST API endpoint to update a restaurant review. So with that covered, let's get started. In this lesson, we'll implement the functionality to update restaurant reviews in our service layer. So here we are back in our IDE. Let's head to the review service interface and let's expand this. So to this interface, we're going to add an additional method. This one returning a review, and we'll call this one update review. And we're going to pass the user, which is the author of the review, a string, which is the restaurant ID, a string, which is the review ID, and our review create update request, which we'll just call review. This is a full update method, so whatever's in Elasticsearch will be completely replaced with whatever information is provided in review. So let's go to the implementing class, hover over the red squiggle, and then we go implement methods, OK, and now we have our method stub ready to implement. So the first thing that we'll want to do is get the restaurant. So we'll say get restaurant or throw, passing in the restaurant ID. If that exists, we can assign that to the variable restaurant. Otherwise, we'll get an exception that our error controller will handle. Although we'll not be implementing full-blown authorization, let's just do a quick check to make sure that the user that wrote the review in the first place is the same user that's trying to update it. So let's extract the author.getID in order to get the user ID. Let's call that author ID. So we'll now need to get the review. So we can follow a similar pattern that we've done up here. We could very well extract this to a private method. So let's do so now. Let's go hover, extract, method, and we'll call this one get review from restaurant. Okay, replace. There we go. So we can now use get review from restaurant in order to get the review. So we need to pass in the review ID and the restaurant, and that will give us back an optional review. So what we'll do is we're going to call or else throw a new review not allowed exception, because we're attempting to update a review that doesn't exist. So we'll say review does not exist. And this is a lambda, of course, so we'll need to put the, there we go. Now we could very well use a separate custom exception for this. However, this particular exception is close enough for our case, and it will return a HTTP 400 to the user, so that should work for us. So we'll assign this to a variable now, and we'll call this one existing review. So now we'll say if existing review dot get written by get ID, and we'll compare that to author ID. So we'll say author ID equals, and then we'll put the exclamation mark in front of that, say not. So we'll say if the ID of the author does not match the ID of the author that wrote the review, then we are going to throw a new review not allowed exception, and we'll say cannot update another user's review. So now that we've done a quick check for the user, let's now make sure that we're in that time window. So the requirement is that the user can update review within 48 hours of raising it. So let's say if local datetime.now is after, and we'll say existing review dot get date posted, and then we'll plus hours 48. Then we're going to throw a new review not allowed exception, and we'll say review can no longer be edited. There we go. So if the current time is after 48 hours of when the date was posted, then the review is not allowed to be updated. Otherwise, we'll now need to update the review. So we'll say existing review dot set content from review get content. So that will update the text content of the review. And now we'll say existing review set rating review get rating. And then we're also going to say existing review set last updated or set last edited to be local datetime.now. Now the user may have also updated the photos. So we're going to existing review dot set photos, and then we'll need to go review get photos, and then we'll stream because we have just photo IDs at the moment, map photo ID, and then we'll go photo builder.build, and then the URL will be the photo ID, and then the upload date will be local datetime.now. And then let's remove the braces so we don't have to use return. And let's return this. And we need a semicolon. And then we'll need to collect this to a list. In fact, let's remove the return there. There we go. So that will update the photos. Again, not a very refined approach to this photo handling. However, it will work for our purposes for the moment. This would be a great opportunity to extend the system, perhaps using a third-party image service. So now that we've updated the photos, let's also update the restaurant's average rating, because that may have changed. So we'll say update average rating, passing in the restaurant. So now we'll need to update the restaurant's reviews. So the way we're going to do this is we're first going to get hold of all of the reviews, except for the one that we've just extracted and updated, and then we're going to include the updated version of that review before saving. So first, let's get the list of reviews, excluding the one that we've just updated. So we'll say restaurant, get reviews, and then we're going to stream and filter, give that restaurant the name of R, and then we're going to filter where the review ID, and we'll say initially equals r.getID, and then we'll put an exclamation mark on there to say doesn't equal. In fact, let's remove these braces. There we go, and let's put this on a new line. So we filtered out all reviews where the ID matches the review ID. So let's collect this to a list, and I'm going to do collect and then collectors, and we'll say to list, and that will give us a list that we can modify. And we'll say updated reviews. And now we're going to say updated reviews, and we're going to add to this the existing review, which is the one that we've updated. And now we'll say restaurant.set reviews, updated reviews. And now we can save, scroll down. Now we can save our restaurant repository.save. And now we'll need to extract the updated review. Although perhaps the easiest way to do that is simply for us to return the existing review. So here we have our first implementation of update review. So we get the restaurant, we then work out the ID of the author, so the user that's attempting to update the review. We get the review from the restaurant. We make sure that the user that's attempting to update the review is actually the author of that review. We make sure that we're within the 48-hour window that a user can update their review. And then we go about updating the review, updating the content, rating, last edited, photos, updating the average rating of the restaurant. Although in retrospect, we should do this after we update the restaurant reviews. So we create a new list with all the updated reviews, set that on the restaurant, update the average rating of the restaurant, save the restaurant, and then we return the updated review. So in summary, the service implements review updates with ownership verification and time restrictions. Reviews can only be edited within 48 hours of posting. Photos and ratings are updated along with review content. And the restaurant average rating is recalculated after updates. We'll now implement the REST API endpoint that will allow a user to update their review. So back in our IDE, let's head to our review controller here and let's expand this. So we have our get review method. Let's minimize that. And let's now add another method. This is a full update endpoint. So we'll be using HTTP put. And the path for this one is going to include the review ID. So we're going to say review ID within braces. Public method, returning a response entity of a review DTO, representing the review that was updated. And we'll call this one update review. As for the arguments, we'll need both the restaurant ID and the review ID. So we'll borrow those from our get review method. And we're also going to need the review create update request, which we'll call review, which represents the review information that we want to update. And we're going to put the request body annotation on this because we'll get that from the request body. And then we'll also put the @valid annotation on that as well to trigger those validation annotations. However, it's not the review create update request, but the review create update request DTO that we'll be expecting, because we'll now need to map the create update request DTO to a create update request, which we can then pass to our service layer. Before we do so, however, let's extract the user, because we'll also need to pass that to our service layer. So for that, we're going to add another argument. We're going to borrow this one from up here, authentication principal JWT to get hold of the JWT. And we'll place that after our review create update request. And now we can call our private method down here, JWT2User, passing in our JWT. And now we have the user that's calling this endpoint. So this should be enough information for us to call our service layer now. So we'll say review service dot update review, passing in the user, the restaurant ID, the review ID, and the review create update request. And this should return to us an updated review, or it will throw an exception. Let's put this on a new line so we can see everything. And now with our updated review, we're going to return response entity .ok, and then we'll call our mapper to DTO, passing in the updated review, and we can return that to the caller. And with that, we have our initial implementation of our update review endpoint. So let's start or restart our application and try this out. There's our application restarted, so let's head over to our browser. So here we are back in our browser. So let's go looking for the golden dragon because that already has reviews on there. Here we are. If we scroll down, we can see review 1, review 2, review 3. Now I'm currently logged in as test user. So I'm going to attempt to update the test user review, expecting it to allow me to update it. So there's our network panel. Let's click on add it. Great. So here we are. So I'm going to change my review to be 2 stars. I'm going to say review 1 updated. And I'm even going to update the photo, I think. Let's choose this one here. There we go. So as I am the author of this particular review, it should allow me to update this. So let's clear our network panel and let's click on update review. We have a 400. Let's see why. Specify review cannot be updated or created. Let's check our console out. Cannot update another user's review. So I may not be logged in as the correct user after all. So let's try this again. If I scroll up here and I log out, I'm now successfully logged out. If I log in, test user, password, I'm successfully logged in. So if I now go to the golden dragon and I go down to the reviews, find the test user review, edit, and we'll say review 1 updated, change the rating to 2 stars, delete this photo, upload a new one, clear the networks panel, and then try updating the review. It's allowed me to update it. So it looks like I wasn't logged in as the correct user after all. So let's go find the golden dragon. Here we are. If we scroll down, we still have 3 reviews. Review 2, review 3, review 1, updated. 2 stars, different picture. It would be at this point that I tried to update a review with a user that didn't write it, but as we've already accidentally tested that, it looks like our update review endpoint is working as expected. So in summary, we implemented the endpoint for review updates, and we reused the JWT2User private method to pass the user to the service layer. So let's recall what we've achieved in the review update module. In review update service, the service implements review updates with ownership verification and time restrictions. Reviews can only be edited within 48 hours of posting. Photos and ratings are updated along with the review content, and the restaurant average rating is recalculated after the updates. In review update controller, we implemented the endpoint for review updates, and we reused the JWT2User private method to pass the user to the service layer. In this module, we'll implement the functionality to allow a user to delete a restaurant review. The module is structured as follows. We'll start by implementing review deletion in the service layer, and then we'll create the REST API endpoint for review deletion. For the learning objectives, by the end of this module, you will be able to implement the functionality in the service layer to allow a caller to delete a review, and implement the REST API endpoint which allows a caller to delete a review. So with this covered, let's get started. In this lesson, we'll implement the functionality to allow a user to delete a review. So back in our IDE, let's head to the review service here and let's expand this. So to the review service, we're going to add one more method. This is going to be a void method called delete review. And it's going to take a string, which is the restaurant ID. And it's also going to take a second string, and that's going to be the review ID. Now, as we're not doing authorization in this service, we're not going to pass in the user. Otherwise, we could use that in order to check that the user who wrote the review is attempting to delete it. But instead, we're just going to leave this method open for the moment, and you can consider the authorization and extension of this exercise. So with the new method in play. Let's now go to the implementation, scroll to the top, hover over the red squiggle, go to implement methods and click on OK. So first thing we'll need to do is get hold of the restaurant. So we'll use get restaurant or throw, passing in the restaurant ID, and we'll assign that to a variable which we'll call restaurant. So now we're going to filter out all reviews with the provided review ID. So we're going to say restaurant, get reviews, stream, and then we'll filter, we'll say R, where the review ID equals r.getID, and then we'll put that exclamation mark on the front, and then we'll call to list. We'll assign this to a variable, and we'll call this one filtered reviews. So now that we have a list of filtered reviews, filtering out all reviews which match this review ID, which may be one or may not be any, let's now set the reviews on the restaurant.setReviews, filtered reviews, and now we can save the restaurant. So we'll say restaurant repository.save restaurant. However, there is a missing step here. When we remove the review, we'll need to update the average rating. So we'll say update restaurant average rating for the restaurant with the updated reviews. And as it's a void method, we don't need to return anything. So this should do it. We first get the restaurant. We extract the reviews from the restaurant, filtering out all reviews where the ID matches review ID. We then set those filtered reviews on the restaurant, update the restaurant's average rating using the new filtered reviews, and then we'll save that restaurant in Elasticsearch. So in summary, review deletion is handled through the delete review method in the review service, and the implementation removes the review and updates the restaurant's average rating. In this lesson, we'll implement the REST API endpoint to allow a user to delete a review. So here we are back in our IDE. So let's head to the review controller here and let's expand this. So let's minimize our update review endpoints and let's add a new endpoint here. So this one is a delete mapping using the HTTP verb delete. And the path for this one is going to specify the review ID. So that means we can get access to both the restaurant ID and the review ID. So let's go public, returning a response entity of void because it won't have a body. And we'll call this one delete review, pasting in our restaurant ID and review ID path variables. And now we can get to implementing our method. And we should just need to call our review service, delete review, passing in our restaurant ID and our review ID, and then we can return a response entity dot nocontent dot build. And with that, we've implemented our delete review endpoint. So let's start or restart our application. There we go. That's our application restarted fine. So let's head over to our browser. So here we are back in our browser. So let's go looking for the golden dragon where we've placed our reviews. Still logged in as test user. So if we scroll down to review 1 updated here, I'm going to open up the network panel. Let's pull this down. And I'm going to attempt to delete this review. Now I could delete any of the reviews because we haven't implemented authorization for review deletion. However, for the time being, let's just try deleting review 1. Are you sure you want to delete this review? Yes, we do. Okay, so let's take a look at the request here. So we have a 204 no content, HTTP delete to restaurants, restaurant ID, reviews, review ID. Of course, there's nothing in the response. It's a 204. Let's just go looking for review 1. So we have review 2, review 3. But no, we don't have any other reviews. So it looks like the review was deleted successfully. So in summary, we added the delete review endpoint using the @delete mapping annotation because we're using the HTTP verb delete. The method accepts a restaurant ID and a review ID as path variables and returns a HTTP 204 status code on a successful delete. So let's recall what we've achieved in the review delete module. In review delete service, the review deletion is handled through the delete review method in the review service. The implementation removes the review from the restaurant and updates the restaurant's average rating. In review delete controller, we added the delete review endpoint using the delete mapping annotation. The method accepts a restaurant ID and review ID as path variables and returns a HTTP 204 status code on a successful delete. Congratulations on making it to the end of the build. I hope you found this truly valuable, and you now have a solid base to build on if you want to extend the system further. Now, if you want to be notified when the next build comes out, be sure to subscribe and hit that bell icon. And in the meantime, why not check this out?